Good evening, everyone. Welcome to Gate Academy Global. So just confirm me audio and video, both quality audio and video, both is perfect or not. Okay, everyone, just confirm me audio and video, everything is perfect. So today we are going to start our revision marathon for the digital electronics. Okay. So everyone, good evening. Just confirm me. Okay, and please like the session. Everyone like the session and share the session. Okay, so just confirm me audio and video, both quality is perfect or not. Okay, just confirm me audio, video, everything is perfect. Okay, everything is perfect now. So today we are going to start digital electronics and I will try to cover all the topics. Okay, I will try to cover all the topics. Okay, so first topic basic I am going to start. Okay, I am not going with number system especially. One important thing just I want to ask you from the, you can say, number system, but that will be useful for electrical, IN and electronics, all the student. Okay, so now I am going to start from here. So the subject name is our digital circuits, you can say, or digital electronics. Okay, now here first important thing I want to discuss here, what is the two's complement and what is the one's complement, everyone know. Okay, so just I want to tell you, sir, what is a one's complement of any number x? So what is a one's complement of any number x? So you know this thing, sir, plus x is nothing but plus x. Okay, and minus x, what you will write, this is nothing but minus x complement. Okay, so sorry, plus x complement, you will write plus x complement. This is a one's complement form, and we know this thing, this is a, you can say, one's complement form. One's complement form. Okay, now many where this is required in whole digital electronics. So we know this thing very well. Now the second important thing, sir, what is two's complement form? What is two's complement representation of any number? So if suppose this is plus x, so you will write that is nothing but plus x, and if this is minus x, what we will find out, one's complement then plus 1. Okay, so one's complement, how we can find out? First plus x, then complement, then plus 1, then plus 1. Now here some shifting operation is very important. Here shifting operation is very important in digital electronics. So if I will ask you, what is the difference between, suppose I am going to write 0001, this is 4-bit data, what is corresponding decimal? We know this thing, this is 1, and if I will shift this bit left, 0010, so what will be this 2? If I will shift this bit here, so this is 0100, this is 4, in I will shift this data here, this is 100, this is 8. So can I write, so this is either one's complement or two's complement, because this is a positive number representation. This we are using for positive number. So all these are the, we are considering positive number. But sir, what will be happen for the negative number? Sir, what will be happen for the negative number? So just I am asking first question. So here our first problem is, suppose if we have a 4-bit data, suppose we have one data n and the data n is 4-bit, A3, A2, A1 and A0. Suppose I am considering 4-bit data. Suppose I am considering 4-bit data. Okay, now if I am going to shift one left, so suppose if a new number, so this is n new, so just I am writing n new is 5-bit. So this 5-bit is A3, this is A2, okay, and this is A1 and this is A0, and one more bit I am going to add here, 0. So suppose if this bit value is n in decimal, suppose this n in decimal, so A3, A2, A1, A0 value is n, and A3, A2, A1, A0, and this is 0, then what will be this value? So if you will compare this two, if you are going to shift this left, so the data is going to be multiplied by 2. Can I write? Yes. If this data is 1, so this is going to multiply by 2 here. If this one is going to shift one left, again this is going to be multiplied by 2, again going to be multiplied by 2. So can I write in this way? Yes. So if I will ask you, what will be the n new? what will be the n nu? So can I write n nu will be 2n? So can I write n nu will be 2n? Is this correct or wrong? Is this correct or wrong? Anybody can tell me, sir, this one is correct or wrong? This one is correct or wrong? So n nu will be 2n or not? N here n nu will be 2n or not? N nu will be, yeah, good evening everyone. N nu will be 2n or not? N nu will be 2n or not? Tell me, just think about this. Just think about this. So from this topic, digital electronics exactly will start, and you should know this thing very well. You should know this thing very well. Okay, now before going to conclude this, first I want to tell you, sir, in one's complement form, or in two's complement form, in both you can add number of bit at MSB side. So data will not be changed. So suppose for example, if n is A3, A2, A1, A0, so this thing you should know, sir, again n will be this A3, I can copy A3, this is A2, A1, A0. We can write in this way. So this is 4-bit representation. This is 4-bit and this is 5-bit. This is 5-bit representation. Suppose if I am saying this is n1. Sir, n and n1 will be same or different? Both will be same if this is representing in one's complement or two's complement. So one thing you should know, if we have any number, this is a 4-bit number. So this is a 4-bit number, and if you want to write any 4-bit number into 5-bit, 6-bit, 7-bit number, so this MSB you can copy n times. Any number of times MSB bit can be copied. Data will not be affected. So this is a 5-bit representation, and this A3, this A2, A1, A0. So both of the data is same. So what we can say, sir, here n and n1 are same. Here n and n1 are same. This first important point you should remember. So in one's complement or in two's complement, MSB bit can be copied n number of times. Now this was my question, but here I have not copied the MSB bit. Here just I have shifted 1 bit. Now I am asking, sir, n nu will be 2n or not? N nu will be 2n or not? Tell me the answer, yes or no? This is correct or wrong? So here, right now you cannot say. Right now you cannot say the exact answer. You cannot say the exact answer. Now, sir, this n is a one's complement form or two's complement form. Sir, this n is a one's complement form or two's complement form. So we can say, sir, if this n is a two's complement form, if this n is a two's complement form, it can be positive number or it can be negative number. It can be positive number or it can be negative number. So if you will shift this, so definitely n nu will be 2n. Then n nu will be 2n. Now I am writing, sir, if this is 1, if this bit is 1, then what will be happen? So if you will shift this bit here and if you will add here 1, so this data will be this multiply by 2 plus 1. Can I write? This is 2 plus 1. If you will put here 1, so this will be nothing but 4 plus 1. If you will put 1 here, so this will be nothing but 8 plus 1. So now if I am going to put here 1, now I am asking, sir, this data will be 2n plus 1 or not? This data will be n will be 2n plus 1 or not? Yes, this will be 2n plus 1. But the important thing is, sir, this should be 2's complement form. This should be 2's complement form. So one important thing you should remember, in 2's complement form, if you will shift the data left side, it will multiply by 2. If you will shift the data right side, it will divide by 2. It will divide by 2. And MSB bit can be copied n number of times. MSB bit can be copied n number of times. This is the important point. Now the question arises here, sir, if this is a one's complement form, then this will be true or not? So here this is valid for 2's complement. This is valid for 2's complement. But this is not valid for one's complement. This is most important thing. And IIT Kharagpur can ask you this category of question. Definitely they can ask you. So if anybody will ask you, sir, what is the advantage of 2's complement over 1's complement? You know very well many number of Now this is the most important thing. In 2's complement, shifting operation easily you can perform. N can be positive number or n can be negative number. Especially complement, for negative number generally we will use. For positive number that is not required. For positive number, basic number system you can use. But for negative number, this complement method generally we will study. So generally we study 1's complement and 2's complement form. Generally we studied two types, 1's complement and 2's complement. So this is the most important thing for 2's complement. Suppose if this data is minus of 2, suppose for example, if this data is minus of 2, here this is n, then sir what will be this value? So here this n will be minus of 2 into 2 plus 1. So this will be minus of 2 into 2 minus 4 plus 1. So this is minus 4 plus 1 is equal to minus 3, is equal to minus 3. So the most important thing, you remember this thing, this shifting operation, left side shift or right side shift. In the register we will study shifting operation, shift register we will study. Okay, so this is most important thing, and definitely they can ask question from here. So remember, this will be valid for 2's complement, but this will not be valid for 1's complement. You can check any value, you can check with any value. Okay, so right now just directly you should remember this thing. Two important thing you should remember: in 1's complement or in 2's complement, this MSB bit can be copied any number of times. MSB bit can be copied in both the format, but shifting operation will provide you exactly multiply by 2, divide by 2. This thing will be exactly provided by only 2's complement, not by 1's complement. Okay, so this basic thing you should remember here. Okay, so I hope this thing is clear to all of you. Okay, you can check with any value easily, you can calculate 1's complement and 2's complement. Okay, so directly examiner can ask you the question from here. Okay, so what exactly examiner can ask you the question? This A3, A2, A1, A0 is a 2's complement number, and they can provide you this. Then what will be the value of this n? So first you can see they are asking 2's complement. Yes, then directly you can write this value is shifted 1 left. This will be multiplied by 2, and they are putting here 1. So this is 2n plus 1. But if the question will change, if this is 1's complement form, then don't remember directly. If examiner will ask you for any example, you can put the value and you can find out the value. Now if I will ask you what is the difference between 2's complement and 1's complement, if I will ask you what is the basic difference between 1's complement and 2's complement, so for positive value 1's complement and 2's complement is both are same. So for 1's complement, here two answer can be possible. If this n is positive, so if n is equal to positive, then this will be 2n plus 1. But if this n is minus n, negative, so I can write if n is negative. In this case, answer will not be 2n plus 1, because 2n plus 1 is 2's complement. So what is the relation between 1's complement and 2's complement? You can see, if this is minus x, 1's complement you are writing 1's plus x complement, and now in 2's complement minus x you are writing this is 1's complement plus 1. So what is the difference between this? Positive number is same. In both. So for positive number you are getting same in both. So suppose if n is positive, so in 2's complement form this is 2n plus 1, and in 1's complement also this is 2n plus 1. But if n is negative, so definitely there will be difference between here. So here if this is minus x, so this is 1's complement plus x complement, but here plus x complement plus 1. So here 2's complement number is one more than 1's complement number, one more than. So how you can find out from this number 1's complement? So if this is a 2's complement number, and suppose here if n is negative, so you are getting this answer is negative. If this answer is negative, then what will be the 1's complement? 1's complement. If this is 2's complement, so 1's complement, just you have to subtract 1 from here. So what will be the answer here, sir? 2n plus 1 minus 1. So this answer will be 2n. This is the basic difference between 1's complement and 2's complement. So in 1's complement form, for positive value you are getting 2n plus 1, but for negative value you are getting 2n. But for 2's complement form, you are getting for positive and negative both 2n plus 1. This is the most important thing. That's why everywhere in whole digital electronics, if you want to represent positive number as well as negative number, always which method you will use? 2's complement form. Which method you will use? 2's complement form. 2's complement form. So this concept examiner can use in your sequential circuit, in register also, in counter also. So examiner generally right now they will provide you the value 1000. Now examiner can provide you if the number is a 2's complement representation, if number is 1's complement representation, and that number is going to be shift. So at least you should know the shifting operation in 1's complement and 2's complement. This is most important concept. Now, okay, so this thing you should know. Now I am going to start concept from logic gates. Okay, so this thing you should know from the basic number system. Okay, now, and this will be important for all the students. Okay, so this especially you should know this thing. This value is 2's complement 2n plus 1, but in 1's complement, if n is positive then 2n plus 1, but if n is negative, this is 2n. This is 2n. Okay, now second chapter I am going to start. Okay, so that is logic gate. That is logic gate. Okay, that is logic gate. Okay, and this thing many where we can use. Now I am going to start logic gates. Logic gates. Okay, logic gates. So in logic gate, the most important gate is you can say especially XOR gate and XNOR gate. Okay, so generally examiner will target question from either NAND gate or XOR gate. These two gates are very important. XOR and XNOR near about both are same. So NAND gate, universal logic gate, and special function gate, these two gates are very important. Okay, so now the second important thing is here. Second important thing is the in logic gate. Okay, so first I want to revise some basic part from the logic gate. Okay, so which logic gate exactly we will study here? First logic gate is a NOT gate and a buffer. NOT gate and a buffer. Okay, this is the first logic gate. Here generally student will skip the buffer, but buffer is also a very important topic. Second logic gate is here AND gate and OR gate. AND gate and OR gate. Third logic gate we have to study here. This is the basic logic gate. All this you can say, all this is nothing but a basic logic gate. This is a basic logic gates. Can I say yes? Next one is universal logic gate. This is NAND and this is NOR. NAND and NOR is the universal logic gate. Universal logic gate. But here one important thing you should remember, already in previous year they have asked question from here. Two more gate are the universal logic gate. Suppose I am writing this gate, okay, and one more gate if we are considering this is a OR gate. So these two gates are also a universal logic gate. You remember this thing. So if how many number of universal logic gate? So total 4 number of this one is NAND. Sorry, this one you can say I can write here. This is NAND, and one more gate. This is nothing but a NOR gate. So these 4 logic gates are universal logic gate. Examiner already has asked question from this two. Okay, so how many number of universal logic gate? 4 number of universal logic gate. This is called NAND, this is called NOR. You can write any name here. Okay, so generally examiner will not write here name, they will provide you the circuit. Now the next one is a special function logic gate, that is nothing but XOR and XNOR. So XOR I can also write in this way, XOR and XNOR. So this number of logic gate you should know. Clear this point? Okay, so this number of logic gate you should know. Okay, sir, this class is important for CSE. Yes, sir. CSE student can also attend. This will be also important for CSE. Okay, and definitely you will get direct questions in your CSE exam also. Okay, so now come to the point. So first gate, if I am going to start, sir, which gate first I have to study? If my question to you, sir, first we have to study NOT gate or first we have to study buffer? Sir, first we have to study buffer or first we have to study NOT gate? So if just I am going to write here 2 gate, this is a 2 gate, you can call this is a special function logic gate. This is a special function logic gate. This is a special function logic gate. So now here first one is the NOT, and second one is the buffer. Second one is the buffer. So sir, how we can implement buffer? How, if your question arises, sir, how we can implement buffer? So buffer will be implemented by NOT gate. That's why first you should know about the NOT gate. Then only by using NOT gate buffer can be designed. Buffer directly you cannot design. So how you can represent NOT gate? This is a NOT gate. This is very basic gate. Everyone know this thing. And how you can represent? Sir, this is the buffer. This is the buffer. So now how you can implement smallest buffer? If I will ask you how you can implement a smallest buffer, so buffer will be implemented by minimum 2 number of NOT gate. So by even number of NOT gate you can implement the buffer. So if I am writing sir delay of this NOT gate, suppose this is a TPD. So propagation delay of this NOT gate is TPD. So definitely what is a propagation delay of this? This is 2PD. Can I write? This is a 2PD. So one thing you should remember, propagation delay of buffer. Propagation delay of buffer is always greater than propagation delay of NOT gate. Propagation delay of NOT gate. Many time in many circuit examiner can use buffer. Examiner can use buffer. So I hope this thing should be very much clear. So NOT gate we know very well. NOT gate we know very well. Suppose if this is X, so what will be the output is X bar. And what is the buffer? So buffer output is nothing but directly we can represent, if this is X, this will be X. But after how much time you will get X? After how much time you will get X? After propagation delay of buffer. And now what is the use of buffer? If anybody will ask you, sir, what is the use of buffer? What is the use of buffer? To provide propagation delay in any circuit. So to provide extra delay, if you want to provide extra delay without going to change your Boolean function, just you can connect the buffer. What will be the truth table here? This is X, this is X bar. If this is 0, this will be 1. If this is 1, this will be 0. So if I will ask you, is there any majority input? What is a concept of majority input? If any input is decided, then output will be decided. So here only one input. So here no concept of any majority input. In 2 input logic gate, I will discuss majority input concept. Okay. So here what will be the truth table? Sir, this is X, this is X. This is 0, this is 0, this is 1, this is 1. If you want to write Y, so Y will be X. If you want to write here Y, so this Y will be nothing but X bar. Okay. Now, sir, what is the use of this NOT gate and what is the use of this buffer? So here one important thing you can see. Okay, so first I will discuss the concept of NOT gate. Okay, what question examiner can ask you? What question examiner can ask you exactly from the NOT gate? So if even number of NOT gate connected in cascade, then what will happen? So if sir, one NOT gate, this is second NOT gate, this is third NOT gate, and this is fourth NOT gate. So just I am saying here even number of NOT gate. So if even number of NOT gates are connected, and the input is X, then Y output will be again same. Output will not be modified. Only circuit will provide you delay. So what will be this delay? So always how you can handle this? If even number of NOT gate are connected in cascade, so just you can represent that single buffer. So this and this will cancel, this and this will cancel. So first you will write single buffer. And if this propagation delay is tau PD, this is tau PD. Suppose this is tau PD, this is tau PD. So examiner will sometime can write TPD time, or sometime they can use tau PD. Okay, so what was this total this delay? 4 times of tau PD. If this is X, then output will be X. Okay, so if even number of NOT gate are connected in a cascade, so your output will not be modified. Only this circuit will provide you extra delay in the circuit. Now the next question. Now if this NOT gate are connected in cascade, odd number. So here if this is the odd number, and if this is odd number, and now the input is X, then what will be the output? Output will be y is equal to x bar. So output you are getting complement. But sir, what is the use of this, sir? What is the use of this? Here if you will connect this output to input, if you will connect this output to input, then something can be changed. If you will connect this output to input, then what will be the happen here? So suppose if this x is 0, then what you are getting, sir? Y is 1. Then after some time, again this will be 0. After some time, again this will be 1. After some time, again this will be 0. So if odd number of NOT gates are connected and if output is connected to the input, this circuit will provide you unstable output. So here output is unstable. Here output is unstable. Here output is unstable. And here if suppose initially 0, then 1, then 0, then 1, then 0, then 1. You will get like this. Now, sir, this is nothing but a one kind of square wave. Yes, you can say, sir, this is a square wave. This is a square wave, not symmetrical. This is asymmetrical. 1 and 0. This is your 1. This is 0. This is 1. This is 0. This is 0. So now here examiner can ask you, what is the output signal you are getting a square wave? What is the time period of that? And what is the frequency of that? So how you can handle this question in GATE exam? How you can handle this category of question in GATE exam? So once you can apply this concept. First, odd number of NOT gate you have to replace by one number of NOT gate. So what you will do here, this is a odd number of NOT gate. This should be replaced by single NOT gate. So what you will do always, if odd number of NOT gate, so just that will be replaced by this is single number of NOT gate, and this output is nothing but this is x bar. You can write in this way. Now here if propagation delay of one NOT gate is, suppose this is tau PD, this is tau PD, this is tau PD. So what is total propagation delay of this NOT gate? So directly you can write, sir, 3 into tau PD. So after every 3 tau PD, 3 tau PD, you will get change, output will change 0 to 1, 1 to 0, 0 to 1. So if initially this was 0, this will be 1, then this will be 0, this will be 1, this will be 0, this will be 1. What will be this duration? This duration will be the propagation delay of this NOT gate. So this is nothing but 3 tau PD. Sir, what will be this time? This will be again 3 tau PD. What will be this total time? I can write this is a T clock. This is nothing but one kind of clock. Or you can write, sir, this is a T. What will be the T? This is 6 times of tau PD. What will the frequency here? 1 by T. This is nothing but 1 by 6 into propagation delay of one NOT gate. So 1 upon 2 into tau of PD. So sometime a student will remember directly this formula. So 1 by 2 into n into tau PD. So sometime directly student will remember this formula. So 1 upon 2 into n is the number of NOT gate and tau PD is the propagation delay of one NOT gate. But if examiner will provide you different propagation delay. But if you remember this formula, and if examiner will provide you, this is first NOT gate, this is second NOT gate, this is third NOT gate, and this is connected here, and this is the output. This is the output. Suppose this delay is 2 nanosecond, this is 3 nanosecond, and this is 5 nanosecond. Suppose this delay is 2 nanosecond, 3 nanosecond, and 5 nanosecond. Then in this case, 2 plus 3 plus 5. So what you will do, sir, one NOT gate you will get like this, and this is the output. And what is the propagation delay of this NOT gate? 3 plus 2 plus 5. This is 10 nanosecond. So you can draw here, sir, for after every 10 nanosecond, output will be changed 0 to 1 and 1 to 0. So what will be this time period? This time period will be 20 nanoseconds. So frequency will be 1 by 20 nano. So what will be the frequency? Time period is 20 nanosecond, then frequency will be 1 upon time. So like this you can handle. Don't remember directly any kind of direct formula. Okay, so this thing you should remember from NOT gate and buffer. So in general, not always buffer propagation delay is 2 times of propagation delay of NOT gate. So buffer will be implemented by NOT gate. So NOT gate have two advantages, two you can say application. First one is design buffer. If even number of NOT gate are connected, and second, unstable, or you can say one oscillations you can get at output if odd number of NOT gate are connected and output is connected to the input. Okay, so from here questions will be definitely asked in GATE exam. Okay, so this thing you should know. Now third important point I want to discuss here. Now third important point I want to discuss here. Sir, it works. Okay, third important point I want to discuss here. Okay, this thing you should know. Now sometime examiner will provide you tri-state buffer. Examiner will provide you tri-state buffer. So what do you mean by tri-state buffer? Sometime examiner will use tri-state buffer. Okay, tri-state buffer. So this tri-state buffer you will get in between in any question. So you should know exactly, sir, what is the tri-state buffer. So this tri-state buffer we will represent in this way, and here we can use one enable signal. So if this is X, what will be the output? Output will depend on the enable. If enable is 1, so here if you will draw this table, sir, this is X, and if this is the enable signal, what will be the output? So if enable is 1, X is 0 and X is 1, then Y will be 0 and Y will be 1. If enable is 1, but sir, if enable is 0, then X can be anything. What will be the output? Output will be, you cannot write here don't care. If enable is 0, means this buffer is not enable, then sir, what will be the output? Output will not be 0, will not be 1. Output will be nothing. Don't write here, don't care. So here output is nothing. And in digital electronics we call this state is called high impedance state. This is sometime called HZ state, sometime also called, this is nothing but high Z state. And this is sometime you can also say, sir, this is high impedance state. So in high impedance state means you don't have any data. 0 is also a data, 1 is also a data. So here you don't have any data. This is very important thing. So you should know the truth table of your basic NOT gate, basic buffer, and your tri-state buffer. This tri-state buffer is very important. Very important. Okay, now come to the point. Now come to the second logic gate, AND gate and OR gate. Now AND gate and OR gate, I hope this thing is clear to all of you. What is a buffer, what is a NOT gate, and how you can use NOT gate, and what is buffer. Buffer will be implemented by NOT gate, and what is a tri-state buffer. Now I am going to start. Now here I am going to start. Okay, next logic gate. Logic gate is your basic logic gate, that is AND gate and OR gate. So first I am going to take here AND gate. So what is the AND gate? AND gate you know very well. AND gate is represented by like this. If suppose this is A and if suppose this is B, so output we can write A dot B. Now if I will ask you, sir, is there any another representation? If any another representation of this AND gate, sir, is there any another representation of this AND gate? Suppose for example, if I will complement this, this is A and this is B, suppose, so you will get A bar and B bar, and suppose if I am going to write here OR, and again I am doing here one bubble, then what will be the output? So again this will nothing but, so this is nothing but A bar plus B bar whole bar. And if you can apply here De Morgan's law, okay, you can apply here De Morgan's law. Sir, this is A dot B bar and bar, you are getting A dot B. So you should remember this is another representation of AND gate. So AND gate either you can represent in this way or you can represent in this way. Now what is the truth table of AND gate? We know very well, sir, this is A B, if this is Y, So this is 0 0 0 1 1 0 and 1 1. 0 0 and 0 0 1 is 0, 1 0 is 0 and 1 1 is 1. So what you can say, if any one input is a 0, then second input is not required, output will be 0. So in AND gate, can I write majority input? What is a majority input? So here majority input is 0. What do you mean by majority input? If any input you know, then second input can be anything, output can be decided. So here can I write, this is AND gate, if any input is 0, then second input can be anything. This can be anything. If this can be anything, what can be the output? If any input is 0, output is a fixed 0. So we can write output is a 0. Clear this point? Clear this point now. But here if I will write, sir, first one input is 1 and second input is anything, then output you cannot decide. Then output will decided by this anything. Anything into 1 will be anything. So here answer will be this value. So if anything I am writing x, x dot 1, this output is x. And if here this is x, x can be anything, either 0 or 1. So output will be 0. So one important thing you should remember, if any input is 0, output will be decided. In many ways we can use this concept. Now the next important point here, sir, in AND gate, suppose for example, if AND gate like this, if this is 1 and if this is open, if this is open, what will be the output? What will be the output? Anybody can tell me the answer for this? If one input is 1 and second input is open, then what will be the output here? 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 Sir, I am doing a rewarding concept of digital that you have completed few days. Which one you have all the concept cover in this session? Also network, which you have completed all the concept neatly. Yeah, okay, this session will also useful. Okay, previously session you can also attend, and this session you can also attend, because in here in very speed manner I will complete all the topics. So this is basically for the your revision purpose, and definitely you will learn also so many new things. Okay, so anybody can tell me here what will the answer? High impedance. So no, if this is open, if this is open, so what will be the output? High impedance means no data. One thing you remember, if you will write high impedance, high, what do you mean by this? No data. So in digital, there are 3 states possible. That's why this is called tri-state. Here 3 state is possible. One state is 0, one state is 1, and one state is no data. No data, and no data is called high impedance state. You can write this is high Z state, high impedance state. So here the important thing is, sir, by which technology this gate is designed? So if in digital electronics, in whole digital electronics, if in gate exam you will get open input, so examiner will always provide this gate is designed by TTL. This is a TTL gate. TTL full form is transistor logic. So always in TTL only open input is possible. In CMOS design, open input is not possible. So in every question, when examiner will provide you open input, so definitely in that question examiner will mention TTL gate. And one thing you should remember, this is also called open input or floating input. This is called floating input. This is called floating input. So in TTL gate, floating input is treated as logic 1. So in TTL, open input is treated as logic 1. So in TTL, open input, always open input is treated as 1. Open input is treated as 1. So if this gate is TTL, this open input always you have to write 1. So 1.1 you will get here 1. You will get here 1. This is the important point. This is the important point. So remember, if open input you will get in whole digital electronics, thus you can see examiner have provided TTL or not. So definitely they will provide TTL. If that is CMOS gate, then you cannot say the answer. Then circuit will not practically operate. Okay, so you cannot say exactly answer. Sometime it can be 0, sometime it can be 1. So if this is a CMOS, so examiner will not ask you for the CMOS, don't worry. Examiner will definitely ask you for the TTL. So if open input, just you can check in the question, they have provided the gate is TTL or not. Clear this point? Okay, so this is your AND gate. This is your AND gate. Okay, this is your AND gate. So there are so many combinations can be possible. Okay, so now you can handle. Okay, how you can handle open input and how you can handle if any input is 0, then second input is not required. Now, and this is the second representation. This you can call, this is bubble NOR. So this gate is exactly called, this one is NOR gate, and here this is bubble. What is the name of this gate? We can say, sir, this gate is AND gate. This is also a AND, but here the another name is, this is the bubble, this is the bubbled NOR. This is bubbled NOR. This is nothing but bubbled NOR. Now the second gate is OR gate. Now the second gate is OR gate. OR gate. So OR gate, how we can represent? OR gate we can represent in this way. OR gate we can represent in this way. Sir, this is A and B, and Y will be nothing but A or B. This is not addition. This is plus represent OR. This plus represent or A or B. So what is the truth table here? This is A, B, and this is Y. If this is 0, 0, so this will be 0. If this is 0, 1, 1, if this is 1, 0, 1, if this is 1, 1, this is 1. So what is the majority input here? So here majority input, what is the majority input is 1. It means if any input is 1, then output will be decided. So if any input is in OR gate is 1, then this can be any value. This can be any value. So if this can be any value, so 1 plus any value, here output will be 1. Output will be 1. So any value will not be matter. But if this is 0, if this is 0, then definitely output will be 0 plus x will be x. So if this one input is, if this one input is 0, and if this is any value, then output will be 0 plus x will be x. If x is 0, output will be 0. If x is 1, output will be 1. Output will be 1. So just you should remember, if in AND gate any input is 0, output is decided. In OR gate, if any input is 1, output is decided. Similarly here, what is the another representation of OR gate, and what is the here open input concept, and what is the open input concept, and what is the open input concept? So here you can see, first if I am asking, sir, this is OR gate, if this is 1 and this is open, so what will be the output? And in second question, this is OR gate, sir, if this is 0 and if this is open, then what will be the output? So examiner will always provide this is, and this is designed by TTL. Then open input is treated by 1, open input is treated by always 1. It can be AND gate, it can be OR gate, it can be anything. So 1 plus 1 output is OR gate 1, and 0 plus 1 output is 1. So in both the cases you are getting 1. If any input is 1 in the OR gate, another input can be anything. So if I am again writing, sir, this is a OR gate, this is open, and if this input is anything, if this input is x, then what will be the output? One thing you remember, if this gate is designed by TTL, open input is treated by 1, so 1 plus anything, your output is 1. This is very, very important concept. Okay, clear this thing? Okay, now clear. Mr. Nitin Kumar, you are asking, sir, your digital electronics, from where it will be resumed? Already it is conducting, dear. Okay, you can watch. Okay, you can watch here. I don't know in which channel you are asking. If you are asking in plus channel, so right now actually I am busy. Okay, I will try after GATE exam. Okay, if you are asking for the plus channel, already 52 lectures are there, and the remaining lecture I will try after GATE exam, but right now I cannot come in. Okay, now come to the question, sir, what is alternate representation of OR gate? So here alternate representation of, sir, this is OR gate. So what is this alternate representation? Again, how you can represent? If this is OR representation, what you can do? Here AND representation, and all these three places you can put the bubble. Here this is NOT gate, and NOT gate. Okay, so if this is A, this is B, and here this Y is equal to A dot B. So if this is A and if this is B, then here this Y, if this is Y, so I can write Y is nothing but A bar dot B bar whole bar. You can write Apply the De Morgan's law. This is A plus B. This is whole double bar. So you are getting A plus B. So both will be same. So this is the alternate representation of OR gate. So what the name of this gate? This gate name you can generally write, sir, this is OR gate. This is also a OR gate, but what is the alternate name? This is a bubble NAND gate. So the name of this gate is this is a bubbled NAND gate. This is a bubble NAND gate. So the name of this gate is a bubble NAND gate. Bubble NAND gate. So I hope AND gate and OR gate, all the concept is clear to you. Now come to the next gate, NAND gate. Now come to the next gate, NAND gate and NOR gate. NAND gate and NOR gate. Okay. Okay, in plus channel you are asking. Already 50 to 50 plus lecture already I have provided. Okay. So I will try after gate exam to finish that part. Okay. Okay. Now, so now come to the point. Now come to the point. Next gate is NAND gate and NOR gate. Next gate is NAND gate and NOR gate. Next gate is NAND gate and NOR gate. So now the next is NAND gate. Next is a NAND gate and NOR gate. Both are universal logic gate. Both are universal logic gate. Okay, so now first I am going to take NAND gate. First I am going to take a NAND gate. So NAND gate, how you can represent? So NAND gate is nothing but you can represent in this way. This is A, B, and what is the output is nothing but A dot B whole bar. A dot B whole bar. Sir, is there any alternate representation? Yes, sir. Alternate representation of NAND gate. How you can represent any gate to alternate gate? If this is AND, so what you can draw here? You can draw here OR. Now, if here this is bubble, so don't apply otherwise all the port you can do bubble. So here I can put bubble, here I can put bubble, here already one bubble was present, one more bubble I can put. So two bubble will be cancelled out. So what will be the actual representation? Actual representation is like this. Actual representation is like this. So if this is A, this is B, and if this is Y, so Y is nothing but A bar plus B bar, and this is nothing but A dot B whole bar. This is nothing but NAND gate. So just I am telling one important and basic thing I can say. This is your AND representation. This is your OR representation. If here bubble is not present, so here bubble will be present. If here bubble will not present, here bubble will present. If here bubble will present, here bubble will not present. So in the total 3 bubble. So here total 3 bubble. Bubble means not gate. Total 3 bubble will be present. Now come to the point here. This is OR representation. So this is AND representation. Here bubble is not present, not present, not present. So here bubble will present. Here bubble will present. So like this easily this is a AND representation of NAND gate, and this is OR representation of a NAND gate. So every gate will be represented by AND representation as well as OR representation. Clear this point? So this is nothing but AND gate. Okay, sorry, this is nothing but your, I can say the name of this gate is NAND gate. And what is the name of this gate? Okay, both are same. What is the name of this? This is NAND gate. But what is the another name of this? Can I say the name of this is nothing but bubble? Can I say this is bubble OR gate? So this is nothing but bubble OR gate. So NAND gate, another name is bubble OR gate. NAND gate, another name is bubble OR gate. Clear this point? Now, sir, what is the truth table of this? So this concept you can apply anywhere you can apply this concept for 2 input logic gate. Anywhere you can apply. Okay, now sir, what is the truth table for this? If this is A, B, and if here Y, this is 0 0, this is 0 1, this is 1 0 and 1 1. So for 0 0 output is 0.0, 0 bar is 1, 0.1, 0 bar is 1, 1.0, sorry, 0.0, 0 bar is 1, 0.1, that is 0, 0 bar is 1, 1.0, 0, 0 bar is 1, 1.1, 1 bar is 0. So here 3 times of 1 and 1 times of 0. Now here can I say majority input? What is the majority input? So if any input is 0, output is decided. So can I see again? So for this AND representation or NAND representation, majority input is 0. If you are not getting this concept, you can see from here. This is NAND gate. This is NAND gate. If any input is 0, so this can be any value. This can be any value. So if another one is anything, so 0 dot anything is 0, 0 bar is 1. So output is fixed. So if any input is 0, another input is not required. Another input can be anything. Output will be decided, that is 1. So here measured input is in NAND gate, that is again 0. That is again 0. Now if again I will tell you one question, sir, this is NAND gate, that is NAND gate, and if this is 1 and this is open, and if this input is open, so always first you can check, sir, this is TTL or not. This is TTL. Always open input is treated by logic 1. So here 1 bar is 0, output will be 0. Sometime student will write open input is treated by 0, 1.0 is 0, and 1.0 is 0 and 0 bar is 1. Your answer will be error. Clear this point? Always open input in TTL circuits, always open input is treated by logic 1. Okay, so this thing you should know. Alternate representation of NAND gate, this basic your major input concepts. Okay, and now this thing you should know, if any one input is open. Now the next gate, next gate is NOR gate. Okay, next gate is NOR gate. So in NOR gate, so our next gate is NOR gate. NOR gate, how we can represent? We can represent like this. This is A, this is B, and what is Y? Y is A plus B whole bar. Can I write? Now, sir, what is the alternate representation of this? What is the alternate representation? What you can do? This is AND, OR. So you can write here AND. Here bubble is not present, here present. So where bubble was not present, you can write the bubble, and this bubble is present, so you don't put here bubble. So this is the another representation of NOR gate. So what is the name of this? So can I say this is nothing but bubble AND gate. So another name of NOR gate is bubble AND. If you want to write output, sir, Y is nothing but if this is A, this is B, so what will be here? Sir, A bar dot B bar, and this is nothing but A plus B whole bar. Can I write? Both the function is same. So every logic gate will have two representation. One is the form of OR and one is the form of AND. And bubble can be present anywhere. Now if I will write the truth table here, sir, this is A, B, and here this is Y, this is 0, 0, 0, 1. 1 0 and 1 1. So if this is 0 plus 0, 0 bar is 1, 0 plus 1, 1 bar is 0, 1 plus 0, 1 bar is 0, 1 plus 1, 1 bar is 0. So here what I can write? Measure to input. So if any input is 1, output is 0. So if any input is 1, output is 0. Like a OR gate. In OR gate, measure input is 1. In NOR gate, measure input is 1. In AND gate and NAND gate, measure input is 0. Okay, so now if I want to write here, this is your NOR gate. If any input is 1 here, and second can be any value, then what is the output? 1 plus any value is 1, 1 bar is 0, then output is 0. But if this is 0, 0, and if this is any value, so if I am going to write here, this is NOR gate. If this is 0 and if this is x means any value, so 0 plus any value is any value bar. So what output you will get here? X bar. So if this is 0, output will be 1. If this is 1, output will be 0. So here what is the measured input? 1. If any one input is 1, output will be fixed, and output will be always this. If any input is 1, output will be 0. So I hope this thing is clear to you. Similarly here, open input concept you can apply. If any input is 1, then again you can treat like SA1. So one more example I am going to take here. This is your NOR gate. If any input is open here, and suppose this is X. This can be anything, 0 or 1. So this open input is always treated by 1. So 1 plus anything is 1, and 1 bar is 0. So this output is 0. So if I will ask you one question, here in NOR gate, if any input is 1, output will be, that is fixed to 0. And similarly, if I will ask you in NAND gate, if any input is 1, open means this is nothing but 1, and this can be anything, then what will be the output? So x dot 1 x, so output will depend on the x. So in NAND gate, if any input is open, that will be depend on the second. But if in NOR gate any input is 1, it will not be depend on the another input. Okay, so just basic you remember, if this is TTL, if this is TTL, and if this is TTL. So for TTL, if any input is open, always write down that SA1, that SA1. Clear this concept? Now if I will ask you, implement NAND gate and NOR gate is universal logic gate. So NAND gate to NOR gate, NOR gate to NAND gate, and NAND gate to AND gate, and NAND gate आपको NAND gate you have to implement by using AND gate, AND gate you have to implement by NAND gate, OR gate you have to implement by NAND gate. So now my next question, now my next target is here, implement all the logic gates by using NAND gates. So implement all the gates, implement all gates by NAND gate, implement all gates by NAND gate except XOR and XNOR. So first a NOT gate. So NOT gate, how you can implement NOT gate by NAND gate? So easily we can implement. So if this is a NAND gate and if this is a X, so if you will connect both the input, your output will be X bar. So you will get X bar. This is the first method. Sir, is there any another method? Yes. So if this is a NAND gate and if this is X, this is second input. If you can put second input as a 1, so this will be X dot 1 X bar. Again you will get X bar. Sir, is there any another method? Yes, one more method we have. Sir, if this is a NAND gate, this is X, you can write this as a open. But this should be TTL. Then again what will be X dot 1? Again this is X bar. So there are three different representation is possible. How you can implement NOT gate by NAND gate. How you can implement NOT gate by NAND gate. Now we have to implement AND gate, OR gate, and NOR gate. Okay, AND gate, OR gate, and AND gate, OR gate, and NOR gate by using this. Now if you want to implement buffer, so to NOT gate you can use. So buffer I am not going to teach you. Then what is a buffer? So if you want to implement buffer, so buffer always will be implemented by buffer will be implemented by to NOT gate, always to NOT gate. Now the next target is here. Sir, what is AND representation by NAND? So AND representation, how you can represent? This is NAND, and again you can write here one NAND. Can I do like this? Yes. This is A, this is B. This will be A, B, whole bar, again whole bar. So you will get here A dot B. So this is AND representation. So if you want to represent NOT gate, only one NAND is required. If you want to implement AND gate, two NAND is required. Next one is OR gate. So OR, how you can implement, so you can see here how you can implement OR. Sir, this is NAND. So NAND will be also represented in terms of OR. Yes, NAND will be also. So what you can do here, sir, if I will represent like this NAND gate, so can I put here one bubble, here one bubble, and like this. So here you can see this is OR gate, this is NOT gate, and NOT gate. So this NOT will be replaced, this will be replaced here, this two bubble. It means here, if you will write here, if you will apply here two NAND gate, so can you implement in another way? Just I am writing this is A dot B, and this is AB, and A dot B whole bar is required. Okay, sorry. Or. Okay, this is not, already we have implemented this, na? Okay, this is or we have to implement. So here A plus B I want to implement. Here by using NAND. Then what you can do here? We can do here, this can be represented by like this. Okay, here can I put one bubble, here one bubble, here one bubble, both will be same. So now you can see this part is already A NAND. Okay, this two NOT gate you can implement by the NAND. So what we can do here? Here this one is the NAND. Here this one is the NAND. And here this one is the NAND. So this is a OR gate, this is A B. What you will get here? A bar, here B bar, here a bar dot b bar whole bar. You will get sir a plus b 2 times bar, you are getting a plus b. So by using NAND gate, if you want to implement OR gate, how many number of NAND is required? 3. If you want to implement AND, how many number of 2? If you want to implement NOT, 1 number of NAND is required. So if I want to write here table, by using NAND gate, number of NAND gate number, if you want to implement NOT gate, how many NAND gate is required? 1. If you want to implement here AND gate, so how many number? 2. If you want to implement OR gate, how many number? 3. How many number? 3. Now if you want to implement NOR gate, so here this was OR, if I will put here one more NAND gate, so here this is nothing but OR, here sorry, this is OR, and here you will get NOT. So if I will put here one extra NAND gate, so here you will get OR, and here you will get NOR. Can I write? So if you want to implement NOR gate by NAND gate, so 4 number of gate is required. 4 number of gate is required. Clear this point? So if you want to implement NOT, 1 number. If you want to implement AND, 2 number. If you want to implement OR, 3 number. If you want to implement NOR, 4 number is required. Now come to the next point. Clear this point? So now my next target is implement all gates by NOR gate. Implements all gates by NOR gate. Implement all gates by NOR gate. So first NOT gate. So first one is the NOT gate. So NOT gate, how you can implement? This is a first way. This is NOR. If you will connect both the terminal, if this is x dot x is x, then you are getting x bar. This is the first way. What is the another way? If you can apply x is one input, then again second input is 0, so x plus 0 is x bar. This is another way. So can you use your open input? No, here only 2 representation is possible. So if I want to write here, this is NOR. So how many number of NOR gate is required to implement NOT? This is 1. Now now I am targeting OR. Second I am targeting OR. Okay, so how you can implement OR gate by NOR gate? So if I will put here one NOR gate, and here if this is another NOR gate, so what you will get? This is a plus b whole bar, and you will get here a plus b. So if you want to implement OR gate by NOR gate, only 2 number is required. So here this is 2 number is required. But if you want to implement AND gate by NOR gate, so first you can write here how in gate exam you can do. Sir, this is AND gate. Okay. Now AND gate another representation you can write. Okay. AND gate another representation is, sir, this is a OR, and here this is no bubble, so you can put bubble here, no bubble, you can put here bubble. Now by which gate you want to implement NOR gate? So you can see, sir, this is already a NOR, this is already a, this should be implemented by NOR, and this should be implemented by NOR. So 3 number of NOR gate is required. So what you can do, this first one is NOR, NOR means this is exactly NOT gate. This second one is NOR, and here you will get one NOR gate. Here you will get one NOR gate. This is AB. So here you will get A bar. Here you will get B bar. Here this is A bar plus B bar. This is whole bar. So this is nothing but A dot B 2 times bar. So you will get A dot B. So in gate exam, this basic diagram process to representation, if you are comfortable, so most of the question easily you can handle. So if you want to implement AND gate, 3 number of NOR gate is required. Now come to the next point. Now I hope this thing is clear. Now I want to implement NAND gate by NOR gate. So here this is AND NAND. Okay, so again if you will put here one more NOR gate, then what you will get? So if here this output is AND, then here this output will be NAND. So remember, NAND to NOR or NOR to NAND, 4 logic gate is required. So again here this answer is 4. 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 So I hope this thing is clear to all of you. Okay, so everyone just confirm me. Okay, so everyone just confirm me. Everything is clear till now? Tell me. Okay, please reply everyone. Na? Please reply everyone. Okay, now come to the next. Now I am going to target here two extra universal logic gate we have discussed. Two extra universal logic gate. So how many extra universal logic gate? So just I am writing here extra universal logic gate. Okay, extra universal logic gate. So here we cannot go into deep. So just basic I want to tell you. Already I tell you. So two number of, this is a first number of, this alternate representation is also possible. Sir, what is this alternate representation? This is number one. Sir, what is this alternate representation? So this alternate representation is here this is R, so you can write here and okay. Sir, here bubble is not present, you can write here bubble. Sir, here bubble is present, you can remove. Sir, here bubble is not present, you can write either this or this, both are same, both are same. This is universal logic gate. Now second universal logic gate is like this. Second universal logic gate is like this. Sir, what is this? What is this alternate representation? This alternate representation is here, here this is AND. So here you can write the R. Here you can write the R. Here bubble is not present. Here you can write bubble. Here bubble is present. You don't put here bubble. Here bubble is not present. You can put here. Total 3 bubble in both side. Okay, in one side AND representation, another side OR representation. Okay, so these two are the extra. These two you cannot say 1 2 3 4. These extra 4 are the universal logic gate, but practically these two are same and these two are same. So how many total universal logic gate? 4. NAND gate, NOR gate, this next third, and this one is 4. Clear this point? Now I am going to jump to the most important. Now I am going to jump to the most important XR and XNOR gate. Clear this point? So this is very important. XR and XNOR is very important. Okay, then we can complete this table. Okay, this table here you have to also put here XR and you can also put here XNOR. Okay, then you have to finish this table. Okay, so just after completion XR and XNOR we can fill this table. We can fill this table. We can fill this table. Okay, now I am going to take, okay, right now we have discussed all the gates to input, all the gate to input. Suppose for example, if examiner will tell you 3 input OR gate, suppose 3 input AND gate, 3 input AND gate, suppose 3 input NOR gate and 3 input, this is NAND gate. Suppose for example all this input is ABC, this is ABC, this is ABC and this is ABC. Suppose all the inputs are ABC, ABC, ABC and ABC. Then what will be the output of this? This is nothing but A or B or C. A or B or C. Now my question is, can you implement this by like this? Can you implement this by like this? Yes, we can implement. Sir, this is A, this is B, this is C. So here A plus B and A plus B plus C. A plus B plus C. Can you write in this way? Yes, we can write. Sir, can you also write? Can we also write this in this way? Suppose this is A and first I am going to write this is B, C. Yes, and now this is a again OR with A. So can I write A or B or C? Yes, we can write. So this is nothing but A or B or C. So for OR gate, 2 input, 3 input, 4 input, 5 input, you can easily divide. Okay, so 3 input easily you can divide by the 2 input. No worry. Same for the AND gate. So I hope you can also write. So here this is nothing but A dot B dot C, and both are near about same. So both are same. Just all the gate will be replaced by here AND gate. So here A dot B dot C. So if you will replace this AND gate, so this will be A dot B, and here this will be A dot B dot C. Can you write? Yes. Here this B dot C. Here first you can find out B dot C, and then this is A. You can write A dot B dot C. So in 2 input AND gate, 3 input AND gate, 4 input AND gate, and 2 input OR gate, 3 input OR gate, 4 input OR gate, you don't have to worry. So can I write A plus B plus C? This is basic mathematics. Can I write this first A plus B, then plus C? Yes, we can write. Can I write here A plus B plus C? We can write here. Now come to the A dot B dot C. Sir, A dot B dot C, can we write first A dot B? So this is 3 input, this is 2 input. So first this 2 input and then C. In another way, sir, this is first B dot C, then dot with C. Can you do? Yes, we can do. Now come to the NAND gate. Here this is NOR gate, A plus B plus C whole bar, and this is A dot B dot C whole bar. So can you implement 3 input NAND gate, 3 input NAND gate by 2 input NAND gate? This is my question. So you cannot do here. Okay, so just I am writing here. This easily you cannot implement in mathematical way. So now you can see, if I am going to write this in mathematical way, suppose sir, this is A, B, C, and what you are writing, A plus B plus C whole bar. Can you write this, sir, A nor B nor C? This is my question. Can you write this like this? So A plus B plus C whole bar, can you write this A nor B nor C? This is my question. Can you write this A nor B nor C? What is the meaning of this 3 input? This is A or B or C, then whole NOR, whole complement. In another way, A nor B nor C, both are same or different? This is my question. These both are same or different? Tell me the answer. Both are same or different? No, both are not different. Yes. Okay, so this basic things should be very clear for 3 input, 4 input. Sometime students are stuck. If examiner will tell you in written 3 input NOR gate, 3 input NOR gate. Suppose for example, if I will tell you 3 input NOR gate, what is the meaning of 3 input NOR gate? So what is the meaning of a 2 input NOR gate? What is the meaning of 3 input NOR gate? And what is the meaning of 3 input NOR gate? So 2 input NOR gate mean is OR gate, then NOT gate. This is NOR, and NOT gate is 1 input and OR gate is 2 input, because you are targeting here 2 input. So if this is A and B. Now my question, sir, what is 3 input NOR gate? So 3 input NOR gate is, again here first you will write this is OR gate, 3 input OR, and then this will be NOT. So this is a 3 input NOR gate. So what you will write, A or B or C and then NOT. This is the meaning of 3 input NOR gate. So what you will write, sir, A or B or C and then whole NOT. This is the meaning of 3 input NOR gate. Don't write A nor B nor C. Clear my point? If you will write this, so what do you mean by this? A nor B means A plus B whole NOR. A plus B, this is A nor B. Now this NOR with C. So what you will write, this is in first bracket plus C whole bar. So this value and this value same? No. If you will open this, so you will get this A dot B. A plus B whole bar. What you will write? A bar dot B bar. And this is plus C whole bar. And again, if you will apply here De Morgan's law. So if directly you are applying here De Morgan's law, so what you will get? This is X, this is Y. X plus Y whole bar. So you will write this is A plus B whole bar, then whole bar. Okay, dot C bar. This 2 bar is cancelled out. So this is A plus B C bar. So you will get AC bar plus BC bar. Both are not same. This is the important thing. So what is the meaning of a 3 input NOR gate? Okay, generally student will not be wrong here, but later I will tell you where student will be generally wrong. So don't, if examiner will write to you, tell you in written way 3 input NOR gate. So what is the meaning of 3 input NOR gate? 3 input NOR gate meaning, you cannot write A nor B nor C. You have to write A or B or C, then whole NOT. I hope this is same for the 4 input. For the 4 input, A or B or C or D, then whole NOT. Clear this my point? Similarly for the NAND gate. So you cannot write this. This cannot be is equal to A NAND, A NAND, A NAND B NAND C. You cannot write A NAND B NAND C. You cannot write this. Both are not similar because A NAND B is nothing but A dot B whole bar and dot C whole bar. This is the NAND. A NAND B. Okay, so A NAND B, then NAND C, and both will not be same. Both will not be same. So I hope this thing should be clear for the 3 input, for the 4 input, for the 5 input. If I will tell you 3 input NAND gate, so you cannot write this is 3 input NAND gate. You have to write this is a 3 input NAND gate. So 3 input first and then not. I hope this thing is clear to all of you. Now I hope this thing is clear to all of you. 3 input. Now easily you can handle 4 input, 5 input, 6 input. So now if I will ask you here one question, I hope this thing is clear to all of you. Now if I will ask you one question, can you divide this 2 gate into in this way? No. So can you write? I hope this thing is clear. Now I am going to remove this part. I am going to remove this part. So can you write this 3 input NOR gate like this? First you can write this AB NOR, sir, AB NOR, then this C NOR, then this C NOR. Tell me, can you write this? No. This both are same? No, both are not same. So A NOR B NOR C, you cannot write. You cannot write. Okay, now similarly, now my next question, sir, A NOR B NOR C. Now my next question, A NOR B NOR C, A NOR B, and this is first A NOR B, then NOR C, A NOR B, then NOR C. This value is equal to A NOR, then B NOR C. This is my question. B NOR C. Tell me, both are same or not? Both are same or not? It means this can you write? This is A, this is B NOR C first, and this is NOR with A. This is NOR with A. So these two are same or different? Tell me, same or different? Tell me, sir, I am planning to take subscription, so want to contact you for referral code. Okay, already discount was going on. So, okay, referral code is not available. Okay, in Gate Academy, referral code is not available. Direct discount you will get. Okay, direct discount you will get. Okay, direct discount you will get. Okay, now come to the point. Now I am asking, these both are same or not? Both are same or not? If this is y1 and if this is y2, y1 and y2 are same, it means you can write, sir, this is A nor B, this is A nor B, and this A nor B nor C, and here this is B and this is C, this is B and this is C. First this is B nor C, and then nor with A, then nor with A. Both are same or different? Tell me. Sir, associate law, it is a, I am not telling any name of the law, associate, distributive, just I am asking the basic mathematics. Both are same or not? Then you can relate with the law. So first you should know this concept. Don't remember associate law will applicable or not. First you remember this will be same or not. Then written you can tell which law you can say this is associative. Then you can say associative law will not follow to NOR gate like this. Are you getting my point? So first this basic you should know, then you should relate with the law. Don't first remember the law, then you can write here. Okay, so both are same or not? No, both are different. So if you are writing, sir, A dot B dot C whole bar, and here, sir, A dot B whole bar dot C whole bar, both are same or not? Both are same. So if you will cancel, this will cancel. Here you will get sir, A dot B C bar, and here A dot B bar C. If you will open this, so this is a B bar plus C bar, and here this is A bar plus B bar, and here this is C. So here A B bar plus A C bar, and here A bar C plus B bar C. Both are same or different? Both are not same. So both are different. Both are different. So here A nor B nor C is not equal to A nor then B nor C. But in OR gate and AND gate you can use this. Okay, so now you can relate with the law. Okay, now you can relate with the law. Clear? Okay, so now this thing you should remember. So this gate you can divide by first two input, then again one. You cannot, again you can also write here, but you cannot divide. But you can implement this by different logic gate. but you can implement this by different logic gate. Okay, but you cannot divide this by two input NAND and this is NOR. So two input NOR and one two input. No, you cannot divide this by three input NAND gate, two input NAND and two input NAND. No, you cannot do here. I hope this thing is clear. So three input logic gate should be also clear to you. Now come to the point, XOR gate and XNOR gate. I hope this thing is clear. Not same. Both are not same. Okay, good. Okay, now come to the point. Next, my favorite part and whole digital electronics most important part. Now I am going to start. That is your XOR gate and XNOR gate. Okay, so here you have to study two input as well as three input, and you have to implement three input by two input. This should be your target. This should be your target. So now, okay, now XOR gate. So first I am targeting two input, and then I will jump to the three input, and then I will jump to the three input. Then I will jump to the three input. Okay, now first I am going to take XOR gate and XNOR gate. This XOR and XNOR gate. XOR gate and XNOR gate. Okay, so what is XOR and what is XNOR? How you can write, this is your XOR gate, this is your XOR gate, this is your XOR, and here if you will put one NOT gate, and if here you will put one NOT gate, so here you will get this is XOR and this is XNOR. So this is the relation between XOR gate and XNOR gate. Remember, this is the relation between XOR and XNOR. Okay, so two input XOR, how we will write? You can also represent in this way. This is first representation. If this is A, B, so you can write this is A XOR B. And XOR you represent in this way, plus over circle, this is A XOR B. And here you will write this is dot over circle A XOR B. But what you can also write, this is nothing but A plus over circle B, this is XOR complement. So A, B you can either represent in this way XOR, and you can either represent in this way. This is not dot. Okay, now this is A and B, and here this is A XOR B. Okay, now what is the meaning of XOR? What is a Boolean function of XOR? So if you will open this, so this is A B bar plus A bar B. This is A B bar plus A bar B. This is the XOR, two input XOR gate. Two input XOR gate, either this representation or this representation. Now if I will draw the truth table, so this is A B, and if this is A XOR B. Okay, so I can write this is Y. You can write this is Y. You can write this is Y. So what if this is 0 0 0 1 1 0 and 1 1? What is output if both the input is same? You can put here the value. This is 0, this is 0 0 0, this is 1, this is 1, this is 0. So 0 dot anything 0, here 0 dot anything 0, 0 plus 0 is 0. So if both the input is same, you are getting 0. Here both the input is same, you are getting 0. Both the input is different, you are getting 1. Okay, so XOR you should remember, if both the input is same, output is 0. If both the input is different, output is 1. Okay, so here if similar, output is 0. If different input, output is 1. So if same input, output is 0. If different input, output is 1. Like this you can remember. Now in second way, how many number of 1? Now here, how many number of 1? How many number of 1 here? 0. How many number of 1 here? 1. How many number of 1 here? 1. How many number of 1 here? 2. So this is your even. I can say 0 is nothing but even. This is nothing but odd. This is nothing but odd. And here this is even. Here this is even. So what I can say, if n number of, if even number of 1 in the input, then output is 0. So if number of 1 is the even, so this is 0 and this is 0. This is 0. When output is 0, if your input number of ones is the even, number of ones is even in input. Okay, this is my favorite relation. You should remember. I will relate in very efficient manner this thing. And now here this is 1. Here this is 1. So if this is 1, so I can say here number of ones is odd in input. clear thing. Right now you remember, I will relate this. Okay, so this is your 2 input XOR gate. This is your 2 input XOR gate. 2 input XOR. Now first I am going to discuss 3 input. So later I will complete this part. Okay, now 2 input XNOR gate. Okay, so this is 2 input XNOR gate. 2 input XNOR gate. So XNOR gate is just complement of this, nothing different. Complement of this. So how you can represent? So generally we can represent in this way. This is XOR, then complement. This is A, this is B. So what you can write? A XOR B complement, but sometime directly we can write A XNOR B. Like this you can write. What is the another representation? In other representation we can also write in this way, plus over circle. This is A B and this is A XNOR B. But always you should try to write. What should be always you have to do in GATE exam? When you are getting XNOR, always you have to replace with XOR. So your representation should be always XOR. Why? Wait for that, I will explain. Okay, so what should be your target? Don't write in this way. Always you have to use this representation. Don't write this. Always you have to use this representation. But this is your choice. This is my recommendation. Okay, so now, so if you will study from me, and if you will always represent, sorry, this is not plus, no, this is XOR. This is XOR, this is XOR. Okay, so if you will represent in this way, definitely you will get some benefit. Now come to the point. Sir, what is the truth table and what is the function? So here function is nothing but, can I write, sir, A bar B plus A B bar whole bar? Can I write? Yes, XOR whole complement. Yes. If you will solve this, you will get from here A dot B plus A bar B bar. You will get this expression. If you will solve this, you will get A dot B plus A bar dot B bar. Everybody know this thing. Now what is the truth table of this? This is A B and this is A XNOR B. In another way you can also write, sir, this is A XOR B whole complement. Okay. Now if this is 0 0 0 1 1 0 and 1 1. If this is 0 0, then what will be the output? Here you can say this XOR is 0. So XNOR will be 1. So, and here this is 1, this will be 0, this will be 0. So here you can see for same input output is 1, for different input output is 0, for different input output is 0, for different input output is 0, for same input output is 1. Okay, so this basic right now you should know. For 2 input XOR gate and 2 input XNOR gate. Now some property I want to discuss here. Some basic function I want to discuss here. Suppose 1 XOR 1. What is that? 1 XOR 1? Same value XOR. So you don't see same or different. You can calculate the number of 1. If 2 number of 1, output is 0. Yes. Sir, what is 0 XOR 1? You can count number of 1. How many number of 1? Here only 1, means odd. So output will be 1. If here 1 XOR 0, this is 1. Here this is 1 XOR, sorry, 0 XOR 0. So just you can count the number of 1. How you remember? Same or different? This is your choice. But what you can also do, you can count the number of 1. If number of 1 is even, output is 0. If number of 1 is odd, output is 1. So total number of 1. So 1 1 0. Total number of 1 is even. 0 1 1. Total number of 1 is even. Including result, total number of 1 is even. 1 0 1. Total number of 1 is even. Here 0 0. So here result will be 0. Total number of 1 is even. So you can see in all this total number of 1 including result. Remember, this is very important thing. Total number of 1 including result is always 1. Is always 1. This is for 2 input. I will relate for 3, 4, 5 also. Wait for that. So total number of 1 is always here, that is even in XOR. Okay, in XOR. In XOR you don't have to remember this. So this number of 1's concept only you should remember for XOR. Only you should remember for XOR. Don't remember for XNOR. Clear my words? Remember only for the XOR. So in XOR, just you can count the number of 1, and if number of 1 is even, result is 0. If number of 1 is odd, result is 1. Only 2 conditions can be possible. Including result, number of 1 will be always even. Now the next property, if A XOR B is equal to C. This is next property. If A XOR B is equal to C, then the very important thing, if A XOR C is equal to B, you can also write, if A XOR B is equal to C, then what you can do, you can interchange this C to anywhere and any one to output, any one. you can replace, you can interchange A to C and C to A, B to C and C to B. Any one you can interchange. Any one you can interchange. Clear my point? Any one you can interchange in XOR. In XOR. Clear my point now? So A XOR C should be B, and similarly you can also write this is B XOR C is equal to A. So A XOR B is equal to C, then A XOR C is equal to B. You can check. If you, this is 0 0 XOR 0, 0 1 XOR 1, 1 1 XOR 0, 1 0 XOR 1. Correct? Now you can say 0 0 XOR 0, 1 1 XOR 0, 0 1 XOR 1, 1 0 XOR 1. Again correct. Clear this thing? So you can write it this way. Remember this thing. Now come to the next property. Clear this point now? Now come to the next property. Next property. Sir, what is A XOR A bar? What is A XOR A bar? A XOR A bar. Either you can put here in your here. In another way, one input is 1, then second will be 0. Any one will be 1. Here, any one will be 1 and second will be 0. Okay. Now, so here, if A is 0, this will be 1. If this is 1, this will be 0. So, number of 1 will be odd. So, result will be 1. In another way, you can also put here. Okay, this is your choice. Now, if I will write, sir, A XOR A. So, both will be either 0 0 or both will be 1 1. It means this is a number of uneven. So, always this result is 0. So, if same input, in another way you can write for the same input result is 0. For different input result is 1. Result is 1. Now I am writing, sir, A XOR 0. What you will get? A XOR 0. So you can see if A is 0. So 0 0 even number of 1. So if A is 0, result is 0. If A is 1, then number of 1 will be odd, result will be 1. So output will be A. Output will be A. Now remember, any value XOR with 0, you will get same value. Any value XOR with 0, same value. Any value XOR with 0, same value. Now, A XOR with 1. A XOR with 1. So, what you will get? If A is 0, number of 1 is odd. So, if A is 0, result will be 1. And if A is 1, result will be 0. So, this will be A bar. A bar. So, here you can say 2 number of alphabet, 1 digit 2 alphabet, 1 digit 2 alphabet, 1 digit 2 alphabet, 1 digit. 2 alphabet, 1 digit. Now here if I am going to write, sir, A bar XOR with 0, and here, sir, A bar XOR with 1. So how you can remember A bar XOR with 0, 0 XOR any value, same value. So this is the A bar, and any value XOR with 1, it will complement. It will complement. So this will be A. So this property basic you should know. This is very, very important. Already this you know. This also you should know. This also you should know. This also you should know. Now come to the XNOR. Now come to the XNOR. So now my recommendation, don't remember much property for XNOR. Don't remember much property for XNOR. You have to remember how to convert XNOR into XOR. Are you getting my point? How to convert XNOR into XOR. How to convert XNOR into XOR. Clear? Now here one more property I want to tell you. Sir, if A XOR B whole bar is given. If A XOR B whole bar is given, then how you can write? So here this whole bar you can write in this way. Sir, A bar XOR B. Both will be same. So whole bar will be result. Whole bar will be, if any input is complement, you will get whole complement. Similarly, you can also write here A XOR B whole. This is a B complement. So if you will get A XOR B whole complement, so what you can change, this whole complement you can do either in A or you can do in B. So this thing you should remember. Are you getting my point? So now come to the point. Now come to the point. So this table already you know this thing. This table already you know this thing. So here suppose you can also write all the property here. You can also write all the property, but I don't want to tell you here property for XNOR. I am going to tell you how you can convert XNOR into XOR. So in GATE exam, anywhere if you will get XNOR, so what should be your first target? XNOR should be converted into XOR. Clear my point? What should be your target? XNOR should be converted into XOR. Okay, clear this point? XNOR should be converted into XOR. How you can convert XNOR into XOR? So here you are getting, suppose for example, A XNOR B. A XNOR B. How you can write A XNOR B? Sir, this is A XOR B whole bar, A XOR B whole bar, yes sir. And this you can also write, sir, this is A bar XOR B, or you can also write A XOR B bar. So first you have to convert XNOR into XOR, and then you can proceed. Clear my point? This is very important thing. But if you want, you can remember this properties. Okay, already we have here you can remember same value XNOR is 1 and different value XNOR is a 0. Same value XNOR is 1 and different value XNOR is 0. Different value XNOR is 0. Clear this point? Clear this point? Okay, now just you can note down this point. Just you can note down this point. Now the important point is, this is the 2 input. This is the 2 input. Okay, this is the 2 input. So this 2 input XOR you should remember number of 1 counting process. You should remember this, sir. Okay, you should remember this. Here I am not telling the counting of number of 1. Remember my word. I am not telling this process number of 1 counting in XOR. Okay, what I am saying, basic 2 input XNOR, this truth table you should know, and now how you can convert XNOR into XOR, this thing you should know, and all the property of XOR you should know. Clear? The most important property is just count the number of 1. Just count the number of 1. If number of 1 is even, result is 0. If number of 1 is 0, if number of 1 is odd, result is 1. If number of 1 is even, result is 0. Now the second important thing, same any value XOR with 0, same value, any value XOR with 1, complement. Same value XOR 0, same value, different value XOR 1. Only this property you should know for XOR. Don't remember for XNOR. So this is a 2 input XOR gate. This is 2 input XOR gate. I hope this thing is clear to all of you. Now come to the point. Sir, how to implement XOR by NAND gate? How to implement XOR by NAND gate? How to implement XNOR by NAND gate and NOR gate? So first I am going to complete this part. Okay. Then I will jump to the 3 input and 4 input and 5 input. Okay. Both I will discuss. Don't worry. Both I will discuss. So what will be 3 input, 4 input and 5 input? First we have to implement. Okay. First we have to implement. This is very important here. Okay. This one is very important here. And this is very basic. Okay. But you should know this thing and you should know this thing. Okay. Now you should know this thing. Okay. Now, so first I am going with how you can implement XOR and XNOR by NAND gate and NOR gate. So NAND gate and NOR gate, so just I am telling. So first by NAND gate, by NAND. Okay, so by NAND, you can see here, just I am going to consider both input. Okay, this is A and this is B. Okay, so first what we are doing, both input NAND. You can see here. You should remember this directly. Okay, first both input NAND. Then again this is NAND with first input. Then again this is NAND with second input. Clear? Then again both output is NAND. Okay, this is structure you should remember. So what we are doing, first your A and B NAND, then that result is NAND with the first input and the same result is NAND with second input, and again both result is NAND. Clear this point? What you will get from here? So you can see here. So this is nothing but A dot B whole bar. This is A dot B whole bar. Can I write? Yes, sir. What will be this? Sir, this is A dot B whole bar. Yes, this is nothing but B dot A dot B whole bar. This whole bar. Clear this thing? If you can see, if you can put bubble here and if you can put bubble here, so this will be bubble NAND, and bubble NAND is nothing but NOR. So if you can see what will be, sir, here value, this value is nothing but sir A dot B whole bar, Sir, what will be the value before bubble? Sir, this is B dot A dot B whole bar. So what will the output? If you can put this bubble here, you can put this bubble here, this will be OR gate. Already we have studied. What is OR gate? OR gate is nothing but this is bubble and this is NAND. Clear this point? So can I write directly here? So what you will get? This plus this. So here you are getting A dot this is A B bar, this plus B dot A B whole bar. So A B bar whole bar is common. So A dot B bar is common. Here this is A plus B. Can I write? If you will open this A dot B bar by De Morgan's law, so this is nothing but A bar plus B bar. So what you will get? This is A plus B. And if you will solve this A bar 0, A B bar, so you are getting A B bar plus B bar 0 and A bar B. You are getting A bar B. It means this is nothing but XOR gate. So here output is this is nothing but this is A XOR B. And now again if you will use one extra NAND gate, again if you will use here one extra NAND gate, then what you will get here? A XOR B whole bar. It means this is nothing but NOR gate. So remember, if you want to implement XOR, this is XOR. Here this is XOR. By NAND gate 1, 2, 3, 4. Fourth number of NAND gate is required. So XOR by NAND gate 4 number, but this is XNOR. XNOR by NAND gate, this is 5 number. This is 5 number. This diagram should be remembered. So here this is XOR and here this is XNOR. So NAND gate if you want, XOR if you want to implement by NAND gate 4 number, and if you want to implement XNOR by NAND gate, that is 5 number. That is 5 number. So 4 number and 5 number. Clear this thing? I hope this thing is clear to you. This process is very, very important. Many time and many places you can use this. Many places you can use this. Clear this point? I hope everyone clear this point. Now come to the point. I hope this thing is clear to you. Just I am going to remove this. Okay, now just I am going to remove this. Now come to the point. If you want to implement by NOR gate, so by NOR gate, so again same diagram, just you can replace NAND by NOR. This is NOR. Yes, this is NOR. Again this is again NOR, and this output is again this is NOR, and again both the output is this is NOR. This is NOR. Okay, so if this is A, this is B, here A plus B whole bar, you will get A plus B whole bar. If this bubble and this, so this is bubble NOR gate, and this is nothing but AND gate. So what is here input? This is A plus, this is A plus, and you can also write this is nothing but A plus B whole bar, A bar dot B bar. So this is A plus A bar dot B bar. Can I write? Yes. Here you can also write this is nothing but B plus A bar dot B bar. You can also write. And what will the output here? This plus this. And if both will be added, you can also solve this. A plus A bar in first bracket, that is 1. So here this is A plus B bar. This you can write A plus B bar, and here this is nothing but B plus B bar is 1, A bar plus B. And this complete gate is nothing but AND gate. So what is the output here? This multiply this. So what you will get? Sir, we are getting A plus B bar in first bracket, second bracket A bar plus B. A bar plus B, and if you will multiply A bar 0, you will get AB, and here B bar 0, you will get A bar B bar. So what you are getting here? Here you are getting XNOR. This is the important thing. Here you are getting XNOR, and again if you will use here another NOR gate, so here you will get XOR. Just opposite. Here XOR, here XNOR, here XNOR, here XOR. This diagram many times examiner can use this one. So here you should remember this. XNOR, if you want to represent XNOR by NAND gate. Sorry, this is wrong. This is wrong. This was 4 and this was 5 by NAND gate. Okay, and by NOR gate, if you want to implement XOR, this is 5, and by XNOR, this is 4. So this is NOR 4, okay, and this is NAND, but here this is XOR. So you can say NOR and NOR, that is minimum. It is depend on you how you are going to remember. Okay, so NAND gate XOR gate, that is 4, NAND gate XNOR gate, that is 5, but NOR gate XNOR is 4, but XOR is 5. Clear? Generally which we prefer? We prefer this one. So in real life, what we prefer? In real life, we prefer NAND gate. And in XOR and XNOR, which will be beneficial? If you will prefer NAND gate, so NOR gate will take 4 and XNOR gate will take 5. So which will be better? So if a examiner will ask you this question, NAND gate is better or NOR gate is better? So answer you should remember, NAND gate is better. Answer, XOR is better or XNOR is better? If NAND is better, then definitely XOR is better. So if in NAND gate and NOR gate, which gate you have to use? NAND gate. In XOR gate and XNOR gate, which gate you have to use? XOR gate. Clear this point? Why XOR? The reason is because NAND gate required only 4 gate to implement XOR, and NAND gate generally we prefer over the NOR gate. There are so many reasons. Right now I don't want to tell you. Okay, just you remember NAND gate is definitely better than NOR gate in many parameter, and if NAND gate is better, that's why we can say XOR gate is better than XNOR gate. Clear? So in real world we use NAND gate and XOR gate. So this thing you should know. 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 Okay, yeah, digital definitely 2 sessions will be required. Okay, so in 1 session it will not be completed. I will complete all the topics. Okay, so in logic gate I will discuss some number of problem, Boolean algebra and mainly K-map I will discuss, and number system. Already one important thing I have discussed in the number system, and then your combinational circuits, then sequential circuits. It will take time. And after sequential circuit, if a time exists, we will also discuss setup time, hold time concepts. And if again, okay, time exists, we can go with ADC and DAC. Maybe in 2 sessions we can complete all the chapters. Okay, because we have lots of time. Okay, so in 2 session, okay, definitely all the topics I will try to complete. Okay, but 2 sessions will be conducted. So I hope this thing is clear to all of you. Now the picture will start. Okay, now the picture is going to be start. Okay, now the picture is going to be start here. Okay, I hope all this thing is clear to all of you now. Okay, I hope now this thing is clear to all of you now. Okay, so just we have discussed here 2 input. Now suppose for example, if I am going to provide you, suppose sir a x nor 1 is equal to, then how I will handle in gate exam this thing. So first I will replace, what we can do, a x nor 1. How you can replace? One important concept I want to tell you. If you want to replace this x nor by XOR, okay, so what you have to do? So what this you can write, sir, this a XOR 1, this whole complement. Can I write? Yes. And this whole complement, again you can also, either you can write, sir, this a bar XOR 1, either you can write, sir, a XOR 0. So this will be written by this, written by this, written by this. Now if I will ask you, sir, a XOR 0, answer is, this is nothing but a. So this answer is a, and you know very well any value x nor with 1, that is no change, but 0, that will be change, that will be a bar. But just I want to tell you how you can convert x nor into XOR. So now earlier I have tell you the one process whole bar. No, now I am telling the three process. If you want to convert, again I am going to write, if you want to convert this x nor, so what you can write? First thing you can write, if you want to change this, so either you can do whole bar, or you can do complement any one variable, or you can complement any one variable. So here 3 answer can be possible. Either this is a, this you are going to change, this one can be 0. In another way, this a can be a bar, this a can be a bar, and in another way whole bar can be possible. So this is a XOR 1 whole bar. So 3 answer can be possible. So like this you can convert easily x nor to XOR. Clear this point? Now the important point. Now the another value if I am asking, sir, if a XOR b is given, and now can I write, sir, this is if I am doing a bar, yes sir, and if I am doing b bar, both are same or different? Both are same. So if you are doing 2 time complement, you will get same value. Why you are getting same value? This bar if you will replace, and if you will replace this bar, so 2 times you will get bar, and 2 times bar will be cancelled. It means in XOR or in XNOR, either in XOR or in XNOR, if you are doing 2 time complement, again you will get the same value. So if again, if you want to write, sir, this is A XNOR B. So can I write A bar XNOR B bar? Yes, both value is same. Both value is same. So 2 times if you are doing complement to any variable or whole function, again you will get the same value. Second value. So graphical, just I want to tell you, you have this XOR. You have this XOR. Suppose this is A and this is B. So what you will get here? A XOR B. A XOR B. Now if you are doing here complement, if you are doing here complement, then what you will get? Then what you will get? Again, sir, this is A XOR B. You can check. Yes, again, because 0 0 XOR is 0, 1 1 XOR is 0, 0 1 XOR is 1 and 1 0 XOR is 1. So if this is 0 0, so you will get here 1 1 1 1 XOR 0, same. If this is 1 1, so here you will get 0 0. Again here you will get again same answer. If this is 0 1, so here 1 0, you will get same answer. If this is 1 0, here you will get 0 1, again you will get same answer. So always you will get same answer. Now the next important point, sir, if we have XOR, and if I am doing here bubble, one bubble and one bubble, and now suppose this is A and this is B, then what will be the answer? So what do you mean by these? This is nothing but, sir, A XOR B bar whole bar. So 2 time bar will be cancelled out. So again you will get A XOR B. This is very important. This is very important. The 2 time bubble will be cancelled out. 2 time bubble will be cancelled out. So 2 time bubble where will be present? Anywhere. Either here or here or here. 3 places can be possible. So either here 2 bubble can be present, or in second way, if here this bubble is present like this. So if this is A, this is B, so what will be the again answer? Again answer, this is one bubble and this is second bubble. Both will be cancelled out. Sir, this is A XOR B. Are you getting my point? So now you have to bubble with if single bubble, if either 3 bubble or single bubble, then you will get result A XOR B whole complement. If 2 bubble or 0 bubble, you will get A XOR B. So like this you have to handle 2 input XOR gate. Okay, so 2 things you should remember. If you will get XNOR representation, what should be your first target? XNOR representation should be replaced by first XOR representation, and you should know all the properties of XOR gate. Clear this point? So one thing you have to implement in gate exam. Clear this point? Okay. One thing you have to implement in gate exam. You are asking for semiconductor memory. Don't worry about semiconductor memory. Okay, semiconductor memory. I have discussed here buffer. Already I have discussed here inverter. Same thing I will relate with memory. It will take 15 minutes of topic. In 15 minutes, I will finish the semiconductor memory. And in gate exam, you can handle any question from semiconductor memory. So I will try to finish in the last 15 minutes semiconductor memory. I will try. Okay, and definitely in a 2 session, maybe we will get the time. Okay, so this thing should be clear. Okay, I hope this thing is also completed now. Now XNOR gate is clear, XOR gate is clear. How you can replace XNOR to XOR? Easily you can replace. So this was the 2 input, and now you have to play bubble like this. Clear this point? This and this are same, these are same, these are. So this is 4 representation of XOR gate. 4 representation of XOR gate. Now you can put anywhere extra bubble, So this will be XNOR. If you will put, sir, here bubble, so XNOR. If you will put here bubble, so XNOR. If you will put here bubble, XNOR. In this diagram, if you will put here bubble, XNOR. If you will remove this bubble, XNOR. If you will remove this bubble, XNOR. If you will put here bubble, XNOR. So anywhere if you will put one bubble or if you will remove one bubble, the circuit will become XNOR gate. Circuit will become XNOR gate. The circuit will become XNOR gate. So I hope 2 input XOR gate is definitely clear to all of you. So just confirm me. If anybody have any doubt till now, please ask me. If anybody have any doubt till now, just ask me. Okay, if anybody have any doubt, please ask me. Okay, now, sir, if you take on late night like last class, later till late night we will conduct the classes, don't worry, but I will try to finish all the topics. Network analysis, I have completed all the topics. Okay, that you can say that is a one kind of revision plus crash course. Okay, so here again I will try to finish all the chapters. Okay, so right now we are targeting exactly in gate exam, examiner can target that part. Okay, so at least you should know this thing. This was a two input, this was a two input XOR and XNOR. Now I will start three input. Okay, so can we take one break? Okay, and this is now the time is 7. Okay, so can we meet after 30 minutes, 7:30? Okay, then again we will conduct classes for 2 hours, 9 or 9:30, and again we will take 1 hour hour break, and then again we will continue the session. Okay, so this logic gate is very important. There are so many important things I will discuss after the break. Okay, the next part I will discuss 3 input, 4 input, any number of input XOR, any number of input XNOR. XNOR also I will teach you, don't worry. Okay, but XNOR will be first converted into XOR, then easily we can handle the question and 100% you will be correct. Okay, so we can take a one break, and after break we will discuss 3 input, 4 input, any number of input XOR and XNOR, and again I will discuss how you can pass any boolean by using a logic gate, and that is very important topic. If you want to pass any boolean function from logic gate, then how you can pass. Okay, so this is a 7-1. So after 29 minutes we will meet. Okay, okay, and please share the session so that next part is will going to be very important, very important, and that will be definitely new for many students. So please share the session. We will be back at 7:30. So at 7:30 you have to share. Right now you don't share. At 7:30 you have to share. Okay, in each and every Telegram group. Okay, so we will meet at 7:30. Okay, thank you. Okay, welcome back everyone. So once just confirm me audio is clear to you or not. Okay, so already we have discussed here two input XOR gate and XNOR gate and many thing in XOR gate and XNOR gate. Okay, now I am going to start very important part, uh, three input XOR gate and three input XNOR gate. Okay, three input, four input, five input we can discuss. Okay, so if we are compatible in three input, then any number of input XOR and XNOR we can easily handle. Okay, now so this all the properties of XOR and XNOR should be very much clear to you. Okay, so everyone join the session and please share the session also. Okay, so now I am going to take a very important things. Now I am going to discuss very important thing here. Okay, now so now I am going to start 3 input XOR and 3 input XNOR. Now our next target is 3 input XOR gate, and here I am going to write 3 input XNOR gate. 3 input XNOR gate. Okay, 3 input XOR gate and 3 input XNOR gate. So now here can I write 3 input XOR gate in this way? Sir, this is 3 input XOR gate. Yes sir. This is A, this is B, this is C. So here this is A XOR B XOR C. Can I write A XOR B XOR C? This is a representation of 3 input XOR gate. Yes, we can also write in this way. This is XOR gate. This is XOR gate. Okay, how many input? 3 input. This is A, B, C, and this is A XOR B XOR C. A XOR B XOR C. Clear? Okay, now here the most important thing, sir, what will be 3 input XNOR gate? What is a mathematical function? So if you can see the graphical representation, in this way we can write this is a 3 input XNOR gate. This is A, this is B, and this is C, and this is the A XOR B XOR C, and this is whole bar. This is a 3 input XNOR representation. And now here if anybody one writing like this, sir, this is 3 input XNOR gate, this is A, B, C, and if you want to write in this way, sir, this is A XOR B XOR C whole complement. Sir, this is whole complement. Now my very important question, can you write sir, A XOR B XOR C? Can you write this is 3 input? Can I divide into 2 input? Can I divide into 2 input? Can I write, sir, this is A XOR B XOR C, and then can I also write, sir, this is A XOR B XOR C? Tell me, can we write? Yes, we can write. So any 3 input easily you can divide into 2 input, or any 4 input easily you can divide into 2 input and 2 input. Any number of input easily you can divide. So here the important thing is A XOR B XOR C, anything you can write. So this value is also nothing but A XOR C XOR B, and this you can also write, sir, this is B XOR C XOR A. In any way you can write. So A XOR B XOR C, any variables you can interchange. First any 2 you can do XOR, and then result can be XOR with any three. Okay, so easily you can write here. Now the next question, sir, can you write here? And what is a represent mathematical, or you can say this is a mathematical function? Sir, can I write this? This 3 input XNOR A XNOR B XNOR C? Can I write this? And sir, both are same or both are different? No, both are different. This is very important thing. So in GATE exam, many times, not in single time, many time in 4 options they have provided. One option is 3 input XOR gate, one option is 3 input XNOR gate, like this. If in theoretical manner, if they will provide you the name 3 input XNOR gate, then 3 input XNOR gate will be A XOR B XOR C whole complement. It will not be A XNOR B XNOR C. No, you cannot write in this way. Please, So both are not same. This is the first important point. This is not is equal to ax nor bx nor c. Both are not same. Both are not same. Both are different. So if I will tell you what do you mean by 3 input XNOR gate, what you will write? You will write this ax nor bx nor c, or you will write ax or bx or c whole complement. So this is the actual representation. So what do you mean by XNOR? It can be 3 input, it can be 4 input, it can be 5 input. So what do you mean by XNOR? So first you will write XOR. First you will write XOR, then you have to put here NOT. This is a XNOR gate. It can be 3 input, it can be 4 input, it can be 5 input, it can be any number of n input. So this is nothing but A, this is nothing but B, this is nothing but C. So here you will get A XOR B XOR C, and here you will get A XOR B XOR C whole complement. In this value is not equal to A XOR B XOR C. Clear my point? Clear my point? Okay, now my question. Now come to the point. Sir, if I will write in this way, this is A and B, and now this is C, and now if I am doing in this way, sir, this is C. What will be the result? What will be the result? This result will be, you can write A XOR B whole bar, or you can also write A XOR B. You can write in this way. This is A XOR B. And sir, what is the final result? So here you can write, sir, this is A XOR B XOR C. So now if I will ask you, sir, here you can see this bubble, can I put here? Yes, this bubble, if you want, you can put here. If you can put here, and there are two bubble, this two bubble will be cancelled out. Already I tell you in previous case, two bubble easily you can cancel out. Two bubble will be same result you will get. It means, what is the result? This is A XOR B. Here, sir, this is A XOR B, and this is C. So what will be this value equal to? A XOR B XOR C. So A XOR B XOR C is equal to A XOR B XOR C. But 3 input XOR is a complement of 3 input XOR, and 3 input XOR is a complement of 3 input XOR. Clear this point? So now here very important thing, sir, A XOR B XOR C and A XOR B XOR C is same. Both are same. Okay, both are same. I will tell you, wait for that. So right now both are same. Both are not different. So first thing you should know, if examiner will provide you A XOR B XOR like this is not a 3 input XOR gate. This is not a 3 input XOR gate. Clear my point? This is also a 3 input XOR. This is also a 3 input XOR. So 3 input XOR meaning is A XOR B XOR C whole complement. This thing you should clear. In gate exam, definitely in any places, this thing is definitely required. Okay, so this is the first important point. So I hope this thing is clear to you. Now, how I can convert this? Wait for that. Again, I will explain this part. So now, one important thing you should remember here, sir, A XOR B XOR C, can we interchange A B C anywhere? Yes, you can interchange. Second important thing, sir, A XOR B, can I do XOR C? And can I also do, sir, A XOR B XOR C? Yes, you can do. Here any two XOR, then third with XNOR. Similarly, sir, can I do for here? Yes, you can also do for here. Now the next important thing is here. Sir, A XNOR B XNOR C. So can we write this? Sir, can I write this A XNOR B XNOR C? Can I write here? This is A XNOR B XNOR C, and this is equal to, sir, this is A XNOR B, and this is XNOR C. Tell me, both the value are same. Can I write here or not? This here you can write. In XOR, anywhere bracket you can place, and in XOR, from anywhere bracket you can remove. In XOR, anywhere bracket you can put, and anywhere bracket you can remove. Now my next question, can we write this value is equal to this and this value is equal to this? This is the first question. Now here, If sir A XOR B XOR C XOR D, this is 4 input. This is 4 input. So sir, can I write this A XOR B? This is XOR C XOR D. This is first one. Now, sir, can I write this A XOR, this is B XOR C like this, and then XOR D? Anything you can write. It means in XOR, any number of input are present. Either you can place the bracket anywhere or you can remove the bracket from anywhere. So XOR is totally independent of this. So XOR is very, very important. XOR is totally independent of this. You can interchange A, B, C to any places. Any 2 you can do XOR, any 3 you can do XOR, any 4 you can do XOR. Okay, so there are no any restrictions in XOR gate. Now my question, sir, these two value are same or not? 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 This is the important thing. This is the important. So can you write in this way or not? So B XOR C. What do you mean by B XOR C? Can you write in this way? See, suppose I am okay. Can you write in this way? Anybody can tell me. Anybody can tell me. It means this is a first one. Suppose this is A and this is B, and this is XOR. This is XOR, and this is XOR with C. And this is XOR with C. This is the second circuit. This is second circuit. And now the first circuit is this is A, this is B, this is C, this is B, this is C, this is A. And now here this is XOR. And now this result is XOR with A. So both the circuit will provide you same answer or not. Here you will get B XOR C. Yes. And this value XOR with this. So easily you can write, sir, this is A XOR B XOR C. So here easily you can place the bracket. What will be this value? Sir, this is nothing but A XOR B. And if you will assume this is X, so X XOR C, it means A XOR B, and this is XOR C. Both the value you are getting the same answer. So you remember this, in XOR and XNOR, bracket you can place anywhere. Are you getting my point? So here in XOR and XNOR, similarly for 4 input, sir, A XNOR, B XNOR, C XNOR, D. So you can also write A XNOR, sir, this is B XNOR, C XNOR, D. This is first bracket, this is second bracket. Okay, now similarly, we can also write here, this is A XNOR, this is B XNOR C, this is one bracket, and this is D. Anything you can write. So one important concept you should remember in XOR and XNOR, there are no any use of the bracket. There are no any use of the bracket. This is most important thing. Okay, this is most important thing. Second important thing, A XOR B XOR C and A XOR B XOR C is equal to same. But in GATE exam, how you remember this and how you can handle this? Okay, so now I am going with how you can convert XNOR into XOR. Already I tell you, you remember the property of XOR, and always first, if you will get XNOR, if in theoretical way examiner will provide you XNOR, so always you have to write XOR then complement. So suppose for example you will get 2 category of question. In first category of question, examiner will provide you 3 input XNOR gate. So what you will write? 3 input or 4 input or 5 input? Suppose 4 input. Suppose examiner are saying 4 input XNOR gate. What you will write? You will write, sir, this is A XOR B XOR C XOR D. This is XOR then complement. This is 4 input XNOR gate. Clear? Then how you can handle this? Easily you can handle this. This whole bar easily you can replace to any one complement. So what you can write? A B C D, any one to complement. So what you will get? Sir, this is A bar XOR B XOR C XOR D. And now easily A B C D value if they will provide, easily we can handle. Clear this part? Now the second question. In second question, they can provide you one function like this: A XNOR B XNOR C XNOR D. Then how you can solve this? So already I tell you what you have to do. You have to convert XNOR into XOR first. What you have to do? You have to convert XNOR into XOR first. How you can convert? How you can convert? So now one important concept you can see. I hope this thing is clear to you now. So first important concept, two XNOR will be converted into 2 XOR, will not be affect to anything. So this is a first conversion. If you want to convert A XNOR B, A XNOR B. So what you can do, if you want to convert this XNOR into XOR, if you want to convert XNOR gate into XOR, so you have three choices. Either you can do whole bar, in another way, any one complement, either A bar or B bar. So you have three choices. If you want to convert any XNOR, now the second question, if you want to convert to XNOR, if you want to convert to XNOR, so 2 XNOR will be converted into 2 XOR. This will not be affect. So you will get same thing. So this is A XOR, this is B XOR C. If you want to write, sir, 1 XNOR is converted into XOR, you will get 1 bar. If you want to convert second XNOR into XOR, you will get 2 times out. So again, you will get same answer. Again, you will get same answer. So what will be this? A XOR B XOR C. This is very, very important thing. So 2 XNOR easily you can replace by the XOR. Are you getting my point? So 2 times XNOR will be replaced by 2 times XOR. So A XNOR B XNOR C is equal to A XOR B XOR C. Okay, this is very, very important function. IIT also, one time IITians are also wrong in this place, but before 12-13 years. But after that they rectify this point. They rectify this point. But in MSQ question, they can ask you. Right now they are asking the MSQ. So in MSQ they can provide you one option, A XOR B XOR C, and they can provide you A XOR B XOR C. But if they will provide you 3 input XOR gate and 3 input XOR gate, then both will be different. So this is not a 3 input XOR gate. This is the important point. This is not a 3 input XOR gate. Getting this point? Now come to the second point. I hope this thing is clear to all of you. So once just confirm me this thing is clear or not. So please just confirm me this thing is clear or not. Please just confirm me this thing is clear or not. Just confirm me this thing is clear to you or not. Okay, please confirm, then I can proceed. Then I can proceed. Then I can proceed. Okay, so easily 2 number of XNOR will be converted into 2 number of XOR gate. Okay, now 2 number of XNOR will be converted into 2 number of XOR gate. Now if you want to find out, sir, what is the value of 3 input XNOR gate? So, sir, what is 3 input XNOR gate? 3 input XNOR gate. So 3 input XNOR gate you have to write, sir, this is A XOR B XOR C whole complement. So whole complement easily you can replace by either any one complement. So this is A bar, sir, this is XOR B XOR C, any one complement or any logic gate. If you want to remove this complement, any one logic gate should be converted into XNOR. You can also write, sir, this is A XOR B XOR C. All these three are same. So this whole bar will be either replaced by any one bar, any one complement, or any one XOR will be replaced by XNOR gate. Clear this point? You can also write this is nothing but A XNOR B XOR C. Clear this point? So what do you mean by A XOR B XOR C whole bar? This is nothing but A XOR B XOR C or A XNOR B XOR C. Clear this thing? And this this value and this value are same. This is for 3 input. Now for any number of input easily we can handle. Now for any number of input easily we can handle. I hope this property is clear to all of you. So 3 input you can handle. Now I am come with the 4 input. Now I am come with the 4 input. Okay, I hope this property is clear to all of you. Now for the 4 input. Now for the 4 input. Suppose next example I am going to consider, sir, if A XOR B XOR C XOR D is given. So what you can write? What you can write? If you want to convert all XOR gate into XNOR gate, so 2 XOR gate will be replaced by XNOR, A XNOR B XNOR C. So this will not be changed. Now if you want to replace this XNOR, so this will be D. So this can be whole bar. This can be whole bar. So A XOR B XOR C is equal to A XOR B XOR C, but A XOR B XOR C XOR D will be equal to A XOR B XOR C XOR D whole bar. Now if you want to write for 5 input, sir, for 5 input what you will get? A, this is B, this is C, this is D, and this is C. So for 5 input what you will get? How many number of XOR? 1, 2, 3, 4. So even number of XOR Gate will be replaced by even number of XNOR, or even number of XNOR will be easily replaced by even number of XOR. So not will be changed. So this will be is equal to A XNOR, B XNOR, C XNOR, D XNOR E. Both value will be same. So from here many students remember, for this 1 2 3 4, for even number of input this will be complement, but for odd number of input both will be same. But you don't remember like this even number, odd number. Okay, always one thing you should remember, all the XNOR if examiner will provide you, first you should convert into XOR, and now you can handle any question. Now you can handle any question with XOR gate, with XOR gate. Okay, with XOR gate. Clear this thing? Sir, again will be the what you are saying, sir? Sir, every day till completion. Okay, now yeah, every day we have one session. Okay, so today digital, tomorrow digital, and day after tomorrow I will take signal, and after that signal, and after that communication. Okay, so every day we have session. Okay, now sir, again, okay, when will be the next session? Tomorrow. Again tomorrow we have also one more session. Okay, Sarjit Singh, you are asking, sir जी बताओ गेट postponed होगा या नहीं होगा? Why you are asking this kind of question? Why you are asking, yaar? Okay, okay, already sir will intimate you. Okay, so you have to follow our main channel. Okay, now, so now come to the point. Here you can see for 5 input, 6 input, for any number of input easily you can handle. Now one question I am going to ask you. Now one question I am going to ask you. So now are you comfortable in this? For you can say 3 input A XOR B XOR C is equal to, you can write here A XOR B XOR C is equal to A XOR B XOR C. For 4 input it will be complement, for 2 input it will be complement, for 5 input it will be same. Okay, but my recommendation always, if examiner will provide you XOR, first you have to convert into XOR. Okay, now the next question if I am going to ask you, suppose for example, if this is A XOR B XOR C XOR D XOR E, okay, XOR F. Suppose this kind of question if examiner will provide you, so what you can write? What you can write? So you can write this, you can see this is 2 XOR. So 2 XOR will be converted into 2 XOR. It will not be affect to anyone. So this you can write, sir, this is A XOR B XOR C XOR D XOR E XOR F. You can convert into like this. Okay, so even number of XOR into XOR or XOR into XOR easily you can convert. Now the next question if I am going to ask you, next question, suppose a function f is given, suppose 1 XOR 0 XOR, this is 1, this is XOR, okay, this is 1, this is XOR, this is 0, this is XOR, this is 1. Suppose this function is given, so sometime you can get confused. First important thing, anywhere bracket you can apply. Bracket can be here, anywhere bracket you can apply. What you have to do in this situation? What you have to do in this situation? So first XNOR should be converted into XOR. What you have to do? XNOR. So how many XNOR? This is 1 and this is 2. So 2 XNOR will be converted into XOR. So this will become XOR and this will become XOR. All the value will be XOR. Now you can see how many number of 1? 1, 2, 3 and 4. How many number of 1 is even number of 1? You can also write this function in this way. How many number of 1? Sir, this is 1 XOR 1 XOR 1 XOR 1. How many number of 1? 1, 2, 3, 4. How many number of 0? 1 and 1, 2. So this XOR 0 with XOR 0. Now you remember one thing, any value XOR with 0, same value. So if you will get 0, this will be removed. So there are no any use of 0 in the XOR function. If any value XOR with 0, you will get same value. So all the 0 you can remove. All the 0 you can remove. Now you can see, sir, 1, 1, 1, 1. If you can solve this 1 XOR 1, 1 XOR 1. 1 XOR 1 is 0, 1 XOR 1 is 0, 0 XOR 0 is 0. But you don't do like this. Just count the number of 1. 1, 2, 3, 4. If number of 1 is even, the result will be 0. So this answer is 0. Never you will be wrong, and within 10 seconds, 20 seconds, 30 seconds, you can handle any question. So I hope this thing is clear to all of you. I hope this thing is clear to all of you. Okay, I hope this thing is clear to all of you. Don't do, sir, 1 XOR 0, sir, 0 XOR 1, sir, 1 XOR 1, sir, 1 XOR 0. If you will do any mistakes, you will get wrong answer. What you have to do? First you have to replace all the XNOR by XOR. If 2 number of XNOR, it will be replaced by 2 number of XOR. If 3 number of XNOR, so okay, so it will be replaced by XOR, and any variable you can do complement. So now the next question. If in this same question, so suppose next question I am going to consider, suppose function is given f, here this is 1, suppose this is XOR, this is 0, this is XNOR, and this is 1, again this is XNOR, this is 1, this is XNOR, and this is 0, this is XOR, this is 1. Suppose this thing is given, suppose this thing is given. So what you have to do? How many number of XNOR? This is 1, this is 2, this is 3. So this 2 number of XNOR will be easily converted into XOR. Okay, now here odd number of XNOR. So if you want to convert this into XOR, so what you have to do? Whole complement, or any variable you have to do complement, any variable. So either this can be 1 to 0, or this can be 0 to 1, this can be 1 to 0, this can be 1 to 0, or this can be 0 to 1, or this can be 1 to 0. So it is better you can do 1 to 0, because any value XOR with 0, you will get again 0. So what you can do, if you are doing this XNOR to XOR, you can do this value 0, or you can do whole bar. And I tell you, whole bar can be replaced by any variable complement. I hope this thing is clear. So now all the XOR, how many number of 1 you can count? Sir, 1 number of 1, 2 number of 1, 3 number of 1. So number of 1 is here. Number of 1 is here odd. So your answer will be 1. So your answer will be 1. Clear my point? So if all the gates are XOR, so what you can do? Just you can count the number of 1. This property is applicable for XOR. This property is not applicable for XNOR. In XNOR gate, for odd number of input, for even number of input, answer will be different. That's why I tell you, don't remember for XNOR. Always you have to replace all the gate by XOR and then count the number of 1. I hope this thing is clear to all of you. I hope this thing is clear to all of you. Okay, I hope this thing is clear to all of you. This is very good example, and this is very basic function. Okay, many where you can use this, many where you can use this. Now come to the point. If again I am going to ask you next property, suppose already we have studied, suppose this is A XOR B XOR C XOR D is given, and this whole complement. Already I tell you for the 2 variable, but for 4 variable you can also apply this. This whole complement you can do anywhere. So this is A bar XOR B XOR, this is C XOR D. Okay, so same thing I have done here. Now if you want to change any gate, okay, so any gate will be replaced by whole bar or any variable bar. Okay, so if you want to replace this, any gate will be replaced by XOR to XOR. Okay, one more question I am going to ask you. Next question. So now suppose if a function is given, suppose this is A XOR 1 XNOR, this is A bar, suppose this is XOR, this is 0, suppose this is XNOR, this is 1, suppose this is XOR A. Suppose this kind of function is given. Here variable, here the function is depend on 0, 1 and A bar and A. Okay, so first thing what you have to do, always all the XNOR should be replaced by, this is 1 XNOR, 2 XNOR. So 2 XNOR will be replaced by this XOR and XOR. Can you replace like this? Yes sir, we can replace by this. Now you can see, you can write in this way, sir, this is F is equal to, can I write, sir, this is A, this is XOR, sir, this is A XOR A, and this is A bar, A XOR A bar. So just I am going to write A bar A. Okay, now 1 and 0. How many number of 1? This is, sir, XOR 1, and again this is XOR 1, and this is XOR 0. XOR 0. Can you write in this way? Any value XOR with 0, so you can remove this 0. From here also you can remove 0. Here also you can remove this 0. Okay, but if you will write in basic order, it will be helpful to you. So this 0 will be removed. Okay, now A XOR A, same value XOR with same value 0. So same value XOR with same value 0. So this whole will be removed, because same value XOR with same value 0, and 0 XOR any value, it will not be changed. So this will be 0. Now the same value, this will be removed, only A bar. So your answer will be A bar. This is the answer. Your answer will be A bar. Easily you can handle this. Otherwise many times student can be wrong here. Okay, so easily you can handle like this. So what you have to do, all the XNOR should be converted into XOR first. All the XNOR should be converted into XOR first, and then all the same value XOR 0 you can remove, all the 0 you can also remove, all the 0. So in the question what you can do, first you can remove this 0. Okay sir, this is A, this is A, you can remove this. 2 number of A will be removed. Sir, 2 number of 1 will be removed. So what will be the remaining? Only A bar. Answer is A bar. Like this you can handle. Now one more question, and this answer you have to give me. Suppose a function is given, suppose this is A XOR, this is B XNOR. Okay, this is suppose 1, this is XOR, this is A bar, this is XNOR, this is B bar, this is XOR, this is 1, this is XNOR, this is B. Suppose this function is given. Anybody can tell me what will be the answer? I am waiting for your answer. What will be the answer for this? 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 How you can handle in GATE exam? So what you have to do first? Always you have to replace, sir, this is X, this XNOR and XNOR. So what you can do, sir, this is XOR and this is XOR. Can you do? Can you do? Now the important, now again one more important concept I am telling you. Sir, 1 complement, 2 complement, 2 time complement, you can cancel this. Sir, how we can cancel? Any variable complement, whole complement, this complement, whole complement. So what you have to do first in any question, in every question, first you have to replace XNOR to XOR, then you have to replace all the complement. Then you have to replace all the complement. Then your question will be only depend on 0, 1 and variables. 0, 1 and variable, and all the gate will be XOR gate. Are you getting my point? So this 2 time complement will be cancelled. Okay, now you can see, sir, this is A, this is A. So 2 time A will be cancelled. Yes. Sir, this A and this A XOR will be 0. Okay. Sir, this is B and this is B. Sir, this B and this B XOR with 0. Okay. Sir, this one and this one, sir, XOR with 0. What will the answer? Okay. Sorry. This is 1 XNOR, 2 XNOR, this is 3 XNOR. This was 3 XNOR. So if I am going to change this XNOR, this will just I am writing B bar. Okay, so this 2 you have to cancel. What is the answer? So your answer will be B bar. So you are getting your answer B bar. So here answer is B bar. Here answer is B bar. Easily you can handle. One more question I am going to take. So can you handle this kind of question? This directly this question you will not get in GATE exam, but this property will be very important. 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 Clear? Now one question I am providing you, and this answer please you have to give me. Okay, now suppose a function f is given. Suppose A bar XOR with B bar XNOR with A. This is XOR with B. This is XNOR with 1. This is 1. And this is again XNOR with 0, and this is XOR with A. This function if I have provided, so what you have to do? First thing, you can do, sir, this bar and this bar will be cancelled out. Okay, 2 time bar will be cancelled out. Okay, sir, how many time this XNOR? This is 1 time, sir, this is 2nd time, and this is 3rd time. So if 3 time XNOR gate, okay, this will be replaced by XOR. Okay, this will be replaced by XOR. But if you are going to replace this, so any one variable will be changed. So what you can change? Don't do A and B. What you can change? This one you can change to 0. This one you can change to 0. Now you can see here, sir, this 0 and 0 will not be affect. Okay, sir, this A and A will be A XOR A 0. Okay, sir, this B and this B will be cancel out. B XOR B will be 0. What will be the answer? A. So here answer is A. You can see in within 5 to 10 seconds, within 5 to 10 seconds we can handle any question here. So I hope you can easily handle 3 input, 4 input, 5 input, any number of XOR gate easily you can handle. Sometime in GATE exam you will get this kind of question. Suppose we have 1 input, suppose like this. and here this is XOR gate, and if this is X, okay, this is X XOR X. Okay, now again this output is again XOR with the same value X. Again this output is again XOR with the same value XOR, like this. Okay, like this. What will be the output? What will be the output? So you can see here X XOR X. How many times? 1, 2. This is 1 and 2. So here this is X XOR X. X XOR X, same value. Now again this is 1, 2, this is 3 and this is 4. How many times you are getting here? Sir, this is 4 times. X XOR X XOR X XOR X. So how many times you are getting? So X XOR X is 0, you know. So 2 you have to cancel. This 2 you have to cancel. Everything is cancelled. Your result is 0. So your answer is 0. So here F you are getting 0. This is the answer. Many times student will remember, sir, if even number up input, if odd number up input. Why you will go with that? Just go with basic process. Just go with basic process. Like this, easily any question you can handle. Any question you can handle. Okay, any question you can handle. So now one question I am going to ask you. Okay, now suppose we have one XNOR gate here. Suppose we have one XNOR gate here, and here again we have one XNOR gate like this. This is XNOR gate. Okay, now again if I am getting here one XOR gate like this. Okay, this is A, this is B, this is C, and this is D. This is D. And now here this is function F. This is function F. So now I am asking, what is function F is equal to question mark. 4 options I am going to provide you, and this is a MSQ question. This question is a MSQ. This question is MSQ. Okay, so you have to give me the answer here. This question answer you have to provide me. Sir, first answer is, first option is A XOR B XOR C XOR D. This is the option A. Okay, sir, option B is A XNOR B XNOR C XNOR D. Now the option C is, sir, A XNOR B XOR C XNOR D. Okay, now the third option is, sir, this is A XOR B XNOR C XOR D. Which will be the correct answer? This is MSQ. This is MSQ. A, B, C, D. Which will be the correct answer? Which will be the correct answer? Which will be the correct answer? I am waiting for your answer. I am waiting for your answer. I am waiting for your answer. Everybody tell me, which will be the correct answer? In mind we can handle. In mind we can handle. Okay, anybody can handle this category of question. 10 second, 20 second is required only. 10 second and 20 second is required only. Tell me answer for this question, everyone. Okay. One answer I am getting D. One answer I am getting. Now you can say, sir, can I pass this bubble from here to here? Yes, you can push. I can remove this. Okay. Sir, can I put this bubble here to here? Here. Sir, this is 2 input. So this 2 bubble can I cancel out? Sir, this bubble and this bubble will be cancelled out. Already we have studied, if in any XOR gate 2 bubble you are getting, that will be cancelled out. So what is the answer? Sir, here we are getting A XOR B. Always you have to concentrate on, always you have to concentrate on XOR. If XNOR will be provided, you have to remove XNOR. That will be easier to you. Sir, this is C XOR D. And if you will remove this bubble, what will be the answer? This XOR this. So what you will get? A XOR B XOR C XOR D. This is the answer. This is the answer. And this you can also write. This is 3 number of XOR. So this 3 you cannot replace, but yes, 2 XOR will be replaced by 2 XOR. So here you can see A XOR B XOR. Yes, this can be the correct answer. Here 2 XOR, here 3 number of XOR. So this cannot be answer. If you want to replace by XOR, so this will be A XOR, B XOR, C XOR, D whole bar. This will be whole bar because here 3 number of XOR will be replaced by 3 number of XOR. So you will get any either A, B, C, D, any one variable complement or whole complement. Okay, so this will not be answer. And now here you can see only this 2 XOR is replaced by 2 XOR. Yes, so this can be also a correct answer. Yes. Now here 2 XOR and 1 XOR. So this cannot be answer because this value and this value is same. Here this value you can this value and this value means B and D are same here and A and C are same. So here B and D are same. These two are same and these two are same. Why same? Sir, here 3 number of XOR. Okay, so this 2 XOR will be replaced by XOR. Yes, so both are same. Sir, here this 3 number of XOR. So any two, this 2 XOR will be replaced by XOR. Yes, this is. So A and C is the correct answer. So his answer is A and C. Why you are getting wrong? Why you are getting wrong? Okay, this is very basic question. This is very basic question. This is very basic question. Okay, last gate was XOR. Yeah, this was XOR. This was XOR. Okay, this was XOR. Clear this point? Okay, now. Okay, so concept should be clear. If you are getting wrong, no worry. If you are getting wrong because of any misunderstanding with question, if you are assuming here this was bubble was present, so no worry. Concept easily you can apply. But here two answer. Here two answer is possible. Two answer is possible, and both are complement to each other. Both are complement to each other. Okay, now my next question. Now my next question. Next problem I am just asking to you. Next problem. Next problem. So here you can see, sir. Suppose here again same category of question is A XOR B, and now this is AB, and this is CD, and this is CD, like this, and now again this is XOR, and now this is XOR. Okay, all the XOR, and this is your Y. This is Y. So here what examiner asking? Sum of A B C D Y is. So what we are asking? Sum of A B C D Y is. Sum of A B C D Y. So what is the sum of A B C D Y is? First option is 0 or even number. 0 or even number. Second option is, first option is 0 or even number. Okay, now the second option is here odd number. Okay, third option is only even number, or you can write here 0 or odd number. 0 or odd number. Okay, this is third option, and one more options we can also consider here. Only even number. Okay, only even number. So these four options I will provide you. Okay, this is MCQ. This is not MSQ. This is MCQ. Okay, so only one answer is correct. Now we are asking sum of A, B, C, D, and Y is. What will be the sum of A, B, C, D, and Y is? Anybody can solve this? Anybody can solve this question? Anybody can solve this question? Anybody can solve this question? Tell me, anybody can solve this question? Tell me. I am waiting for your answer. I am waiting for your answer. Sir, will there be everyday session? Yeah, every day we will get a session. But please you have to attend today's session and give me the answer. Properly you have to attend and give me the answer, please. Okay, now digital tomorrow. Digital only we have 2 sessions, today and tomorrow. Okay, in 2 sessions we will finish the digital. Okay, just tell me everyone what will be the answer for this. What will be the answer for this? This time is not required. Within 1 minute you have to handle. So now you can see what will be the y. Y will be nothing but sir, A XOR B XOR C XOR D. Okay, then what will be the y? If number of 1 is here even, already I tell you, including result. So A comma B comma C comma D comma, and this is y. How many number of 1? So number of 1s is even, always including result. And if all these 4 values 0, result is 0. So what will be the answer? In the sum of A, B, C, D, Y, in A, B, C, D, Y, number of 1 is even or 0. Or all are 0. So what will be the sum? If here number of 1 is even, so even number of 1, sum will be even number. And if all the value are 0, then 0 sum will be 0. So what will be the answer? What will be the answer? Sir, 0 or even number. 0 or even number. So if you will write A, B, C, D, and if you will write here y, and if you will find out here sum of this, so what you will get? 0, 0, 0, 0, 0, 0, 0, 1. Okay, some table just I am going to write 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1. This is 0, 1, 1, 0. This is 0, 1, 1. This is 1, 0, 0, 0. Like this here to complete. This is 1, 0, 0, 1. This is 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, and last 1, 1, 1, 1. You will get like this. How you can find out y? Don't do A XOR B XOR C XOR D. Count the number of 1. Number of 1, here 4 0. So you will get 0. Here number of 1 is odd. So here you will get 1. Including result, number of 1 should be even. Here number of 1 is odd. Here 1. Here number of 1 is even 0. Here odd, you will get here even. This is 0. Here even. This is 0. Here odd, you will get 1. Here odd, you will get 1. Here even. This is 0. Here even, you will get 0. Here odd, you will get 1. Here this is even, you will get 0. Here odd, you will get 1. Here odd, you will get 1. Here even, you will get 0. What will be the sum of this 1, 2, 3, 4, 5? Always here this is 0. Here this is 2. Sir, here this is 2. 1 plus 1. This is 2. Here this is 1 plus 1, 2. 1 plus 1, 2. 1 plus 1, 2. This is 4. Here this is 2. Here this is 2. Here again this is 2. Here this is 4. Here sum of this 2. Here sum of this 4. 1, 2, 3. This is 4. And this is 1, 2, 3, 4. So you are getting the answer sum either 0 or 2 or 4. Either 0 or 2 or 4. So what will the answer? Either 0 or even number. This cannot be odd number. This cannot be 0 or odd number. This cannot be only even number. Answer will be 0 or even number. This property already we have studied. Just for if any number of XOR gate, so just count the number of 1. If number of 1 is even, result is 0. If number of 1 is odd, result is 1. Including result, always number of 1 is even. This is very important thing. This is very important thing. This is very important thing. Okay, this is very important thing. Clear? See. Okay, so I request to all of you, please reply. Okay, in between the session, please reply. Okay, so that I can complete all the topic. Okay, so focus on what I am going to teach you right now, and you have to reply me the answer. You have to properly reply me the answer. You have to properly reply me the answer. I hope this thing is clear to all of you. I hope this thing is clear to all of you. Clear this one? Okay, now I am going to take some more problem from the logic gate. Okay, now suppose for example one question is given, and this is very basic question. Just you can note down. Next problem is given here. Okay, next problem is given here. Next problem is given here. One XOR gate and one XNOR gate is given. Here this is XOR gate. Here this is XOR gate, and here one XNOR gate. This is XNOR gate. Okay, and both of the input is same. Here both of the input is same. This is A and this is B. This is A and this is B. And now one more input is given. One more input is given. This is C. And all these three input are connected with XOR gate. All these three input are connected with XOR gate. Okay, now just I am going to remove this. I hope this problem is clear to all of you. Okay, now this question is given. Okay, now one XOR gate, two input, one XNOR gate, both the input is same, and one three input XOR gate. Okay, sorry, this is XNOR gate. This one is XNOR gate. This is three input XNOR gate. Don't write this three input complement. No. Okay, now here examiner are saying for output f to be 1. Now they are saying this is the output f, and they are saying f is equal to 1. So what will be A, B and C? Now they are asking what will be A, B and C. Okay, so four options I am going to write here. Four options I am going to write here, and this answer you have to provide me. A is equal to 1, A is equal to 1, B is equal to 1, this is first option, and C is equal to 0. C is equal to 0. Now the second option, this is option A. And now the second option, A is equal to 0, B is equal to 1 and C is equal to 0. Now the C option, A is equal to 0, B is equal to 0 and C is equal to 0. And now the D option, A is equal to here 1, B is equal to 0 and C is equal to 1. Four options they have provided. This is MCQ question. This is MCQ, multiple choice question. So only one answer is possible here. 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 Now tell me. Okay, I am waiting for your answer. For this question, I am waiting for your answer. I am waiting for your answer here. Output is 1. So if when examiner will provide you the output, you can proceed from the output. You can proceed from the output. Okay, just I am providing you some minutes. Okay, some seconds. If you can give me the answer. If you can give me the answer. Okay, if you can give me the answer. Anybody can give me the answer? Very basic question. You can proceed from the last. So now you can see if this app is 1. So here what you will get? Here app is 0. And this is a XOR. At this point this is XOR. How many number of input? 3 number of input. So if result is 0, it means in this 3 number of input, number of ones should be even. So what I can say in this 3 input, number of ones is even. That's why you will get result 0. Yes. So number of 1 is even. So here either all these 3 are 0 or 2 are the 1. So now you can get this AB. Here this is A XOR B. And here this is A XOR B whole bar. It means if this is 0, so this will be 1, and if this is 1, this will be 0. It means all these 3 cannot be 0. So what you are getting here, in this 2, 1 is 1 and second one is 0. Any one is 1 and any second is 0. What will be third one? This should be 100% 1. So here C should be 1. And A and B can be anything. So what can be the answer here? Sir, C should be 1 and A can be anything and B can be anything. So here it is not going to be depending on A and B. It is not going to be depending on A and B. If C is 1, your output will be 1. You can see again I am going to draw. This is your A, B, and here this is XOR. And here this is again A, B, and here this is XOR. This is XOR. This is A, B, and this is A, B. What will be this output? If this output is 1, this will be 0. because both are complement. If this is 0, this is 1, and now this is going with 1 XOR. Can I say? And here this third input is C. Can I write this is XOR? Can I say here 0? Because here this is bubble, and if this is 1, so before bubble the output should be 0. So can I say this is 0? When this will be 0, either this is 0 or 1, and this is 1 or 0. So in this two, any one input is 1. And for 3 input XOR, if output should be 0, then input in input number of 1 should be even number of 1. So here already 1 is 0, 1 is 1, so definitely this should be 1. So C should be 1, and A and B can be anything. A, B can be anything, and C should be 1. So here answer is option D. Here answer is option D. Okay. Many times students are wrong in this question. Why students are wrong in this question? Just I am telling you. Many times students are wrong in this question. Why students are wrong in this question? If this thing is given, so what student will write here? Sir, this is A XOR B. Okay. Sir, this is A XOR B. Okay. This is C. So what student will write here? Student will write this is A XOR B. This is the first value. This second value XOR. This is A XOR B. This is second value, and this is XOR with C. This is not, this is, suppose this is X, this is Y, this is Z. So this is not X XOR Y XOR Z. No, this is wrong. Already we have studied. This is wrong. You cannot write this is 3 input XOR. This is 3 input XOR gate. But 3 input XOR gate, you cannot write all the 3 input XOR. You have to write this X XOR Y XOR Z whole complement. Already we have studied here. So many times many students are wrong because of this. Already we have studied this logic earlier. I hope this thing is clear to all of you. Already we have studied this logic earlier. Okay, now come to the next point. Now come to the next point. Okay, so okay, good. Already you have provided me answer D. Good, good, good. Okay, very good. Okay, this thing I am expecting from everyone. Okay, this thing I am expecting from everyone. Now one more question I am going to ask you. Okay, one very basic question I am going to ask you. Okay, one very basic question, and this answer you have to provide me. I hope this concept is clear to you. Now the next question. Now the next question. Okay, now easily you can handle the logic gate. Now easily you can handle the logic gate. So here one input is given. Next problem, just you can note down. One input is given here A. One input is given here A, and here this is a NOT gate. Here this is a NOT gate, and now this is connected with a one XNOR gate, 2 input XNOR gate, and this input is B. This input is B, and both the output is connected with one XOR gate. One XOR gate. This thing is given. This thing is given, and now what examiner asking? This is a Z. This is Z. So what is the function of that? They provided 4 truth table. Okay, but I am not going to provide you 4 options here. What will be the output Z? Anybody can tell me the answer. I am waiting for your answer. I am waiting for your answer. Okay, this kind of question easily you can handle within 10 seconds, 15 seconds, more. Okay, at least less than 1 minute. Just tell me what will be this answer. What will be this answer? I am waiting for your answer. I am waiting for your answer, dear. Option B. Okay, B. Okay, here option I have not provided. Good. How you can handle this? You can see my approach. I don't know by which approach you have handled, but now you can see my approach. Okay, now always what should be your target? XNOR gate should be converted into XOR. This should be your in circuit also. So this bubble I can remove from here, and this bubble can I put here? Yes sir, we can put. And you know very well this is 2 input XOR gate, and 2 bubble can be cancelled. This is NOT gate, so this NOT gate, this bubble can I put here? Yes, you can put here, and this 2 bubble will be cancel out. Yes sir, cancel out. So here this is nothing but A. Sir, this is A, this is B. So here this is A XOR B, and here this is A. So what will be that? Sir, A XOR B. What will be A and A will be cancelled out. What will be the answer? Answer will be B. Okay, good. Okay, good. In correct time, you have to give me answer for this, but I don't know what approach you have applied here. But just here, we have to play with bubble. We have to play with a bubble. Okay, and XOR gate should be converted into XOR. Okay, this kind of question at least we have to handle in gate exam. Okay, so now from my side, uh, we can handle any kind of questions from the logic gate. Okay, so I hope now logic gate topic is over. In logic gate, I will tell you how we can proceed Boolean function, by logic gate. But before going to start that part, okay, first we have to study the Boolean function. So now I am going to start okay, revision for Boolean function. Then I will combine your Boolean function as well as logic gate topic. Clear this point? And after that we will study K-map, and then after K-map then we will start combinational logic circuit. Clear this point? So now I am going to start our next topic, that is Boolean algebra. And I know you are expert in the Boolean algebra, so only important points, okay, just I will tell you for the Boolean algebra. Okay, now so everything is here. Okay, yeah, same approach. If you have applied the, if you have cancelled the bubble, so now you can feel, now you are going to be expert in digital. If you have cancelled the bubble, then definitely you are at a good level in this logic gate. Okay, so now I am going with here next topic, Boolean algebra. Okay, now practically this topic is not much important. We should be comfortable in here SOP and POS form. So practically here two kinds of terms generally we have to study here in Boolean algebra. Okay, so first I will tell you canonical form. Here three category of forms can be possible. Suppose if we have a function and suppose variable is x, y, z. So what do you mean by this? It means we have a circuit that input is x, y, z and output is this function. So if I will tell you this, it means we have a digital circuit. If we have a digital circuit, this input is x, y, z. It means this input is x, y, z and your output is function of x, y, z. Okay, so now how you can write this function? So there are lots of different way we can write this function. So this function we can write, this is Boolean function. Here x, y, z is a binary variable. Here x, y, z is a binary data. I can say this is a binary data. So x, y, z can be either 0 or 1. Okay, so here this Boolean function f x, y, z, this is nothing but Boolean function. This is nothing but, we can write this is a Boolean function. So if I will ask you how many different Boolean function representation is possible for n variable, so you should know this thing. So one formula you should know, sometime examiner will ask you. So for n variable, number of different Boolean function. How many number of different Boolean function you can write? This answer is nothing but 2 raised to power n. We can write this in bracket 2 raised to power n. So if n is equal to 1, so number of Boolean function is 2 raised to power 1 is equal to 4. If n is equal to 2, so how many Boolean function? 2 raised to power 2 raised to power 2, 2 raised to power 4 is equal to 16. If n is equal to 3, so this is 2 raised to power 3. So this is 2 raised to power 8, and 2 raised to power 8 is 256. This is 256. So 256 practically Boolean function you can now draw. But just I will tell you what will be for one variable. So for one variable, suppose for example, and suppose this variable is x. And this is digital circuit. This is a digital circuit. Okay, so how many Boolean function is possible here? You will write this as function of x. So how many function is possible? So first function is 0, result is 0, x can be anything, result is 0, okay. Second function is result is 1, yes. Third can be sir x, and fourth can be x bar. How many different Boolean function? 4. Similarly, for 2 variable you can write 16 Boolean function. For 3 variable 256 different Boolean function. Ideally you cannot write in your notebook, clear this point, but conceptually we can say. So lots of Boolean function for 3 variable we can write, but for digital circuit will provide you one answer, one result. Okay, so now my question is how many number of Boolean function can be possible? So how, if you are getting a one answer, so in how many different ways you can write? So here if you want to represent this Boolean function, so we know this thing. First one is canonical form, and in canonical form we have two representation. First one is SOP and second one is POS. So in canonical form, in second way you can also write in a compressed form, compressed form you can also write compressed form. You can also write this is a minimized form, minimized form of a Boolean function. Again minimized form you can write in two way. This again we can write in SOP and POS. Now what is a canonical form? Canonical form is nothing but this is a complete form, or you can say expanded form. This is a compressed form, or canonical form is a expanded form. So we can write this is nothing but this is a expand form, or you can say expanded form. Okay, this is a expanded form and this is a compressed form. So if examiner will provide you compressed form, you have to write expanded form. If examiner will provide you expanded form, you have to write compressed form. If examiner will provide you the in between any form, neither full compressed or nor full expand, so you have to find out either this or this, anything. Okay, so we know this thing very well. I hope you know this thing very well. Just I am going to revise this part. Okay, how you can convert any form to another form. Okay, and how, what is the meaning of this SOP and POS? Okay, what is the meaning of this SOP and POS? So now here suppose I am going to assume a truth table. Suppose truth table. So I am going to assume a truth table. So first here you have to study mean terms and max term. First mean terms and max term. So what is the mean terms and max term? What is a mean term and max term? Mean term we can represent by small m, and max term we can represent by capital M. So suppose I am going to write a truth table. Suppose here two variable x and y, and this is a function of xy. Okay, so now if xy is 0 0, this is 0 1, this is 1 0 and 1 1. So what you can write this 0 0? So in terms of mean term, so here first I am going to write what is a mean term of this, what is a mean term of this, and what is a max term of this. So you have to write mean term and max term. So here I can write in mean term, this is a product term. So mean term is nothing but this is a product term, this is nothing but product term, and product term multiplication result should be 1, and this max term is a sum term. This is a sum term, and sums result should be 0. This should be our target. So what you can write, if you want this multiplication, this, and result should be 1, so this should be complement, this should be complement. So 0 0 you will write this is x dash y dash. What you will write, and we can also write this a mean term for decimal 0. If you will write here decimal, so what will be the decimal for this, sir? This is 0 1 2 3. So decimal 0 or binary 0 0, mean term you will write is small m0, that is nothing but x dash y dash. Now really what you will write, sir, this is nothing but x dash y, and we can write this is m1, this is nothing but x y dash, and this is nothing but m2, this you can write x y, and this is nothing but m3. Okay, now come to the max term. We have to add both the terms and the result should be 0. So 0 plus 0 will be 0. So what you will write, x plus y. You will write x plus y, and this is nothing but capital M0. Now what you can write this, sir, this is x plus y dash, and this is nothing but m1. Here 1 0. So you can write this is this one bar. So x dash plus y, and this is nothing but m2, and this is 1 1. So what you will write, this is x dash plus y dash, and this is nothing but m3. So this is for 2 variables. Similarly for 3 variable, similarly for 4 variable we can also write. So now I am again I am going to take for 3 variable. So for 3 variable, how you can write, suppose this is decimal value, the decimal value, and here 3 variable x, y, z. So what will be this mean term, what will be the max term, and what will be the max term, what will be the max term. Okay, so again I am going to write decimal 0 1 2 3 4 5 6 7, total 8 value is possible. Yes, 0 0 0 0 0 1, this is 0 1 0, this is 0 1 1, this is 1 0 0, this is 1 0 1, this is 1 1 0, and this is 1 1 1. So 0 0 0 mean term, this is nothing but m0, this is m1, this is m2, this is m3, this is m4, this is m5, this is m6, and this is m7. So what will be the m0 here? 0 0 0. You can write this x dash, y dash, z dash. Okay, so 0 0 0 you can write x dash, y dash, z dash. So 0 0 1, this is x dash, y dash, z. What is 0 1 0? You can write this x dash, y, z dash. What is m3 0 1 1? This is x dash, y, z. So all the 0 will be complement, 1 will be as it is, and you have to multiply. Now 1 0 0, this is x, y dash, z dash. What is 5 1 0 1? This is x, y dash, and z. 1 0 1. Now 1 1 0, this is x, y, z dash, and what is m7? X, y, z. So you can write in this way. So first you have to write any variable into either mean term or max term. Okay, then we can use this. So what is max term? We can write, sir, this is m0. So here 0 plus 0 plus 0 is 0. So you can write x plus y plus z. Now what is m1? What is m1? 0 plus 0 plus 1 bar. So what you can write? X plus y plus z dash. Similarly, what is m2? This is 0 1 0. So 0 as it is, and this is y dash 0 1, and this is z 0 1 0. 1 will be complement, 0 will be as it is. Similarly, this is m3. This is 0 1 1. So 0 will be as it is, 1 will be complement, and this is 1 will be complement. What will be m4? M4 will be 1 0 0. So this is x dash plus y plus z. What is the m5? This is 1 0 1. So m5 you can write, this is 1. 1 means complement, 0 means as it is, and 1 means complement. Now this is m6, and this is m7. Sorry, this is m7. So what is m6? 1 1 0. So this is nothing but x dash plus y dash plus z. And what is m7? X dash plus y dash plus z dash. X dash plus y dash plus z dash. Okay, so I hope you know very well this thing. Okay, so we can write any truth table and any variable in that, okay, in terms of either mean term or max term. Clear this point? Now if you want to, suppose if I am going to provide you a truth table, then how you can write SOP and how you can write POS. So now you can see here, suppose I am going to take one circuit. And this truth table is given, and this truth table is given. Okay, now suppose the circuit is 2 input XOR gate, I am going to assume, and suppose this circuit is the 2 input XOR gate. Suppose 3 input XOR gate, I am considering 3 input XOR gate. Suppose 3 input XOR gate is my circuit. So what you can write? So I am going to write 3 input is x, y, z. Okay, and the function is the function x, y, z, and this is nothing but x XOR y XOR z, like this. Or suppose this truth table is given already. Okay, so already the function is given, then easily you can write the truth table, or examiner can also provide you the truth table. Okay, so now 0 0 0, this is 0 0 1, this is 0 1 0, this is 0 1 1, this is 1 0 0, 1 0 1, 1 1 0, and 1 1 1. So what will be this 3 XOR gate? What will be this XOR gate? What will be here this XOR gate? So what will be this XOR gate? So here this XOR gate will be number of 1 you can count. So number of 1 is here E1. So this is 0, odd, this is 1, this is odd 1, this is E1, this is 0, this is odd 1, this is E1 0, this is E1 0, this is odd, this is 1. Like this you can write. This is, you can write, this is the output. This, but how you can write this function? How you can write this function? So you have to consider, if you want to write SOP, so you have to consider 1. If you want to write POS, you have to consider 0. So here, if you want to write SOP function, so SOP, what you can write, what is the function x, y, z? So here I can write function x, y, z is equal to, what you can write, if you want to write SOP, so SOP is represented by summation, and sometime you can also represent by small m. Either summation or small m can also be used. Either any one, either summation or small m, or both the term, or any one term. And in bracket you can write which mean term. We can write this is decimal quantity. So this decimal is nothing but this is 0, 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. Where you are getting 1? Where you are getting 1? So 1 we are getting at 1 position, and you can see at 2nd position, and at 4th position, and at 7th position. So this is nothing but 1, 2, 4, 7. This is nothing but 1, 2, 4, 7. So this is 1, 2, 4, and 7. This is 1, 2, 4, and this is the main term. If you want to write in terms of max term, means POS. So POS will represent, this is a function x, y, z, and POS will represented either by here pi, or sometime this is capital M. Either both or any one. Sometime pi represent POS, capital M represent POS. Okay, so POS if you want to write, so this is nothing but 0. So remaining term 1, 2, 4, 7, this is 0, and this is 3, this is 5, 6. So this is 0, 3, 5, and 6. So if any truth table is given, so we can write in terms of SOP or POS, means in terms of mean term or in terms of max term. At least we have to write. Now what will be the Boolean function? Now what will be the Boolean function here? Then what will be the Boolean function here? So, and one more important thing you should remember, this is for if 3 input XOR gate, the answer is 1, 2, 4, 7. If 3 input XOR gate, the answer is 1, 2, 4. And you remember, because many time we will use this. Many time we will use this. Okay, many time we will use this. Now if you want to write this, if you want to write this Boolean function, you can write. Easily you can write. If you want to write this Boolean function, easily you can write. How you can write? How we can write this Boolean function? This is a mean term of 1, 2, 4, 7. Already we have studied in the previous table. So if you want to write this 1, 2, 4, 7. So how you can write? This variable is x, y, z. The variable is x, y, z. So 1 you can write 0, 0, 1. So this is nothing but x dash y dash z. And now 2, this is x dash y z. This is 0, 1, 0. And now 4, 1, 0, 0. X, y dash z dash. And what is 7? X, y, z. Like this. So Boolean function you can write. And now if you want, you can simplify this, or you can compress this by using K-map. Okay, so now the second function, this is your SOP. This is your SOP. So you can say this function is SOP. So sum of product. So what we can say, this is nothing but sum of product. So first you are going to find out product term, then product sum. So this is called sum of product term. This is called sum of product term. Similarly, if you want to write POS in a Boolean function, so what you will get here, this is a function of x, y, z, and this function is nothing but this is the pi of our max term of 0, 3, 5, 6, 0, 3, 5, and 6. So what you can write to 0? 0 means x, y, z, and all are 0, 0, 0. So you will write x plus y plus z in first bracket. Now this is 0, 0, 0 means 0. 3 means 0, 1, 1. So what you will write? This is 0, and 1 will be complement, and 1 will be complement. 1, 0, 0. Now in the third bracket 5. 5 means 1, 0, 1. 1 will be complement 1, and this is 0, and this is 1. X dash plus y plus z dash. And what is 6, 1, 1, 0? So this is x dash plus y dash plus z. So here two answer can be possible. In two way you can represent to any function. Okay, we can represent any function in two different ways. Okay, So first way is SOP and second way is POS. Okay, same function will provide you two answer. Same function will provide you two answer. Same function will provide you two answer. Clear this point? Now if I will ask you, can you convert SOP to POS and POS to SOP? Yes, easily we can convert. Easily we can convert SOP to POS and POS to SOP. How? If you know this thing 1 2 4 7, so what will be the POS? Directly you can write. Don't write here. Suppose for example, one example if I am going to consider, suppose if we will get function x y z, we will get this is a suppose 0 3 5 and 7. Suppose what is the POS form? So directly you can write, sir, what is the POS form here? Directly we can write this is pi up. Which term are not presenting here? But you have to complete all the terms. So you will get here 0 is present, 1 is not present, so 1, 2 is also not present, 3 is present here, 4 is present, not present. You can write here 5 is already present, 6 is not present, 7 is present. And how many total term? So can I write this plus this will be complete term. This plus this will be 0, 1, 2, 3, 4, 5, 6, 7. So if you will add SOP plus POS, so you will get number of rows in a truth table. Number of rows in a truth table. If you will add this 2, so this will be 2 raised to power 3 is equal to 8. Okay. Now one more example if I am going to consider. One more example. If you are getting function x, y, z, suppose this is sum of 0, 3, 6. Only here 3 terms. So in POS what you will get? So in POS this is nothing but pi. Here if this is 3 terms, so you will get 5 terms. So here 1, this is 2, 3 already present, here 4, 5 and 7. This will be the answer. So if total SOP number of min terms you can say and number of max term, sum will be always. So complete you will get sum of the here min term and sum of the max term. This is max min term, this is min, this is min. This is max, this is max, this is max and this is max. So here 4 min and 4 max term. Here 3 min and 5 max term. So number of min term plus max term will be here total number of rows in a truth table. Okay. So this thing should be remembered to you. Now if a Boolean function will be provided. So if a truth table will be provided, can we write SOP and POS? If anyone is provided, so can you write another function? Yes, we can write the another function. Now the third question, can you expand this function? Yes, we can expand the function. Here I am going to write, if you want to expand this function, first you can see how many number of variable, 3 variable. So just you can write 0 means 0, 0, 0. It means this is nothing but x dash, y dash, z dash plus what do you mean by 3, 1, 1, 0? So we can write this is x, y, z dash 1, 1, 0. What is 6? Sorry, 3 means 0, 1, 1. Okay, this is 6. 3 means this is 0 means 0, 0, 0, x dash, y dash, z dash. 3 means 0, 1, 1. So this is 0 x dash, this is y, z. Now 6, 1, 0, 0. So this is x, y dash, z dash. Similarly, you can also write a POS form. Similarly, here 5 terms you will get. 1 term, this is second bracket, third bracket, fourth bracket, 5 bracket. Okay, so we can write POS. Okay, so if truth table will be provided, we can write SOP POS. If one SOP provided, we can write POS. If SOP or PS anything provided, we can expand the, or we can write in terms of Boolean function. Now the question, if reverse question will be asked by the examiner, reverse question. Okay, and now how we can write SOP and POS? If examiner will provide you reverse question, then how we can handle? So suppose for example, now if examiner will provide you the reverse question, so here first I am going to ask you first problem, if suppose one function f x y z is given, suppose for example x dash y z dash plus x y z plus x dash y z dash plus x y dash z dash, like this. Okay, so here 4 term they have provided. So how you can write? So you can see this is x dash, this is SOP. Yes, all this function you can say, sir, this is SOP. Okay, now you can say, so this is min term. Okay, now so which min term? This is how you can write. X dash means this is 0, this y means 1, this is 0, 0, 1, 0. Here this is 1, this is 1, this is 1. Here this is 0, this is 1, this is 0. Here this is 1, this is 0, 0, 0. This is mean term 4, this is mean term 2. Here this is mean term 7, and here this is mean term 2. If two mean term you are getting the repeating, and in digital you know very well a plus a is a. So if two mean term you are getting, so just you have to consider one time. Okay, so what will be this function? You can write in terms of SOP function. So this is mean term of 2, so just you have to write this as 2. This is a 4, so you can write 4, and this is 7, and this 2 and 2 are same, so just you have to consider one time. So this is 2, 4, 7. Now if you want to write this in terms of max term, so what will be the function? So you can write this function fx/y, that is nothing but max term, which is not presenting here 0, 1. Here this is 3 is also not presenting, here 5, and here this is 6. We can write in this way. Okay, now the second question. If examiner will provide you here minimized form, then how you can write the mean term and max term? So you have to go with canonical form. Suppose if examiner is going to be provide you the function fx/y/z is equal to, suppose x dash y plus this is y z plus this is x dash y z dash plus x z. Suppose they have provided like this. Suppose this is x z dash. Suppose they have provided like this. So this is not a canonical form. So you can say this is canonical form. This is canonical form. So canonical form means here in every term you will get x, y, z, all the three term. If this is 3 variable, so in every term you will get all the variable. But here z is absent, here x is absent, here complete terms, here y is absent. So how you can write here? So how you can write this? You can see x bar. So you can write this is 0, this is y, this is 1, z is absent. So you can write don't care. You can write z can be 1 time 0, z can be 1 time 1. Here x is absent, so you can write don't care. Y is 1, z is 1. Here x bar is, that is 0, y is 1, z bar is 0. Here x is present, this is 1, y is absent, so this is don't care, and z bar is a 0. So from here you will get two terms. So this is 1, 0, 1, 0, and then 0, 1, 1. Here two terms you will get, sir, 0, 1, 1, and this is 1, 1, 1. From here you will get this is nothing but 2. So this is mean term 2, and this is here two term you will get. This is 1, 0, 0, and here 1, 1, 0. So this is 4, this is 6, and here this is 2, here this is 3, and here this is 7, here this is 2, and here this is 3. All the mean term, okay, just you can write here. So here you can see this is not a canonical form. So if examiner will not provide you canonical form, no worry. Which term are absent, you can consider don't care, 1 time 0, 1 time 1, and you can write the function. So what is the function here? Function x, y, z, and this is nothing but mean term of, you can see 0 are present here, 0 are not. So 1 are present here, this is 4, 6, this is 2, this is 3, this is 7, this is 2, this is 3. 1 is also not present. Here first term is 2, okay, 3 is yes, 2 and 3. Now this 2, 2, this 2, 3. Okay, now 4 is present, yes, 5 is present, not present, 6 is present, yes, and 7 is present, yes. So here answer is 2, 3, 4, 6, 7. Like this you can write. So what is the SOP form of this 2, 3, 4, 6, 7? What is the POS form? So POS form you can also write. This is a pi of 0, 1, 2, 3, 4. Here 5 is absent. 0, 1, and 5. Like this we can write. So SOP to POS, POS to SOP. Easily we can handle. If canonical form will not be provided by examiner, easily we can convert into canonical form. So now you have to handle like this. I hope this thing is clear to all of you. Like this you have to handle. And now the next target is compressed Boolean form. So first you have to write mean term, max term for any Boolean function. Then we can use the K-map. Are you getting my point? Then we can use the K-map. So by K-map we can compress this Boolean function. Why we are going to compress the Boolean function? If you can compress the Boolean function, so that our logic gates will be minimum number of required. So what is our first target? For any circuit, write down the truth table, and for this truth table, write down the either SOP or POS, and then go with K-map and find out the minimized form, and then implement the circuit. Okay, this is our basic process. This is our basic process. I hope this thing is clear to all of you. I hope this thing is clear to all of you. Now here, this you should remember, x XOR y XOR z we can write 1 2 4 7, because every time I will use this 1 2 4 7 mean term is x XOR y XOR z. Now one more important thing, if I will ask you, I hope this thing is clear to all of you. If anybody have doubt till now, just tell me. If anybody have doubt till now, just tell me. If anybody have doubt till now, just tell me. Now one more important point I want to tell you here. Suppose if you have this function fxyz. Now suppose if you want to write f dash complement of this function. So what is a complement of this function? What is a complement of this complement? So this is summation. So complement means which is not present here. So which one is not present? 0, 1 and 5. Now what is a complement of this? F dash xyz. What is the complement of this? Which term is not present here? So can I write here? This is nothing but pi. Which term is not present here? 2, 3, 4, 6, 7. 2, 3, 4, 6, 7. So you will get 4 kind of representation is possible. One F SOP, F POS, F dash SOP, F dash POS. So this is nothing but normal form. This is POS. POS normal form. Can I say, sir, this is SOP normal form? Normal means function F. Sir, what is this? This is SOP and this is POS. But this is normal form? No, SOP complemented form. This is complement. And sir, this is POS complement. So, if any one form you know, remaining 3 forms you can write. Remaining 3 forms you can write. Are you getting my point? Remaining 3 forms you can write. If you know this, you can write this. If you know this too, you can write this too. So if any from this 4, any one form is given, either examiner will provide F dash or F dash or F or F, F dash POS, F dash SOP, F, SOP, F, POS. Anyone if examiner will provide you, easily you can write. I hope this thing is clear to you. I hope this thing is clear to you. I hope this thing is clear to you. Okay. So no worry about that. Okay, so our target is to write any one form first. Okay, any one form first. Now I hope this thing is clear to all of you. Okay, so now come to the next point. Here sometime examiner are interested in this circuit. So can you say this circuit is nothing but majority input detector? So if I will ask you a circuit, majority input detector circuit, majority input detector circuit for 3 variable, so majority input detector circuit for 3 variable, what will be the circuit? Can you write this? Yes, here you can say which is the majority. 0 0 0, 3 times 0, so result is 0 0 0 1, 2 times 0, 1 time 1, so majority. Okay, no, this circuit is not a major input detector circuit. Okay, no, this circuit is not. Okay, this circuit will be different. Okay, so later I will discuss this. Okay, so I will discuss this in combinational circuit. Okay, so now one thing you should remember here, if examiner will provide you 1 2 4 and 7, what you can write? This is nothing but if the input is x y z, x XOR y XOR z. You should remember this. Okay, so now for any truth table, we can handle SOP normal form, POS normal form, F dash normal form, and F dash POS form. Sorry, F dash SOP and F dash POS. All these 4 form you have to handle. Okay, now we have to find out the compressed form. But before going to start K-map, one more important thing I want to discuss here. The important thing is here, which one is better, SOP or PS. So now I am going to take one example, XOR gate. Okay, already 3 input I have considered, but right now I am going to take 2 input XOR gate. This is 2 input. 2 input XOR gate, 2 input XOR gate. Okay, I am going to consider 2 input XOR gate. So now 2 input XOR gate table is nothing but this is XY and this is X XOR Y, and if this is 0 0, this is 0 1, this is 1 0, and this is 1 1. So 0 0 XOR 0, this is 1, this is 1, this is 0. So here in two way you can write this function. So this Boolean function I can write fxy. This is nothing but fxy. So either you can write SOP form or you can write POS form. Okay, so you can write 4 form, but if examiner are interested in F dash, then only you can go with F dash. Till now, in very rare case, in one time only in GATE exam, they are interested in F dash. But if examiner will be interested in F dash, at least you should know directly you can write now. But we are interested in here F. So what is SOP form? This is 1, this is 1. Here this decimal value is, here this decimal value is 0, 1, 2 and 3. So 1, 1 and 2. So here this is nothing but main term of 1 and 2. And what is the POS form? So this is nothing but 0 and 3. Can you write? Yes sir, we can write. We can write. We can write. Okay, 0 and 1 and 2, and this is 0 and 3. If you want to write this Boolean function, if you want to write this one, so what is 1? So this is nothing but x bar y plus this is x y bar. This is 0 1, this is 1 0. And what is 0 and 3? So 0 and 3 we can write 0 means x plus y and 3 means x bar plus y bar. Can you write? Now if you will implement both circuit, then both circuit will be same or different? No, circuit will be different because representation is different, result is same. Result is same, representation is different, that's why circuit will be different. So what will be circuit for this and what will be the circuit for this? So what will be the circuit for first one, SOP form, and what will be the circuit for second one? So first I am going to write the circuit for SOP. So for circuit for SOP, so your x dash y, so can I write this is x dash and this is y. X dash y is AND gate, and here this is nothing but this is x and this is y dash. Okay, x dash and y dash you can generate from NOT gate. Okay, so I am not going to write here, and here this will be OR gate. This will be OR gate. So here you will get x dash y plus x y dash. Can I write? Yes. Now if I want to implement this circuit, if I want to implement POS circuit, so what POS circuit we will get from here? So first we will get x plus y. This is x plus y, and second again we will get OR gate. This is x bar, this is y bar, and now we have to do this AND gate. This is x plus y in bracket x bar plus y bar. You will tell me, sir, both functions are different. No, if you will solve this, you will get same function. This is x XOR y, and this function is also x XOR y. So Boolean function is same, so result will be same. Only circuit will be different. So here you can say SOP function. First you are getting here AND gate, this is AND gate, and here you are getting OR gate, OR gate. And POS, first you are getting here OR gate, and here you are getting AND gate. So you know this thing. So you know this thing, examiner can ask you here. So SOP function is first AND then OR, and POS is first OR then AND. So what we are getting from here? So what you can write from here, what is a SOP and what is a POS function? So SOP and POS we can write from here. What is the SOP function? SOP we can also write, this is nothing but AND OR array. This is AND OR array. And what is POS? POS we can write first OR then AND. First OR then AND. First OR then AND. Okay, now my question, which will be easily implemented by NAND gate and NOR gate? Now you can come to here. If I will put here one bubble, so can I cancel this by two bubble also? If I can put here two bubble, then circuit will be same. This NOT gate, 2 time NOT gate cancel, 2 time NOT gate cancel. You can see this is NAND gate, this is NAND gate, and this is bubble OR gate, this is also a NAND gate. It means this AND OR circuit, here 2 AND gate and OR gate will be replaced by NAND. This is very important thing. This is very important thing. So what I can say, this AND OR circuit will be replaced by NAND. Now if I will ask you, sir, POS will be replaced by, so if I will put here one bubble, here one bubble, here one bubble, so this is NOR, this is NOR, this is bubble and bubble add in nothing but NOR. This is NOR. So what you can say, POS will be replaced by NOR. POS will be replaced by NOR. Okay, so you should remember this. You should remember this. So SOP will be replaced by NAND and POS will be replaced non. Already I tell you which gate we prefer. We prefer NAND gate. We prefer NAND gate. We prefer NAND gate. So which term will be better? Generally we follow SOP. So that's why SOP we follow. Okay, so many times. Okay, so examiner can ask you anything from here. At least you should know this basic. At least you should know these basics. This was the last topic from the basics. Okay, so I hope now you should know this thing. Okay, now I am moving toward the question. Now I am moving toward the question. Okay, if anybody have any doubt, sir, hold time, setup time, delay time, because okay, lecture, yeah, in last topic we will discuss. Okay, if you will attend properly my classes, okay, I will relate each and everything with that part, and tomorrow definitely setup time and hold time. Okay, last we will discuss. Okay, now okay, setup time and hold time. Already you can also search in Google. Already you will get. Okay, already you will get my video. Okay, so you can search my name. Okay, Renu Raj Garg, and just you can put the setup time. You will get the video. Okay, now come to this. I hope this thing is clear to all of you. Now one very important topic I am going to discuss. Very important topic. Everybody now be ready for the next very important part. Now my next part is if we are going to process any boolean function with logic gate. Now my next topic is if we are processing any boolean function with logic gate, then how we can handle. So now the next topic is okay. So at least you should know the POS, SOP and all this part. Okay, so all the basic part is completed. So now mainly I will focus with the numericals and previous year problems. Okay, so now you will get definitely enjoy. Okay, because I know everything, you know many, but something definitely new you will get. Some new thing definitely you will learn. Okay, so now our next topic is how we can process any boolean function by using logic. So now I am going to mix boolean. In boolean algebra I am not going to discuss different law, you know very well, I know. Okay, so, and that law is not required to me, and in gate exam again that boolean algebra, that boolean algebra means you can say many laws, that is practically not required. Okay, so if you know, that is good. If you don't know, so that will not required in my process. Okay, without that we can handle any question. So now the next part is any mean term or max term. Okay, mean term or max term. Mainly I will discuss mean term is SOP. How we can process any boolean function by using logic gate. So here boolean function by logic gate, boolean function by logic gate, boolean function by logic gate. And this is most important topic, this is most important topic, and this is most important topic. Okay, boolean function by logic gate. Are you ready for this? So please comment me. Okay, please comment me who are continue watching my video. So please comment me first. Okay, then we can continue this. Okay, who are watching live, okay, please comment me. Okay, can we continue this session after your dinner break? So right now our time is 9:13 means 9:15. Okay, so from 10:15 I will start, and this topic I am going to discuss, and K map again we will discuss, and we will start your next topic. Okay, then combinational circuit. Okay, so please comment me. Can we start? Okay, so can we start after dinner break? Okay, so after dinner break we will continue this. Okay, so we will continue our classes. Right now the timing is 9:14, means 9:15 you can say. So after 1 hour, so at 10:15 again we will start our session. Okay, okay, so we will meet at 10:15. Okay, then I will start, and this is most important topic. Okay, everyone. So till now, if anybody or any doubt, just ask me. Okay, okay. Okay, so we will meet at 10:15, sharp 10:15. Okay, okay, thank you. Yeah, good evening everyone. So just confirm me, audio is clear to you or not? Okay, so everyone just confirm me, audio is clear or not? Good evening everyone. So now we will start the most important part from the logic gate and Boolean algebra. That is Boolean function. How you can pass any Boolean by using logic gate. Okay, so everyone, if anybody here doubt, just comment me. Amar Viswas sir, ADC, DAC and setup time all time. Yeah, tomorrow I will try to plan. I will complete. Don't worry. Okay, ADC, DAC and setup time whole time separate. Okay, if suppose tomorrow I will try. Okay, so you can uh, after tomorrow dinner maybe this topic can be completed. If this will not be held tomorrow, definitely I will do day after tomorrow. Okay, so 100% setup time whole time ADC DC, this topic I will cover. Okay, this topic I will cover. Okay, now, so now this is very important topic, Boolean algebra. Okay, or you can say Boolean function and logic gate. So now I am going to mix both the topic, and I will take one best example from the previous year, and you can see how we can handle that category of question. Okay, so now, so suppose first I am going to take a NOT gate. So I am going to take NOT gate. So now suppose for example, if we have one NOT gate, and now if you want to pass any Boolean function from the NOT gate, suppose here if we have any Boolean function f x y z, so what you will get? The Boolean function f dash x y z. Suppose this function is given mean term. This is SOP function 1 2 4 7. Then what you will get? This f dash you will get here. This is complement of this. So here mean term you will get, sir. This is 0, this is 3, this is 5, and this is 6. Now, if a examiner will provide you your max term, suppose max term 1 2 4 7, then what will be this answer? So here you will get f dash. Output is f dash you will get, yes sir. Then output function you will get complement of this. So you will get here pi of which term is not present here. This is 0, 3, 5, 6. And now you can also say, sir, this answer is equal to, this answer will be for this, and this answer will be for this. This if you want to write in terms of max term, so sir here this max term is 1 2 4 7, and here if you want to write in terms of mean term, sir, this is 1 2 4 7. Okay, so by NOT gate easily we can process any mean term or max term, easily we can handle. Okay, now this was very easy. Now the second important thing is, sir, AND gate. Now the second important thing is AND gate. How we can process any Boolean function by using AND gate? By using AND gate, how we can process any Boolean function by using AND gate? So if we want to process any Boolean function by using AND gate, so suppose here if we have first function f1, this is 3 variable x y z, this is f2, this is x y z. Okay, so now this output is suppose f x y z. Suppose here f1 is given, function f1 is given, x y z is given. Suppose mean term this is 1 2 3 and 6, and now suppose second is given, f2 x y z is given. Suppose this mean term is 0 2 3 5 and 7. Okay, so what will be the output? What will the output? So AND gate will provide you common mean term. Common, if you will write here, this is first term, second term, third term, fourth term. 4 mean term here, 1 2 3 4 5. So which term you will get at output? Which term will be same? We know very well. AND gate, suppose if this is AND gate, here suppose this is x dash y z, here this is x dash y z. What will you output? This dot this and this dot it. If both will be same, then only output you will get x dash y z. Okay, if any variable is different, so you will get a 0. Multiplication you will get a 0. So only common term you will get here, the output. So what will be the output here? Sir, here output we will get here this is 1 2 3 6 0 2. So which term is the common here? 1 is not common, 2 is, yes, 2 is the common, and 3 is the common. So what will be the answer? This mean term of here, this is 2 and 3. Now the important thing is here, sir, by which we have to process, mean term or by max term? So one thing you remember, if examiner will provide you anything, what you have to do? First you have to convert max term into mean term, or you can write POS into SOP. So you have to write SOP, then you can process. This is very important thing. So what you have to process? Always SOP. So here this topic is Boolean function by logic gate, and this Boolean function I am targeting SOP function. This is first important thing. So if examiner will provide you, suppose here, sir, F1 is nothing but pi of 0, 2, 3, 5, 6. Suppose this, if this is a pi, so first you have to write this summation, means this SOP form. So if examiner will provide you pi, you have to write first summation. This is the important thing. Okay, so this is the important thing. So now next question I am going to take. I hope this thing is clear. Now I am going with OR gate. Now I am going with OR gate. So next gate is OR gate. Next gate is OR gate. So suppose here, for example, for example, we have one OR gate. Suppose this function is F1, this function is F2, and this function is F. Now here I am going to provide you F1 is this is pi. This is a, you can say, POS form. Suppose this is 0, 2, 3, 6, 7, and F2 is given here. This is again, this is the SOP form. This is summation. Suppose this is 1 and 2, like this. So first what you have to write, you suppose this is 1, 2 and 3 I am considering. So what you have to write, first all the term you have to write in terms of SOP first. So this term first you have to write F1, and this is nothing but SOP. So here 0, this is 1 will be here present, 2, 3, here 4 will be present, here 5 will be present. So 1, 4, 5, and remaining this is a 5 term. So this is F1, this is F2. So this should be SOP, this should be SOP. So one thing you remember, always SOP you have to process. Then definitely you will never be wrong. Okay, so F1 is here we are getting. This is one. F1 is 1, 4, 5. This is 1, 4, 5, and here the term is 1, 2, 3. This is 1, 2, 3. So OR gate will pass all the mean term. So here mean term 1, here this is 2, 3, 4, 5. So here you will get mean term answer is, mean term 1 you will get, okay, 2 you will get, 3 you will get, 4 you will get, 5 you will get. So all the mean term which are present in F1 and F2. So AND gate will pass common mean term, and OR gate will pass all the mean term. This is important thing. I am saying mean term. So this is the first thing you have to convert. If examiner will provide POS form in terms of max term, first you have to write SOP form in terms of mean term. Okay, this should be your first protocol, and easily we can convert. We know very well. Now, so this is a third gate. Now the number fourth gate. If I will combine, suppose for example, if I will combine all these three gate, then how we can handle? So now one question I am going to take from here. So first question I am going to take from here. Okay. Everybody are saying, sir, we know this thing. Yes, I know you are, you know, but I will target XOR and XNOR gate, and then I will do some magic. And then not I, you will do some magic. Okay, so wait for that. Okay, so just basic first you should learn how we can process any Boolean function by using logic gate. So now you will tell me, sir, in gate exam directly this kind of question you will not get, but how you can use this category of thing in gate exam, this thing I will tell you. Okay, so suppose for example, one question I am going to consider. Suppose here we have one NOT gate, okay, and here one more function, and suppose for example, here I am taking, suppose this is the AND gate, and this is with OR gate. Suppose we are getting this category of function. Suppose this is F1, this is F2, this is F3, and here this is F. So suppose F1 is given, this is mean term of, suppose this is 0, 2 and 3, and now F2 is given, this is a mean term here given 1, 2 and 5, and now F3 is given here, this mean term of 0, 3, 5, 6 and 7. So what will be the F? So easily you can write, this is the F1, so here complement, so here I can write here you will get term 0, 2, 3. So here you will get 1. This is 2, 3 present, 4, 5, 6 and 7. Okay, so and here this is and F2 and F3. When F2 and F3, which term is common? 0 is not common, 1 is also not common, 2 is also not common, only 5 is common. So here you are getting only term 5. One thing you remember, all the terms are mean term. All the terms are mean term. So what will be this OR gate? So you will get your answer. This SOP form of 1, 4, 5. 1, 4, 5. 5 and 5, this is common. So one time you can write. This is 6 and 7. This is 6 and this will be the answer. This will be the answer. Now here reverse question can be also asked by examiner. Examiner can provide you this and examiner can ask you this. This question can be also asked. So examiner can provide you this thing and examiner can provide you this and this, and examiner can ask you F1. So easily we can handle. How we can handle? Suppose in this question, if examiner have provided this and they have provided F2 and F3, then F1 is question mark. Then how you can find out the F1? Okay, so here F2 common term, here you are getting 5. So what should be the here function? Here this can be 1, 4, 6, 1, 4, 6, 7. This is the first answer. One more answer can be possible. 1, 4, 5, 6, 7. So two answer can be possible. So here either this or this. Two answer can be possible. Either you can consider 5 here, or you cannot consider here 5, or you can also consider 5. So two answer can be possible. So what will be this complement? So here you will get this is the mean term of 0. If I am going to find out from here, this is 0, 2, 3. Here this is 5. And from here, if you want to find out answer, so this is mean term of 0, 2 and 3. So here two answer can be possible. So examiner can provide you the output and they can ask you the input. So this in this category of question, many number of answer can be possible. So they can ask you the MSQ question also. Now the another question. So I hope now easily you can handle this category of question. Okay, now the next question, NAND gate. Now I am targeting NAND gate. So NAND gate is again very simple. So first one is AND, then this is NOT. So this is a combination of AND gate and NOT gate. Suppose this is F1, this is F2 and this is F. So what will be the suppose function F1 is? This is mean term of 0, 2, 3, 6. Suppose F2 I am targeting. This is the suppose 1, 2, 5 and 7. So what will be the output? So first here you will get common term. So which term is common here? So common 0 is not common, 1 is not common, 2 is common, then 3 is not common, 5 is not common, 6 and 7. So you are getting here, this is mean term of only 2. So what will the answer here? Remaining term. So this is 0, 1, 3, 4, 5, 6 and 7. This will be the answer. Easily we can handle NAND gate. Okay. Now what will be by NOR gate? So if you want to process by NOR gate, so again this is R. So this is R. So this is F1, this is F2 and this is F. So again, if same example I am considering here, so what will be the F? So first you have to find out here. So which term is present in both? So you will get from here 0, you will get 1, you will get here 2, you will get here 3, you will get here 5, you will get here 6, you will get 7. Which term are not present means complement of this. So you will get 0, 1, 2, 3, here only 4, 5, 6, 7. So only this mean term 4 is the answer. So all these are universal and basic logic gate. But in gate exam, examiner will target XOR and XNOR. Now examiner will target XOR and XNOR. Then how you can handle? And now this is very, very important topic. So now this is XOR. XOR and XNOR. Okay. XOR and XNOR. So suppose we have here XOR gate. And this is XNOR. So here you will get XOR. Here you will get XOR and here you will get XNOR. Can I write? Yes. So now if this function is F1, this function is F2. Here suppose this function is F or this function is F dash. Suppose just I am writing. So you have to calculate what will the output of XOR and what will the output of XNOR. So here suppose I am going to assume F1 is equal to mean term of 0, 2, 3, 6. And now F2 is here. This is mean term of this is 1, this is 2, this is 3 and this is 5. Okay, so this 2 we are considering. So this 2 we are considering. So you can see here 2 is common, 3 is common, 0 is present, 1, 2 present, 3 present, 4 is not present, 5 present, 6 present, 7 is not present in F1 and F2. What will be the XOR? What will be the function F? So function F is nothing but F1 XOR F2. What will be this answer? What will be this answer? So first I am going to tell you the basic, then I will tell you in directly GATE exam how you can handle. Okay, so first I am going with the basic, how you can implement XOR gate. How you can implement XOR gate, because this thing in whole syllabus I will use. In combinational circuit especially I will use this concepts everywhere. So you should be expert. If you are my student, so you should be expert how we can process a boolean function by using logic gate. So here this XOR gate you can write in this way. Suppose this is F1 and this is F2. So what will be this first F1 bar? So this is F1 bar F2. So this is F1 bar F2. Then this is F1 and this is F2 bar. So here this is NOT gate and this is AND. Can I write? And both will be OR. Can I write? So what is XOR gate? If two variable x and y, x bar y plus x y bar. So from here what you will get? So what is F1 bar? Always first you have to find out what is F1 bar and what is F2 bar. So F1 bar is nothing but 0, 2, 3, 6. Here you will get 1, this is 4, this is 5 and this is 7. Can I write? What is F2 bar? Here this is mean term of this is 0, this is 1, 2, 3 is present, this is 4, 5 is present, this is 6 and 7. Now you can write here. What is here F2? So you can write in F2. F2 is 1, 2, 3 and 5. Can I write? What is here? F1 dash. F1 dash is 1, 4, 5, 7. 1, 4, 5 and 7. So what will be the output here? Common term. Which term is common? 1 is common here. 4 is not common. 5 is common. Then 1 and 5 you are getting. 1 and 5 you are getting. What is the F1 here? F1 is 0, 2, 3 and 6. What is here? F2 dash. F2 dash is 0, 4, 6 and 7. 0, 4, 6 and 7. Which you will get? Which is the common term? 0 is the common term. 2 is not common. 3 is not common. 6 is also common. 0 and 6. So what will be the output? Here F you are getting. This is the mean term of. So this F you are getting mean term of 0 and this is 1 and this is 5 and this is 6. So this is the output of XOR gate. Then what will be the output of XNOR gate? If this is XOR, so you can put here one NOT gate. So this is F dash. So F dash you are getting. This is a mean term of 0, 1, 5, 6. So here this is 2, 3, 4 and 7. 2, 3, 4 and 7. This is the answer. So what answer we are getting here? So this F we are getting here. This is a mean term of 0, 1, 5, 6. This is 0, 1, 5, 6. And what you are getting? This is F dash. This is 2, 3, 4, 7. 2, 3, 4, 7. So if you can see here, sir, what is the output of XOR and what is the output of XNOR? So now my target, we have to remember only XOR. If you examiner asking XNOR, so complement only you have to do. So you should remember for only XOR. And already in previous session, already I tell you, if you will get XNOR in between the circuit, replaced by XNOR to XOR. But if you will get in last, so just you have to find out XOR output, then you can find out XNOR output. I hope this thing is clear. Now, how you can remember this answer directly? So you can see here, what answer you are getting? 0, 1, 5, 6. You are getting 0, 1, 5 and 6. So you can see which term is common. 2 is common and which term is common here? 3 is common. So what you have to do? Just you have to remove the common term. Just you have to remove the common term and remaining term will be the output of XOR gate. Just you have to remove the common term and remaining term will be the output of XOR gate. So directly you can write the answer. If examiner will provide you this F1 and F2 and this is XOR. If this is F1 and F2, this F1 and F2. So how you can write directly answer? So here F you will get. Here common term 2 and 3 remove 0, 1, 6, 5. 0, 1, 5, 6. This is the answer. And this you have to remember. This you have to remember. This you have to remember. Clear this point? So how we can process any boolean function? By using logic gate. All the gate we have discussed. If examiner will provide you combination of this, so you can handle. But in gate exam, You will not get direct question from here, but you have to use this. But you have to use this. How you can use? So one question I am going to take. Okay, one question I am going to consider here. One question I am going to consider here. Okay, one good problem. I hope this thing is clear to you. Now XOR, if you remember, XOR will be complement of this. Easily you can handle. So what will be the XOR? What will be the XOR here? What will be the XOR? This XOR is F1 is sorry, F dash. This is 0, 1 is present. This is 2, 3, 4 and 7. 2, 3, 4 and 7. So 2, 3, 4 and 7. So how you can remember? You can remember the common term and the term which are not present. Which term are not present? 0 present, 1 present, 2 present, 3 present, 4 is not present, 5 present, 6 present and 7 present. So 4 is not present, 7 is also not present, and which term is common? 2 and 3. But don't remember this. I recommended you remember this one. Okay. So which term is common? Remove remaining term, you will get at output of XNOR gate. I hope this thing is clear now. Now I am going to take one good problem from this concept. Okay, one good problem from this concept. Okay, so I hope all the gates easily you can process any boolean function by using logic gates. Now how you can handle this thing in gate exam? Because definitely they can target. Okay, they can target. So now I am going to take one good problem. So here three variable. First variable is a. First variable is a. Okay, and one more variable is b. So here two variable. Okay, this is first variable a and this is second variable b, and both the variable is passed by one AND gate. Okay, this is single variable a and b. And now here this is b, and again we are considering one AND gate, and here this second variable of this is c. Okay, now again this output is again passed from one AND gate, and now this c is the second input of this AND gate. This c is the second input of this AND gate. Okay, now output of this and this output of this one and this both will pass from here XOR gate. This is XOR gate, and now this two output is passed from XOR gate. And this is F. So here this is very simple circuit, not a complicated circuit. But what is your approach? So you have to find out F in terms of A, B, C is equal to question mark. This you have to find out. This you have to find out. Four options I am going to provide you. Okay, you should try to solve. I am going to write here four options and you have to give me which is the correct answer. Just I am providing you 1 minute. I am going to provide you I am going to provide you only here 1 minute. Okay, just I am going to write the four options. So here a plus b plus c, and now the second option. Is here a b plus c. Sorry, this is a, and this is b plus c. Now the third option is b a plus c. This is b a plus c, and now one more option is given, option D, and that is c a plus b. Which can be the correct answer? Okay, now anybody can tell me which can be the correct answer. This is my favorite question. Okay, I love this question. This is previous year GATE exam, and this is not an easier question. Anybody can solve, but how much time will require? This is important. Okay, Akhil, you are saying you are having doubt in network classes. You can post personal in Telegram. You can post. Okay, you can search my name Renu Raj Garg. You can search Renu Raj Garg. Okay, and you can post me personal message. You can post me. Okay, I will provide you solution. Okay, now anybody can give me the answer. 1 minute is going to be over. 1 minute is going to be over. 1 minute is going to be over. Anybody can tell me. Anybody can tell me? Now your time is over. Now your time is over. Now you can see my approach. I don't know which approach you are applying. I don't know which approach you are applying. Now you can see my approach. Okay. If you can see, sir, this is XOR gate, and input of this XOR gate is not a single variable function. This is a B C. This can be depend on ABC. Sir, here also. Sir, here again also. So what you have to do in this case? First, this is basic logic gate A dot B. So here you will get, sir, A dot B. Okay, we can write, sir, here this is C and this is B. So here this is B dot C. Here this is B dot C. Now here this is C and this is AB. So what you will get, sir, here A B C. Here you will get A dot B dot C. Here you are getting BC and here you are getting AB. So what you can write? You have here three function. This is ABC. So if I want to write in terms of SOP form, so what you can write this? This is nothing but ABC means 7. Can I write 7? Yes, sir. This is AB. So what you can write? 1 1 don't care. So here 1 1 0 and 1 1 1. So this is 6 and 7. So what you will get here? This AB means, sir, this is a 6 and 7. Yes, sir. Now this BC means what you can write? This is don't care 1 1 means 0 1 1 and 1 1 1. This is 3 and 7. So what you will get this? Sir, here this is 3 and 7. Already we have studied if you want to pass any mean term by using XOR gate. So which you will get? Just you have to remove the common term. So here 6 7 and this is 7. So 7 is the common term. So what you will get here? Sir, mean term 3 and 6. So here you are getting 3 and 6. Yes, sir. So here this is 7 and here this is 3 and 6. So which is common? None is the common. So just here to remove the common term. So no one is common. So what is the answer? Sir, this is 3, 6 and 7. So what is the answer? 3, 6 and 7. Now you can write 3, 6, 7 is nothing but 3 means 0, 1, 1. So 0, 1, 1 variable is ABC. So this is A bar BC. This is 3, 6, 1, 1, 0. So this is A, B, C bar. And sir, what is the 7, 1, 1, 1? Sir, this is A, B and C. If you will common from here AB, so this will be C plus C bar. C plus C bar will be 1. So you will get here A bar BC plus from here AB. If you will consider B as a common, so you will get B as a common. You will get, sir, A plus A bar C. Now if you can solve this, you know this basic law. Okay, one bracket A plus A bar, in second bracket A plus C. Can you write here? A plus A bar is 1, so you will get, sir, B A plus C. This is the answer. So what is the answer? B A plus C. This is the answer, B A plus C. Like this you can handle. I don't know which approach you are applying. If you will play here with ABC, so sometime it will take huge time and sometime you can get confused. So this is my approach and this is the best approach. I don't think anybody can solve this question in this way. Okay, so please just confirm me this problem is clear to all of you. This problem is clear to all of you or not? This problem is clear to all of you or not? Please respond me, yaar. Please respond me. Okay, never you will get this kind of approach. That's why we studied how we can process any Boolean function by using logic gate. Okay, now I hope this thing is clear to all of you. Suppose this question, if you want to handle by this without this mean term concept, suppose, then what you can write? Suppose if you want to process without this, then how you can handle? Then how you can handle? So here I am going to write, answer is already you know, B dot A plus B. So now if you want to handle without this, then what you will get? You will write here, sir, AB dot BC. Okay, AB into BC bar, and you will write plus, sir, here this is AB bar dot, sir, BC. You will write in this way. Okay, here this is ABC. Then you will solve this function, and if you will solve this function, so what you will get? Sir, this is AB, here B bar plus C bar. Okay, sir, this is plus here A bar plus B bar, and then BC. Now again, if you use a a b b bar 0, a b c bar, so here you will get a b c bar, and here you will get a bar b c. Okay, and here b bar b c 0. So here you are getting two term, a b c bar, a bar b c. Then again, what you will write here, f sir, a b c whole bar, ABC whole bar dot this term. Then sir, this is ABC bar plus A bar BC, and then plus second term is this as it is ABC and this complement and this whole complement. So this is ABC bar plus A bar BC, then whole complement, and then you will solve this. How much time it will take? So don't go with. So now what is this theory behind this? If you will get a logic gate circuit, complicated logic gate circuit, so what you can do, you can process with a mean term concept, you can process with SOP, we can process with SOP. I hope this thing is clear to all of you. I hope this thing is clear to all of you. This is the magic of digital circuits. Clear thing? This is the best question, and this is the my logic. This is my logic. Okay, I hope now everyone can handle questions from the logic gate, okay. So according to me, now each and everything is completed, okay. Now, so now can we start our next topic, that is K-map. So already we have studied this thing. Then how we can minimize? Suppose if you don't want to minimize from here, this by using this Boolean principle. So by using K-map, you can also minimize this. So this 367, if you don't want to minimize from here, so easily you can minimize in this way. Sir, this is A, B, C. This is 0, 0, 0, 1, 1, 0, 1, 1. This is 0, 1. So from easily you can minimize 0, 1, 2, 3. This is 3, 4, 5. This is 6 and 7. So this group and this group, your answer will be from here. Sir, this is B, C. This one and this one is, sir, A into B. This is A into B. So here B you can take common. Sir, this is A plus C. This is the answer. So if you are not comfortable in this Boolean principle, so you can go with this K-map. So Boolean principle is not much required. You have to process with canonical form, SOP and POS. Clear this point? Now I am going to start K-map. So our next topic is a K-map. Our next topic is a K-map. Okay, our next topic is K-map. Okay, now I am going to start our next topic, that is K-map. Okay, K is a Karnaugh map. K is a scientist name. K is a Karnaugh map. Okay, so everyone, this thing is clear to all of you. Okay, now first you should know in K map 2 variable, 3 variable, 4 variable. Generally we will use 2 variable, 3 variable and 4. 2 variable function generally we can write directly. And 3 variable K map and 4 variable. So mostly question you will get from 3 variable and 4 variable. But by using that big size of K map we can also implement. Okay, so now suppose 2 variable K map. If I am going to consider 2 variable K map, suppose, so how you can write 2 variable K map? So if you have to write K map, suppose our function is function x AB. Suppose I am considering function AB. So always I will write MSB here and LSB here. This is my protocol. Always MSB I will write here, LSB here, sir. This is 0, 1, this is 0. This 0 means B bar, this 1 means B. This 0 means this is B bar, and this 1 means B. This 0 means this is A, and this, A bar, and this is A. Clear? So what you will write, order, this is 0, 0, it means this is decimal 0, this is 0, 1, this is decimal 1, this is 1, 0, this is decimal 2, 1, 1, decimal 3. So this is a 2 variable. Suppose one example I will consider. If you have a Boolean function, this function AB, and suppose if you have a mean term, suppose we have a SOP function 0 and 1, then what will be the minimized form? So you can put this in the K map. So 2 variable function directly by using Boolean you can minimize. So in generally for 2 variable we will not use. But if you want to use, you can write here this is AB. Sir, this is 0 1, this is 0 1. Here this is 0 1. So where you are getting mean term are present. So mean term are present means here which position? Decimal 0 and decimal 1. This is decimal 0 and this is decimal 1. You have to write 1 1. It means here this is nothing but 0 0. So it means at decimal 0 position and decimal 1 position you have mean term. Mean term represent 1 and 1. So this two represent mean term. So definitely this should be representing max term. We know very well, already we have studied. If for three variable, suppose fourth term is mean term, so remaining four term will be max term. Similarly, if these two are the mean term means 1, so definitely this two should be the max term. But in generally we don't write here 0. This is understood. Here this is 0. So just here to form a group. So we have to form a group. So if you will form a group, so what will be this function a b minimized form? So this is nothing but which is common here, a bar. So answer is a bar. So two variable easily we can handle. Okay, now the second example. Second I am considering a three variable k map. So three variable k map. So three variable k map. You have to represent either horizontal or vertical because total number of cells 8. So one thing, what is a number of cells? What is a number of cells here? So can I write 2 raised to power n? So this is 2 raised to power 3 is equal to 8. So 8 is not a square. 4 is a square. Here this is 2 raised to power 2. 2 raised to power is 4. 4 is a square. So generally we design here is square. But here square is not possible. So in generally we will represent in this way. In general we will represent in this way. Sir, this is A. This is B, C. Three variable I am considering. You can write 0 0. 0 1, this is 1 0 and 1. You should remember this is a gray code sequence so that easily group we can form. I hope you know very well this thing. So now this is 0 1. So now if suppose for example, if suppose here reverse question I am writing here, suppose here 1, here 1, here 1 and here 1 is given for the three variable. This 4 1 is given. So what I can write, this is function of ABC. Is there any group is formed? No group is formed. This is single, this is single, this is single and this is single. So here no group will be formed. So if no group will be formed, you can write this is 0 1 2 3. So this is nothing but 1, this is 2, this is 4 and this is 7. So this is nothing but 1 2 4 7, and already we have studied 1 2 4 7 is nothing but A XOR B XOR C. So this thing you should remember. So if you will get like this zigzag form and we are not getting any group, so if you are getting this zigzag form, so this is nothing but 1 2 4 7 and this is nothing but A XOR B XOR C, and this we can also write A XOR B XOR C because this both value is same. Remember directly this value because many time in combinational circuit we will use every time. Okay, every time we will use this thing. So remember this zigzag form is representing all values XOR A XOR B XOR C. Clear this thing? And this mean term we remember 1 2 4 7. Now the second example here. So one thing here I want to discuss. Okay, I am going to take 2-3 examples, then I will discuss prime implicant, essential prime implicant. Okay, now so suppose for example one more example if I am going to consider here like this. Suppose one more example, suppose this one, and suppose this is A, this is B, C, this is 0 0 0 1 1 0 and 1 1. Suppose this is 0 and 1, suppose this is 0 and 1, and now here suppose this is 1, this is 1, this is 1, this is 1. Then what will be this function? So this complement, can I write this complement? So here this is the function ABC. So what will be this function ABC? This is mean term of this is 0 1 2 3. So this is 0, this is 3, this is 5 and this is 7. So 0 3 5 7, this is nothing but complement of this. So can I write this answer directly? Sir, A XOR B XOR C whole complement. So if you know this zigzag form, and this zigzag form will be the XOR of all the function, so opposite of this will be the XOR complement. So is this XOR complement you can also write this is nothing but A XOR B XOR C, or you can also write A XOR B XOR C. Already we have studied this in the previous session. Already we have studied this, so easily we can write. So this two answer directly we remember. This zigzag means is this all the variable XOR, and this zigzag means all the variable XOR complement. Okay, now here is there any group will be formed? Sir, this is single, this is single, this is single and this is single, all having single. Okay, Now come to the 4 variable K map, and in 4 variable K map we will discuss what is prime implicant, what is essential prime implicant, like this. Okay, now before going to start for a variable, now my question, can we implement 3 variable K map by using 2 variable K map? So this is my question. So 3 variable K map by using 2 variable K map. So 3 variable K map, 3 variable K map by 2 variable K map. So can you implement 2 variable K map? Can you implement this 3 variable K map? Yes, this is a square, but this is not a square. So sometime if our K map is not a square, we can use 2 square K map and we can implement that function. So like this, by minimum size of K map, we can also go with maximum. We can also write the Boolean function for maximum variable function. So how we can write? Suppose here this is a 2 variable, here this is a 2 variable, suppose this is 2 variable, like this. So here I am considering a, so this I am writing, this is for a is equal to 0, this is for a is equal to 1. So for a is equal to 0, you will get 0 1 2 3. So this is nothing but a decimal 0, this is 1, this is 2, this is 3, this is a is equal to 0. And can I write here b and c? So this is c 0 0, sorry, this is 0, this is 1, this is 0, this is. So can I write this value? A0, B0, C0. 0 0 0 means 0. This is 0, this is 0 1. So this is 0 0 1 means 1. Now this is 0 1 0, this is 2, 0 1 1, this is 3. Can I write? Now. Now here a is equal to 1. If I am going to write this is BC, this is 0 1, this is 0 1. So this is 1 0 0. So this is 4. This sir, this is 1 0 1, this is 5. 1 1 0, this is 6, and 1 1 1, this is 7. So you can also write in this way. But the important thing, you cannot split this, because this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. So what is the difference? So if you will tell me, sir, can I divide this exactly half, and this is a is equal to 0 and this is a is equal to 1? No, you cannot write, because you can write, sir, this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. So this was opposite. So here you have to write in this way, and this is B and this is C. So if you want to divide, if you want to divide this K map into 2 parts, so what you have to do? You can divide from here. Yes, sir. This is for A is equal to 0. This is for A is equal to 1. And this is B here. This is C here. Here you can write this line, sir. This is B. This is C. So this is 0, 1. This is 2, 3. This is 4, 5, 6. So this K map is opposite. You can see. Here you are going to write. So can you write in this way? So you can see, sir, if this A is equal to 0, important thing. So this is 0, 0, 0. Sir, this is 0. Here this is B is 0, C is 1, 0, 0, and this is 1. Sir, this is 0. So this is your not 4, 5. This is 2, this is 3. So you cannot divide. Sometimes student will do like this. No, this will be wrong. This will be wrong. This is the important thing. Okay, so you cannot write in this way. You cannot write in this way. So if you will say me, sir, can we divide this K map from here? No, this will be totally wrong. Why wrong? Sir, this is 0, 1, this is 2 and this is 3. But here this is 2 and this is 3. So if you want to divide, sir, can it is possible? Yes, in one case it can be possible. You can see, sir, this is 0, 1, this is 2, 3, this is 4, 5, 6, 7, this is 4, 5, 6, 7. So if I am going to write here, you can see here, sir, this is 0, 0, 0, 0, 0, 1, 0, 1, 2, 3, this is 4, this is 1, 0, 0, and this is 1, 0, 1. Which term is common in all? So you can see here B. B is the common. This is common, this is common, this is common, this is B is, so this the whole is for B is equal to 0. So, and here you can see, sir, this is for 0, 1, this is 2, this is 2, this is 3, and this is 4, 5, this is 6, and this is 7. So here again B is 1. So here again this B is 1. So if you want to divide exactly from the middle, so what will be the K map? So if you will split this 2 like this, so you can write in this way, and what you have to write, sir, this is for B is equal to 0, and this is for B is equal to 1. B means this value, and remaining value you can write, sir, this is A, this is C, this is 0, 1, this is 0, 1. But here you can write this is A, this is C, this is 0, this is 1, this is 0, this is 1. But you will not get this kind of question in GATE exam. Just I am telling. So if you cannot divide from here exactly, if you want to divide from here, this will be the variable, this will represent one part will be for b is equal to 0, second part will be for b is equal to 1. But sometimes student can do like this. I hope this thing is clear to you. But you can represent 3 variable by using 2 variable in this way. I hope this thing is clear to you. I hope this thing is clear to you. I hope this thing is clear to you. Okay. So you cannot split this exactly in this two part, and you cannot write, sir, this is equal to 0, this is equal to 1. No. You can also not write, sir, this is b is equal to 0, this is b is equal to, no. If this is b is equal to 0 and if this is b is equal to 1, so here you can start from here. So this will be 0, this will be 1. Okay, this will be 0 and this will be 1. This will be 0 and this will be 1. This is the important thing. This is the important. So this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. Then easily you can split like this. Clear this one? But don't worry, you will not get this kind of region. But just I am telling, if examiner will target this, so you don't be wrong here. So okay, so I hope this thing is clear. So just I have implemented 3 variable K map by using 2 variable K map. Examiner will provide you this kind of question. Don't worry. Examiner will provide you this kind of question. So what you will do, find out function from here and just you can multiply by a bar. You can find out from function here and just you can multiply by a. One example I am going to consider. Okay, which kind of question examiner can ask here? So suppose one question I am asking to you. Suppose one question I am asking to you. So suppose one example. Suppose they have provided here, this is 2 variable K map and one more 2 variable K map like this. Okay, suppose this is for a is equal to 0, this is for a is equal to 1, and suppose this is b, this is c, and here suppose this is b, this is c, this will be 0 1, this will be 0 1, this is 0 1, this is 0 1. And now they have provided here this is 1, here this is 1, here this is 1, and here this is 1. So what will be the answer? So what you will do, you can make here one group. So this group you can write this b bar. So here the answer is b bar, and b bar will be multiply a0 means this will multiply with a bar. So here this answer will be a bar dot b bar. Here this is single, this is single. So what you will write, sir, this is this is b bar into c, this is b into c bar, plus this is nothing but b bar into c. So this will be XOR C. Already you know this diagonal represent. This is XOR gate. So this is nothing but B XOR C. So B XOR C, and B XOR C will multiply by A. So this answer will be A bar B bar. This answer will be A. This is B XOR C. What is complete answer? So complete answer will be, you can write A B bar plus this is A and this is B XOR C. This is the answer. But now the important thing, this is not a fully minimized form. If you will solve this function by using 3 variable K map, so you will get a compressed form. This is not a 100% compressed form. This is the important thing. That's why generally we will not prefer big size of K map by using a small size of K map, because this will not give you 100% comparison. Clear this one? Why we are going to use K map? Now I want to tell you some theory behind K map. What is the use of K map? So first thing, if you will make a perfect group, so you will get here perfect compressed form, so that form cannot be more compressed. So one important thing, if you will do perfect group in K map, and you will get a function that is 100% compressed form, and that form cannot be more compressed. This is the advantage of K map. This is the advantage of K map. Now one question I want to ask you from here. Okay, one question. Okay, before going to take that question, first I want to tell you 4 variable K map. So first we are going to take 4 variable K map. Generally examiner will target 4 variable K map. So in 3 variable K map, you remember zigzag form, that will be important. Okay, and how we can implement any bigger size of K map by using a smaller size of K map. So easily you cannot split this two. Sometimes student can think, can we split in those 2 parts? No, you cannot split exactly. This variable is important. Okay, so which you are considering here common term, everything is important. Okay, sometimes student can be wrong, but don't worry, in GATE exam they will provide you this kind of question and they can provide you what is the output, so just you can write. But one important thing, this is not a fully minimized form, this is not a fully minimized form. So now I am going to take a 4 variable key map, and in 4 variable I will tell you what is pi, what is epi, okay, what is prime implicant and what is essential prime implicant. So now 4 variable k map, 4 variable k map, and always examiner will ask you question from 4 variable k map. So now here suppose for example 4 variable will be square, yes, total number of cell will be 16, so we can consider 4 and 4, we can consider 4 and 4. Suppose our variable is abcd, so you can write here abcd. Okay, I can write here, sir, this is 0 0 0 1 1 0 1 1, this is 0 0 0 1 1 0 and 1 1. Okay, now suppose if I will write here, suppose for example this is a 4 variable k map, if this is 1, 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 and this is 1. Okay, and this is 1 2 3 4 5 6, sorry, this is 7 and this is 8. What will be this answer? So directly we can write this answer. So this answer is f a b c d. So here this is single, no group, 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 so none of the one will form a group. So directly I can write answer, sir, this is a xor b xor c xor d. Directly you can write it. So this answer at least you remember. Now second example. So second example I am going to considering from 4 variable k map. Suppose this k map is given, this k map is given, and suppose this is a b c d, this is 0 0 0 1 1 0 and 1 1, this is 0 0 0 1 and this is 1 1 and 1 0. Now suppose here I am considering, suppose this 1 1 1 1, and now suppose this is 1, this is 1, this is 1 and this is 1. Suppose this is given, suppose this one is given, suppose this one is given, suppose this one is given. So what is a function abcd minimized form? So examiner will ask you what is a minimized form, what is a minimized form. So now which group you have to form? First important point here, which group you have to form. Generally what student will target bigger size of group? No, here you don't target bigger size of group, you should target which one which is independent from any another group. So if you will target this one, so only we have one choice, you can see here, yes sir, if you will target, this is only one choice. Okay, if you will target this one, this is only one choice, if you will target this one, only one choice, if you will target this is only one choice. So here you don't have to make this 4 group, this is not required, this group is not required. So sometime if you first target the bigger size of group, and sometime that group will be practically not required. Okay, that will be a redundant group. So if any student will form this group, suppose for example, so this group is practically not required, we can call this is redundant prime implicant. But in GATE exam they will not target a redundant prime implicant, so you don't have to study that. Okay, so only here 2 number here. If I will ask you, if in this question, suppose if you are going to write 1 2 3 4 5, if I will ask you how many number of prime implicant, so number of prime implicant, first question, and now my second question, number of essential prime implicant. So what will be the number of prime implicant? So if you are going to represent perfect group in K map, so all the perfect group is called prime implicant. Are you listen my word? Again listen my word. If you are making perfect size of group for everyone in K map, and if you are not going to take any extra group, if you are going to do perfect group in the K map, that all the groups is called prime implicant. So here this is pi, we can say this group is pi, this group is pi, and this group is prime implicant, and this group is prime implicant. Don't write this is a prime implicant. So if examiner will ask you how many number of prime implicants here, so you have to write 4. Don't write 5 prime implicants. Some student can write this and they can say, sir, that is a prime implicant. No, so your answer will be wrong. That's why sometime examiner will ask you how many minimum number of pi. So if examiner will ask you here number of prime implicants, so examiner will tell you This is a minimum number of prime implicants. That's why you will not get confused. That's why you will not get confused. It means if you will write K-map answer, so just you can see how many groups you are making. That all the group is prime implicants. Are you getting? So each and every group which you are using in your answer, that all the groups are prime implicants. Clear this point? Now, so you have formed here 4 groups. This is number 1, this is number 2, this is number 3, and this is number 4. This is number 4. So this group is called, this is called redundant prime implicant. Just remember, which can be form a group but you are not using, that is called redundant prime implicant. But don't worry, examiner will not ask you RPI. Now, which will be the EPI? So first I am going to write this answer. This first group you can write from here. Sir, this is C bar D. This is C bar D, and from here this one is common. This is A. So A C bar D. Now the second answer. This I am going to write. This is from here A bar, and from here, sir, this is CD. This is CD. This is second. Now third. What will be this one? Sir, here A bar B. This is A bar B, and from here we can write which one is the common. Sir, this is C bar. And what is the lost? From here, this is A dot B. A B, and from here, sir, this is common term is C. Can I write in this way? So all these 4 term are PI. If I will ask you how many number of EPI, so you can see here, this is PI, okay, this is PI, okay, this is PI, okay, and this is PI, okay. And now which PI is EPI? It means suppose if n number of students are going to write this K-map, so write this minimize Boolean function, and which group is present in all the answer. So if I am writing, you are writing, your friend are writing, and if everybody are writing perfectly, but sometime 2 answer can be possible. Sometime 2 answer can be possible, and both answer is correct, and both are the fully minimized. That situations can be possible. So if in any K-map, if you are going to write PI, and that PI is 100% should be present in all the answer, that PI is called essential. That is called essential PI. So what I can say, this will be EPI, this will be EPI, this will be EPI, and this will be EPI. Clear this point? So which PI will be present always in any situation in your answer, that PI is EPI. So how many number of EPI? This is 4. Now you don't say, sir, EPI is 4 and PI is 0. No, you don't write. So your number of PI is, number of prime implicant is 4, and sir, all PI are EPI. So number of EPI is also 4. Don't write, sir, PI will be 0 because all are EPI. No, some PI will be EPI. So PI is also a EPI. Sorry, EPI is also a PI. So essential prime implicant is a prime implicant. But which prime implicant? That is essential. That is called essential prime implicant. 2 more example I am going to take. So 2 definition you should remember. What is PI and what is EPI? Now if in one question I will ask you, then sir, what is prime implicant? Now then, what is the prime implicant? Sorry, what is the implicant? Sir, what is the implicant? So if somebody will ask you, sir, what is the implicants? Sir, what is the implicants? So what do you mean implicant? Implicant means the prime implicant which are not prime. Not prime means, suppose if you can make a size of 2 group, but you are not considering size of 2 group, you are considering a smaller size of group. So here implicant means a smaller size of group. When you are going to form a smaller size of group and you are going to write that function is called implicant. But if you are going to make perfect size of group, that is called prime implicant. So which is required for our life? Prime implicant. That's why nobody are interested in implicants. This is the important thing. Nobody are interested in implicants. Okay, implicant is not required. But just one example I am going to consider here. Suppose one K-map is given. Like this. Suppose one K-map I am considering in this way. Like this. Suppose this is AB and here this is CD, this is 0 0 0 1, 1 0 and 1 1, this is 0 0 0 1, 1 0 and 1 1. And now suppose here this one, this one, this one and this one is given, and now here this one and this one. So here 1 2 3 4 5 6 1 I have considered. So suppose if one student are doing, first you have to target this one. This is should be single, yes. This cannot be form a group, yes. So this should be single, and this cannot be form a group with anyone. Now this four corner you can make a one group, but suppose for example if any one student will make group of this, and if any one student will make group of this, suppose for example, then what you will say? First thing, sir, this is implicant. Okay, this will be implicant. Okay, sir, this will be implicants. So first I can write, sir, this will be implicants. Okay, this will be implicants. Okay, so every group is called implicants. Sir, this group is implicants. Okay, sir, this group is implicants. Okay. Now you can see, sir, this is a perfect size of group or not? No, not a perfect size. So this is not a PI. This is only implicant, but this is not a PI. Why this is not a PI? Because this four group can be formed, and you have considered only two one of group. This 4 1 group easily you can form, but you have formed here a smaller size of group. So you cannot say this is prime implicant. So prime implicant definition clearly says you have to make a perfect size of group. You cannot create a minimal or a smaller size of group. So you can call this implicant, this is implicant, this implicant, this implicant, but this is not prime implicant. Now, sir, this is a perfect size, yes. So this cannot be create more group size of group, and this is PI. Then, sir, which will be EPI? So if so in every answer, now you don't target I because this is only implicant. So which PI will be EPI? So in every answer this is possible, yes. So this will be EPI. In every answer this is possible, yes. So this will be EPI. This is the answer. This is the answer. So if any students are creating this group, so what we will say, sir, this is implicant, this is implicant, this will be PI, and this will be PI, and this will be EPI, and this will be EPI. But what will be the correct answer for this K-map? What should be the correct answer for this K-map? So again I am going to draw. What should be the correct answer for this K-map? Okay, that's why generally we are not interested in implicant. Are you getting this point? So implicates, nobody will ask you what is implicant. Nobody will target. Okay, or nobody will ask you what is the implicant. So in this question, what if I will examiner, what question I will ask you? Number of PI, number of minimum PI, number of minimum prime implicants. So in this question, how many number of minimum? If any one student will make this group, 2 group, 3 group, 4 group. So some student will write, sir, here the number of prime implicant is 4. No, number of PI is not 4, and you cannot say, sir, number of PI is 2, because you have created here a wrong group. So if you will give answer from here, you will be wrong. So if anybody will give answer from here, so either he will write, sir, PI is 2 or PI is 4. Only two answer will somebody will give you, and both answer are wrong. Both answer are wrong. So what will be the actual answer? Here this is 1, here this is 1, this is 1, this is 1, this is 1, this is 1. This is single group, and all these 4 corner you can write 1. So all these are PI, yes sir. Now this is PI, yes sir. Now this is PI, yes sir. Now this is PI, yes. So this is a perfect size group, yes. This is perfect size group, and all the 4 corner is a perfect size of group. Then, sir, which one will be EPI? So this only one answer. This alternate answer possible? No possible. So this is EPI. Again, this is also EPI, and this is also EPI. So in this question, examiner will ask you minimum number of PI. So answer is 3. So if you will not create a perfect group, your answer will be wrong. Your answer will be wrong. Clear this point? That's why examiner are interested in PI. If you will provide me perfect PI, then examiner can think, yes, at least you have formed a perfect size of group. Only you have to write the Boolean function. Clear this point? So I hope this PI and EPI is clear to you. I hope this PI and EPI is clear to you. Okay, now one important thing, this PI and EPI, we always talk when you are making a group from 1. This is the important thing. So this PI and EPI, this you can note down or you remember. PI and EPI definition is defined for this is defined for SOP function, or I can write mean terms. This is not defined for max term. So you can write this is not defined for max term. Why I am writing this? Because sometime we are creating here group for 1. Sometime we can also create group by 0. I will discuss that. So but if you are making a group from 0, then you cannot discuss or you cannot talk PI and EPI. Clear my point? So PI and EPI will be only described when you are making a group from 1. 1 means mean term. Are you getting me? Are you getting this point? So PI and EPI definition, always you have to find out when this K map is given by 1 and you are making a group by 1. You are not making a group by 0. Are you getting this point? So now what will be this complete answer? If I am going to ask you, sir, what is this complete answer? So this is A, B, C, D. Here this is 0, 0, 0, 1. This is 1, 0 and 1, 1. Here this is 0, 0, this is 0, 1. This is 1, 0 and 1, 1. So what will be this answer? So here answer this function A, B, C, D. So what is this answer? This 4 group, you can write 4 groups. Sir, here this is common B bar and here this is common D bar. So first answer is B bar, D bar. Can I write? Now the second term. If you are going to write this, sir, this is A dot B, A, B, C bar, D. So this is A, B, C bar, D. Now the third term, if you are going to write this, sir, this is A bar B. This is A bar B and C, D. And this one is here C, D. So here 3 terms you are getting. This is PI. Yes, this is also PI. And this is also PI. This is PI, EPI or not? Yes, this is EPI. This is also EPI and this is also EPI. Now the important thing, how many number of literals? So here this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I will ask number of literals is equal to 10. 4, 4 and 2. So number of literal means how many number of times input or variables you are going to use. So just count this. So number of literal, that is called number of literals, L-I-T-E-R-A-L-S. This is nothing but number of literals is here 10. 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 I hope this thing is clear to all of you. Now come to the next point. If I will ask you, sir, this answer is SOP form or POS form? This is minimized form. Yes. So what you can say, sir, this is a minimized form. This is a minimized form. Can I write? Yes. SOP or POS? SOP. So this is a minimized SOP form. Now my question, sir, can we write minimized POS form? Yes, we can also write. So 2 category of question can be asked by the examiner. Sometime examiner can ask you the find out minimized SOP form, and sometime they are also interested in minimized POS form. Then you have to discuss which will be better. So now if I am going to find out for the same question, if examiner have provided you all the 4 options, in POS form, so in any K map 2 number of function can be possible. So first thing, so here first F you can find out SOP, and second function you can also find out POS, and both are minimized form. So in real life we have to check which is better. But here in GATE exam they can provide you the K map, and first question they can ask you how many number of PI, how many number of EPI. Okay, so I hope this PI and EPI is clear. Now second question they can ask you what is a minimized Boolean function. So this is the first minimized Boolean function. Second they can ask you what is a minimized Boolean function but in POS form. So if they are asking POS form, so what you can do, so you can again draw this K map, you can again draw this K map, and now in place of 0, in place of 1, just you have to remove, remaining place you can put 1. This is your A, this is your B, this is C, D. Now I can write 0, 0, this is 0, 1, 1, 0 and 1, 1, this is 0, 0, 0, 1 and 1, 0 and 1, 1. Now just remove this place, and at remaining place you can put this is 0, this is 0. Now here this is 0, here this is 0, here this is 0, here this is 0, and here this is 0, 0, 0, 0, and 1, 2, 3, 4, 5, 6. So in 6th place you are getting min term. So in remaining place, total place is 16. So in 10 place you are getting max term. Already I tell you, if here 1 are present, so in remaining place 0 will be present. So you can also form a group by 0. So can we form a group by 0? Yes. So we can also form a group from 0. So if you are targeting this 0, if you are targeting this 0, if you are targeting this 0, so only one group is possible. Sorry, if you are targeting this 0, so you can create this 0 and this 0, this is, and this 0, 0 and this 0, 0, and this is single. Sorry, this is not single here. Now this is not single, this is not single. Now this 0 you can form either group with this 0 or this 0. So you have two choices, and this 0 you can form a group with this 0, or you can form a group with this 0. So there are two conditions possible. So now here different answer can be possible. So already I tell you, for some K map many number of answer can be possible. So in K map, when many number of answer can be possible, so examiner are interested in minimum number of PI. So in that situation, generally examiner will ask you minimum number of PI. So if in this K map, suppose 3 different answer was possible, then examiner will not ask you minimize function of K map. Examiner will ask you what is the minimum number of PI. They want to check, are you making a perfect group or not? So what examiner want here? You are making a perfect group or not. So here you have different choices. So here 4 answer can be possible. This 0 you can take with, this 0 you can take with. This is first answer. This 0 with this 0 with this second answer. This 0 with here, this 0 with here, third answer. This 0 with here, this 0 with here. So here 4 answer can be possible. So here 4 answer can be possible. 4 answer can be possible. Okay, but you can see in all the 4 answer, size of result, or you can say here number of literal will be same. So any one answer you can write. So what I am doing here, I can consider this 0 with here, yes sir, and this 0 with here, just I am considering. So now you can write the answer. So here function, this is a comma b comma c comma d, and what is this minimize boolean function in POS form? Okay, in POS form. So what is the minimize boolean function in POS form? Sequential circuit tomorrow we will start. Okay, so tomorrow we will complete the whole digital sequential circuit tomorrow we will start. Okay, so now here this function a b c d, how you can write? So one important thing, if you are making a group of 0, so you have to write POS form, you don't write SOP form. So first this 4 group if I am going to take, so you can see here common is 0, here common is 0, but you have to write POS form, but you have to write POS form. So 0 is nothing but here B, so just this is nothing but B, and what is common here, this one, and 1 is nothing but here D bar. So what you will write? Sir, B plus D bar, B plus D bar. This is the important thing. How you are going to write POS form? How you are going to write POS form? Clear my point? So here in this 2, here common is 0, 0 means B, and here common is 1, 1 means this is D. So 1 you will write in POS form, that is the D bar. So B plus D bar for this. So now for this 4, if I am going to write in second bracket, here common term is again 1, 1 means here B bar, and here common is, you can say 0, 0 means this is D. So this is B bar plus D. This is second term. Now come to the next term. If I am going to take this 0, if I am going to take this 0 with here, so here this common term is A plus B bar. So in third bracket, this is A plus B bar, and in this 2, here what is the common? This is C, A plus B bar plus C. Now the last one, here this is A bar plus B bar, A bar plus B bar, And what is the here common term? 1 means this is C bar. This is C bar. So if you will write any answer, if you will make this 0 with here, this 0 with here, so only the variable will be changed, but number of literal will be same. So here number of literal 2, this is 2, this is 3 and 3. 6 plus 4, 10. So again you are getting here number of literals is equal to 10. So why we study POS and SOP? So this is the important point. Sometime POS will give you better result. Sometime SOP will give you better result. That's why examiner will ask you write down the minimize function of a POS form. Write down the minimize boolean function in SOP form. So what is this answer? This answer is again minimize. This is a minimize form. This is a minimize form, but which form? SOP or POS? POS. So at least you have to find out both the form from any K map. So examiner sometime will ask SOP, sometime examiner will ask POS. But now the important point, if you are making a group from POS, don't write PI and EPI. So here in this form, we will not discuss PI and EPI. This is the important point. So here already I have discussed PI and EPI. Here I have discussed this number of literal, but here you cannot discuss which one is PI, which one is EPI, because your answer will be different. Why answer will be different? Sir, this group is necessary. Yes, this group is necessary. So this is necessary group, this is necessary group. So here these two are the EPI, but here, sir, this is not necessary, this is not necessary, but all are PI. So if you will tell me the answer from here, sir, this is PI, 4 PI, but only these two are the EPI, and from here 3 PI and 3 EPI. So answer will become conflict. So one thing you remember, PI and EPI will only define for when you are making a group for one. It means that will define for minimized SOV form, that is not defined for POS form. Clear this point? So here examiner can ask you two category of question. First category of question, examiner will provide you K map and they will ask you what is minimum number of PI and how many number of EPI. So you have to form a group from one. Examiner can ask you minimum number of literal. So you have to find out SOP form and you have to find out PS form, and in this two, where you are getting minimum number of literal, that will be the answer. Now third question, examiner can ask you what is a minimized form and they can provide you 4 options. In all the 4 options they can provide you POS form. So sometime in GATE exam, in all the 4 options you will get POS form, but in generally student will find SOP form, and when after calculating they will see, oh, here SOP we have find it out, but all the 4 options given in POS form. So first you have to check all the 4 options. So either they will provide you all 4 options in SOP form, or they will provide you all the 4 options in POS form. Sometime 2 options is SOP, 2 options is POS. Also they can provide you. So here MSQ question easily can be framed. So in this topic, MSQ question easily can be framed. They can also provide you this answer and they can also provide you this answer. Both answer will be correct. Both answer will be correct. Both answer will be correct. Clear this point? Both answer will be correct. So I hope what is PI and what is EPI. From where we will discuss PI. Okay. From where we will discuss EPI. This thing should be very clear. So now from 1K map to answer you can find out. If you are making a group of 1, you have to write SOP form. If you are making a group of 0, you have to write POS form. Okay. Then we will check. Now one important thing. This is SOP. SOP circuit already we studied, implemented by NAND gate, and this POS implemented by which NOR gate. And you are getting here number of literal 10. Here you are getting number of literal 10. So we can assume same size of circuit is required. Then which will be better? If same size of circuit is required, then definitely we can move with NAND gate. So this circuit in real life we will implement. I hope this problem is clear too. Now the next problem, one more problem I am going to consider. Okay, one more problem I am going to consider. Okay, next problem. Okay, so next problem, everyone ready for the next problem? Okay, and this you have to give me the answer. Now the next problem. Now the next problem. Now the next problem. Here this is A B C D. A B C D. This is 0 0 0 1 1 0 and 1 1. This is 0 0 0 1 1 0 and 1 1. Okay. Now here suppose this is 1 0. This is second 0. This is third 0 and this is fourth 0. Okay, this this is not 0, this is 1. In this place this is 1, in this place this is 1, in this place this is 1, in this place this is 1. So now I am asking you 4 questions. First question, number of PI. Okay, second question, number of EPI. This is second question. Okay, and always PI means this is minimum number, so that you have to give the correct answer. So always examiner will tell you minimum number of PI. If they will not tell you minimum, so it is understood this is minimum number of PI, so that you have to give me the perfect answer. Okay, now then which PI is API? Now the next answer, here SOP form, minimize. Which SOP form? Minimize. Then here POS form, minimize. Okay, then here number of literal, here number of literals, and here number of literals. This you have to find out. Then which will be better? So which is better? Which one is better? SOP or POS? So here SOP will be better, means which circuit you will implement. So already this is one. So can I write, this will not make a group with anyone. This is single. All the one are single group. So what I can write here, so this is function A B C D is nothing but, this one is nothing but, I can write A bar B, and from here C bar D bar, plus what is this, sir? This is A bar B, and from here, sir, this is C D. And now the next, from here this is A B bar, and from here this is C bar D bar, and from the last this is A B bar, and from here you can write this is CD. Can I write? Now which one is PI? Sir, this is PI, because no alternate answer is possible. This is PI, sir, this is PI, and this is PI. So how many PI is given? This is 4 PI. Which one is EPI? Every answer is 100% necessary. So this will be EPI, this will be EPI, this will be EPI, and this will be EPI. All will be EPI. Okay. Sir, how many number of literal? Here 4, here 4, here 4, and here 4. So total 16 literals. So PI and EPI answer always you have to give me from SOP. So this is a minimized SOP form. Can I write? This one is minimized SOP form. Okay, now so here first answer is number of PI. How many number of PI? 4, and all the 4 PI is EPI. Now in SOP form already you have find it out, number of literals is 16, and this minimized form you have find it out. Now the next, now you have to find out, can I remove this? Yes, this 1 1 1 1, and in the remaining place you can put 0 0 0 0. So here you will get 0 0 0 0, here you will get 0, here you will get 0, here 0 0 0 0, and here you will get 0. Can I write? So remaining place you can put 0 0 0 0. Now you have to make a group of 0. So you can see, if you are targeting this 0, so this 4 group you can form. Yes. If you are targeting this 0, so this 4 group you can form. Only one answer is possible. Yes. If you are targeting this 0, so only this 4 group is possible. Yes. And if you are targeting this 0, so this 4 group is possible. So here you are getting 4 number of group. What will be the answer? So this is function f A, B, C, D. So what answer you will get? This 4 group you can write from here. This is POS form you have to write. So what will be the answer here? A plus B in first bracket. Okay. Now if you will write this, sir, this is A bar plus B bar. A bar plus B bar, this is second bracket. If you will write this vertical, this is a C plus D bar. This is C plus D bar, third bracket. If you will write from here, sir, here this is C bar plus D. C bar plus D. So now the important thing, you don't talk PI and EPI from POS form. First important thing, this is nothing but a minimized POS form. This is a minimized POS form. This is minimized POS form. Okay. Here you don't talk PI and EPI. Already this answer you have found it out. Here number of literal 2, 2 and 2 and 2. How many number of literals? 8 literals. 8 literals. In general, here 16 literal, here 8 literal. So we can think this circuit can be better. But when you are going to realize the circuit, then exact answer you can tell me. That's why in GATE exam they will not ask you which will be better. Which will be better. But just for your knowledge, I am saying which one is better. So how you can say where minimum number of literal. So here POS is better. So what I will say, POS is better. So sometime POS is better, sometime SOP is better. That's why we study POS. Somebody are thinking, sir, all the circuit is implemented by NAND, then why we are studying POS? Sometime POS circuit will give you better answer, smaller size of circuit. So this size of circuit will be bigger, and here you will get a smaller size of circuit. This is the important. This is the importance of POS. So I hope this thing is clear to all of you. Okay, I hope this thing is clear to all of you. I hope this thing is clear to all of you. So please just confirm me once. So please just confirm me once. Okay, this thing is clear to you or not. So first please confirm me this thing is clear to you or not. Okay, clear? Okay, now. So now here one important thing I want to discuss with you. Okay, one important thing I want to discuss with you. Okay, now one next question I want to discuss with you. Okay, next question. I hope this thing, then I will also discuss don't care here. Okay, don't care I will also discuss. Okay, now one more next question. Now one more next question. Okay, then after I will discuss some question from don't care. Then I will discuss one question from don't care. Okay, now. So here suppose next K map if I am going to provide you, again this is a 4 variable K map. Again this is a 4 variable K map like this K map is given. Suppose this is A, B, C, D, 0 0 0 1 1 0 and 1 1. This is 0 0 0 1 and this is 1 0 and 1 1. Suppose this thing is given. Suppose this thing is given, and this answer you have to provide me. Okay, suppose here this 2 0, here this 2, sorry, this 2 is 1, this is 1 and 1, this is 1 and 1. Suppose this is 1 and 1 and this is 1. Okay, suppose this 1, this 2 and this is 3. Okay, and here suppose this is 1 and suppose here this is 1. Suppose this 4 group is given. Suppose this 4 group is given. Suppose this sorry, here 8 number of 1 is given. Now my question again here, number of PI, and this answer you have to give me, and number of EPI. Number of EPI. Okay, this answer first you have to tell me how many number of PI and how many number of EPI. How many number of PI and how many number of EPI. How many number of PI and how many number of EPI? Tell me. How many number of PI and how many number of EPI? And if you can give me correct answer, it means now you are comfortable in PI and EPI. Okay, then we will discuss here minimized SOP form, then minimized SOP form. Okay, and number of literal, and then we will discuss minimized POS form, and then we will discuss minimized POS form. Okay, I am waiting for your answer. I am waiting for your answer. Okay, first answer only I need. Sir, PI is, you can write 4 5 6 3 2, and EPI is like this. It can be 0 also. Okay, PI cannot be 0. PI cannot be 0. Okay, in any K map. In any K map. Please tell me. I am waiting for your answer. I am waiting for your answer. I am waiting for your answer. Okay, 3 EPI, 4 PI. No, no. So here you are wrong. Okay, why? You can see here. So this one can be form a group with here. Okay, now yes, but this one can also be form a group with this one. Now this one can form a group with this one. Yes, this one can form a group with this one, and this one can form a group with this. Is a suppose student number 1 answer. This is student number 1. Now another second student. Second student answer is suppose like this. Suppose second student answer is like this. Suppose second student answer is like this. This is A, this is B, this is C, D, this is 0 0 0 1 1 0 1 1, this is 0 0 0 1 1 0 and 1 1. Now the second student, suppose this is 1 1 1 1, this is 1 1 and this is 1 1. Suppose second student are making group, sir, these two, this two, this two and this two. Okay, now and this is student number 2. Okay, both the answer are correct. In both the case, how many number of PI? Sir, 4 PI. Yes. How many number of PI? Sir, 4 PI. Which will be EPI? All these 4 PI will be different from this 4. So here 0 EPI. So what will the answer? Sir, this is 4 PI and 0 EPI. This is the answer. So here number of EPI is 0 because all that alternate answer is possible. So if you are considering this one, but this can be form a group with this one. So this group is not a EPI. This one can form group with this one and also this one. So here 2 alternate answer is possible. So here what we can say in any situation number of PI will be 4. So if this category of question will be framed by the examiner, so what they will ask you? They will not ask you the answer because 2 different answer can be possible. Here 2 different answer can be possible. So what is the first answer? So here function f, this is a, b, c, d. So what is the first answer here? What is the first answer here? So we can write this. So this is a bar, b bar. This is a bar, b bar, and from here this is c bar, plus from here this is a bar, b. This is a bar, b, and here which term is common? This is d. Plus what is the third term? From here a, b, and what is the next term? From here this is 1 means this is c, plus what is the last term? This is a, b bar, and what is the common term here? This is 0 0, this is d bar, this is d bar. This is a function ABCD. First answer. So this is PI, this is PI, because you have formed a perfect group PI, but which one is the EPI? No one is the EPI. So here EPI is 0. Okay, how many number of literals? 3 3 3 3. So this is 12 literals. This is student 1 answer. Student 1 answer. And sir, EPI will be all the group having alternate answer. So this group having alternate with here. 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 So all the group having alternate answer. So already I tell you, if 100 students will write the answer for this K-map, and which PI is common in all the answer, that PI will be only API. Now the second student answer. The second student answer will be here. This function A, comma B, comma C, comma D. What you will get here? So you can write here. The common term is here 0 0 means B bar. So this is B bar, and from here C bar, D bar. First, this second one you can write here. This 0 is common, means A bar, and you can write here C bar, D. And now you can write from here. This is 1 is common, means B is common, and from here you can write C, D. And what is the last term? From here you can write this 1 is common, means A is common, and from here this is C, D bar. From here you can also write which one is PI. Sir, this is PI. This is PI because this is a perfect size of group. This is PI, this is PI. but no one are API. No one are API. So here two answer can be possible. So this category of question, if you will get in GATE exam, so examiner will not ask you this function. Examiner will ask you number of minimum PI, and here how many number of laterals? Laterals is equal to 12. So student 1 and student 2, if anybody will ask you which answer is better, both answer is exactly same. So here you can see this 3 size of 4 group, 3 size of 4 group. So exact answer in circuit point of view exactly same, but variable point of view only different. So one student are using different variable, but result is same, and second student are using different variable, but result is same. So sometime the meaning number of answers can be possible. Sometime meaning number of answers can be possible. Clear this point? So here number of PI is 4, number of PPI is 0. So what is a minimized form of SOP? We have find it out. So if in the same question, if examiner will ask you what is the POS form, minimized POS form, so what can be the answer? So at least one answer you can write. So now I am going to find out POS form. Clear this point? Sir, what about don't care condition? Yeah, we are waiting. Okay, after that next question I will take from don't care. Okay, wait for that. Just wait 2-3 minutes. Okay, suppose if in this question, I hope this thing is clear. If in this question you have to write POS form, if in this question you have to write POS form, then what will be the answer? Sir, this is A, B, C, D. This is 0, 0, 0, 1, 1, 0, 1, 1. This is 0, 0, 0, 1, 1, 0, 1. But this 0, 0, 0, 1 is not SOP form. This is POS form. So one thing you remember, this 0, 0 meaning is, sir, this is C plus D. Sir, this is C plus D bar. This is C bar plus D bar. And this is C bar plus D. And in SOP form, what you will write, this 0, 0 means this is C dash D dash. And this is C dash D. This is C D. And this is C D dash. Are you getting this difference? But always I will write like this. So this is your choice what you want to write. You want to write like this, or if you want to write like this, or you want to use only 0, 0, 0, 1. If you will use 0, 0, 0, 1, 1, 0 and 1, 1, it will save your time, but meaning should be very clear. If you are going to write SOP, so you have to use this term, and if you are going to write POS, you have to use like this. But directly I can apply from 0 and 1. So if you are going to write SOP, you can consider 0 to suppose A bar, and if you are going to write POS, you can compare A with A. Are you getting? And in SOP form, 0 means A bar, and in POS form 0 means A. Clear this thing? So now just you can put here, sir, this is 0, this is 0, this is 0, this is 0, here this is 0, this is 0, here this is 0, this is 0. So it can be possible. Here again two answer can be possible, but you can check. If you are targeting this 0, so sir, this is first group, two group is possible. Sir, for this 0, one group, two group, so again two group. So any group you can consider. So just I am considering this two groups. So this 0, 0, 2 group, this is third and this is third. So again you are getting 2, 2, 2, 2. So again here literal. I am not going to write the function. If you will write this is 3 literal, here 3 literals, here 3, 3, 3, 3. So in this answer again you will get 12 literals. So here number of literals is same. Literals is same. So sometime in SOP and POS you will get same number of literals. So we cannot compare which circuit is better. So in that situation always we prefer SOP form. Okay, sometime you will get 2-3 number of different answer in SOP form also. I hope this problem is clear to all of you. I hope this problem is clear to all of you. Now one good question I am going to ask you. Clear this? So here many you are wrong, sir. Number of EPI and PI. So here number of PI and EPI is correct. This is 4 PI and 0 EPI. From here you don't talk about PI and EPI. This is the important thing. I hope this thing is clear to all of you. Now one more question I am going to ask you. One more good question, very good question. If I am going to ask you, now note down the question, and this answer you have to give me. For 4 variable K map, maximum number of maximum number of pi is equal to question mark. This is a previous year gate question. So they can ask you for n variables. So first you have to answer for this. Then our answer is for n variable. For n variable K map, maximum number of pi is equal to question. This answer. So first you have to give me answer for this. So what will be the answer for this, and then what will be the answer for this? So maximum number of pi is possible for variable K map. Anybody can tell me the answer? Anybody can tell me the answer? Think about this and you can give me the answer. This is a previous year gate question. This is a previous year gate question for variable K map, maximum number of pi. Okay, so one answer is 8. One answer is 8. One answer is 8. Okay, good. How you can think? So if examiner will ask you this kind of question, just you can already, we have studied zigzag form. Zigzag form will give you. So if this is ABCD, so zigzag form will, so here two answer can be possible. Sir, like this. All the zigzag form. So this is 1, 2, 3, 4, 5, 6, 7, 8. Second answer here you can put. So here two answer can be possible. Now if you will think, sir, if I will put anywhere one extra, so yes you can put. If you will put one here extra, this will be form a group. Only here only one pi is possible. Clear this point? So maximum 8 number of pi is possible. So directly you can remember this is for 4 variable. For 3 variable, sir, how many number of pi is possible? So this is zigzag form. Just you should remember, already this question has been asked in previous year gate exam. So how you can write? This is nothing but, sir, 2 raised to power 4 by 2. This is 16 by 2 is equal to 8. So one formula we can create. What will be? Sir, 2 raised to power n by 2 or 2 raised to power n minus 1. Okay, so this is the, what will be 2 raised to power 3, that is 8. So here 2 raised to power n by 2 or 2 raised to power n minus 1. Okay, so but the condition when you are getting, so here two condition can be possible, either this or this. So two condition can be possible here. Two condition can be possible here. Okay, two condition can be possible here. Okay, two condition can be possible here. Now one more important thing I want to discuss here. Okay, one question for don't care, So next problem I am going to consider for don't care. Suppose one 4 variable K map is given and don't care examiner will provide like this. This is summation of mean, or they will write this is don't care like this. If they will write D, or they will write this is mean term of D. Generally they will write mean term of D, or only write, they will write don't care like this D. Suppose they will write don't care. Okay, so here this is a mean term. So don't care how they will write. They will write D. Summation represents mean term, pi represents max term, or D represents don't care. Clear this point? So now just I am going to take one example. Summation represent mean term. This pi represent max term. And D represents don't care. Clear this point? So suppose I am going to consider this is A, B and C, D. Okay, now here suppose K map is given. Suppose this is 1, 1, 1, 1, 1, 1, and here suppose this is don't care. This 2 don't care is given, and suppose here one more don't care given, like this given. Suppose this question is given. Okay, this question is given. So here this is 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0 and 1, 1. Okay, so what is a minimize Boolean function? Always one thing you remember, if don't care will be provided by examiner, so they are interested in SOP form, because here if SOP form and in POS form, answer will be invalid. So if you are going to write answer for SOP and if you are going to write answer for POS, so sometime answer can be invalid in one way. So that's why one important thing, if a don't care will be given, always examiner are interested in SOP form. Okay, so here SOP form is very important. So PI and EPI we will only discuss for SOP form. And now the second, if don't care they will provide you, they are only interested in SOP form. Clear this point? So here answer, we have to write this function a b c d. Which form you have to write? SOP form. So just you can see here. So what do you mean by don't care? So don't care can be treated by either 0 or can be treated by 1. So according to our convenient. So don't put all the don't care 0 or don't all the don't care. Some don't care can be 0, some don't care can be 1. So all the don't care is 0, all the don't care is 1. No. Some don't care can be 0 and some don't care can be 1. This is the important point. Okay, so now if you are going to form a group, if I am targeting this one, so this 4 group you can form. Okay, if you are targeting this one, so this 4 group you can form. It means you have not used any don't care in this question. So sometime any don't care is at least you have to use. This condition is not restricted here. So if this don't care is not beneficial to you, so if this don't care is not beneficial to you, it means what you are assuming here, it means this don't care you are not assuming 1, it means this is nothing but 0, this is nothing but 0, this is nothing but 0. So when you are not going to use don't care, that will be treated as a 0. So here none of the don't care are used. Okay, so can you write here boolean function? Sir, this k map you are getting here common term is b and here common term is c, and for this 4 this common term is sir a bar b. What is the answer here? What is the answer here? This is nothing but a bar b plus bc. A bar b plus bc. This is the answer. So sometime don't care is necessary to use. No, this is not restricted condition. Okay, now one more example I am going to consider. Suppose one more example I am going to consider. Suppose like this. One K map is given. One K map is given. Suppose this is AB, CD. This is 0 0 0 1, 1 0 1 1. This is 0 0 0 1, 1 0 and 1 1. Suppose here, here this is 1. Here this is 1. Here this is don't care. Here this is don't care. Here this is 1. Here this is 1. Here this is don't care and here this is don't care. Suppose this K map is given. Suppose this K map is given. Okay, sir, up to which topic you will be teaching? Yeah, today we are teaching only this till this topic. Okay, K map. Okay, today only we are going to deal. So next 10 minutes only, and after next 10 minutes we will finish. So after next 10 minutes we will finish this, and tomorrow then we will start combinational circuit and sequential circuit. Tomorrow I will discuss combinational circuit, sequential circuit, and then I will try to discuss the setup time, hold time, and ADC and DAC and ADC and DAC. Let's depend on the time. But don't worry, I will take definitely classes for setup time, hold time, and ADC and DAC. Okay, now so here you can see if you are targeting this one, sir, this 4 group can be formed. Yes, this 4 group. And if you are targeting this one, this 4 group can be formed. So here all the don't care is treated by 1. So here this all the don't care you are treating 1 1 1 1 and 1. So sometime all the don't care can be treated by 0. Sometime all the don't care can be treated by 1. Sometimes some don't care can be treated by 1 and some don't care can be treated by 0. Okay, so what will be here answer? So this function a b c d. So here function a b c d is nothing but this 4 group. Here common term is b and here common term is d. And now what will be all this 4 corner? This is b bar and here this is nothing but a d bar. This is the answer. So this is the nothing but a b XOR d whole bar or b XOR d. This is the answer. This is the answer. One more question I am going to take. One more question I am going to take. Okay, so here I have considered 2 questions. In first question, none of the don't care are used. In second question, all the don't care are used. Now the third circuit. Now the third circuit. Now the third circuit. Now the third circuit. Okay, now here this is A, B and C, D. This is 0, 0, this is 0, 1. This is 1, 0 and 1, 1. This is 0, 0, 0, 1, 1, 0 and 1, 1. Now in the next circuit, suppose for example, here this don't care is given. Here this don't care is given. Suppose here 1 is given. Here 1 is given. Here don't care is given. Here don't care is given. And now suppose here don't care is given. like this. Okay, this thing is given. Then you can see only 2 1 is given. You can form a one group, only one group. It means you are treating this is 1, you are treating this is 1, this is 0, this is 0, and this is 0. So here 2 don't care are treating as a 1 and 3 don't care are treating as a 0, So what will be the answer here? So this function a, b, c, d, this function a comma b comma c comma d is nothing but only one answer. Here common term is b and here common term is c. This is the answer. This is the answer. This is the answer. Okay, sir, can I treat don't care as a 0 here? Can I treat don't care as a 0 here? Now, one more thing I want to explain here. Okay, so here this don't care is nothing but 0. This don't care is 1. Here all the don't care was 0. Here this don't care 1 1 and this don't care 1 1. So what is the use of don't care? What is the use of don't care? Don't care represents. So just I want to tell you one example. I hope this thing is clear now. Now, can I remove this? Yes, can I remove this? Suppose just I want to tell you, sir, what is the exactly definition of don't care and how we can use. Suppose for example, we have one truth table. This is decimal value. Okay, decimal, and here this is ABCD. ABCD. Okay, and our circuit is divide by 3 circuit. So our function is divide by 3 circuit. So divide by 3 circuit. Okay, and this is only decimal value, one bit. So means 0 to 9. So just I am saying divide by 3 circuit, and this is BCD. And this is BCD. So this is decimal 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So till 9 practically these are the BCD number, yes. And in ABCD you can write, sir, this is 0, 0, 0, 1 till you can write 1, 0, 0, 1. Now here I can write 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, and this is 0, 1, 1, and 1, 0, 0. Okay, so divide by 3 circuit, 0 will divide by 3, yes. So here one, this will not divide, this will divide, this will not divide, this will divide, this will not divide, this will divide. But here in BCD, this 1, 0, 1, 0, 10, this is 11, 12, 13, 14, 15. This is an invalid input. So this is 1, 0, 1, 1, 1, 0, sorry, 1, 1, 0, 0, 1, 1, 0, 1, 1, 0, and 1, 1, 1, 1. Okay, so practically all these are invalid input. Invalid input. So first you should know what do you mean by don't care. Don't care represent that input is not valid. So here this 6 input is not valid. So when you will not provide input, will you get output? No, sir, output will not be possible. If input you will not provide, then how you will get output? So when input is invalid and this input is not available, you can say this input is not available. Not available. If this input is not available, it means what will be this output? You can assume anything, because if you will not provide input, then what output you will get? Output will not be possible because input you will not provide. So when input is not possible, or you are not going to provide an input, that output you can write don't care. That's why the name is don't care. Generally what a student feel, for this input output can be 0 or 1. No, none of the circuit will provide you 2 output. None of the circuit in digital can provide 2 output for 1 input. Are you getting my point? If we have one digital circuit, suppose for example, and here this is 4 input, and if here suppose 1 1 1 1 I am providing, can you tell me output can be 0 or 1? Can you tell me? No, output will be either 0 or 1 if input is possible. Are you getting? So don't care represent. If I am writing here don't care, why I am writing? Because you have to complete truth table. So for 4 variable complete till 16 means 0 to 15, you have to write truth table, and in K map every value you have to write either 0 or 1. Are you getting my point? So what don't care represents? Don't care represents that input is not possible in the circuit, and you are committing that input you will not provide. Are you getting my point? It means if here this is don't care, this is a min term 1, it means in this circuit this input you will not provide. So if you will not provide, so anything you can assume here. So if this input you are not providing, so here you can assume anything. This is your choice. Either you can assume 0 or you can assume 1. So what we will write here, we will write don't care, and then for minimization of function, if that is using SA1, we can assume that SA1, and if if suppose that is 0 required, so you can assume that SA0. So this is your choice. So first you should know what is the meaning of don't care. I hope this thing is clear. Many times students are getting wrong definition. They think wrong definition of don't care. What they think, this is the input, and for this input output can be either 0 or 1. No yaar, how it can be possible in digital circuit? For one input, how two output can be possible? Output you cannot say it can be 0 or it can be 1. How? It cannot be. So don't care represents for that mean term you are not providing the input. So if I want to find out minimize function for this, so now my question is, what is this is a previous year gate question. This is a previous year gate question. So what is a minimize boolean function for? What is a minimize boolean function for divide by 3 circuit? So now the question is, what is the minimize boolean function of minimize boolean function of divide by 3 circuit? Divide by 3 circuit. Okay, and input is BCD. Input is a BCD number. So if input is BCD, or you can say single digit, or you can say this is a single digit decimal. So single digit decimal means till 0 to 9, or BCD means till 0 to 9. So this will be the truth table. So what will be the K map? So just you can write here K map. Just you will write here K map like this. Here this is K map. You can write here, sir, this is AB, this is CD, this is 0001, 1011, this is 0001, 1011. Then you can see, sir, 1 where you are getting at 0, at 3, at 6, and at 9. 0, 3, 6, 9. So this is 0, this is 1, this is 2, this is 3, this is 4, this is 4, this is 5, this is 6, this is 7, this is 8. You know this thing for 4 variables 0, 1, 2, 3, 4, 5, 6, 7. This is 8, 9, 10, 11, 12, 13, 14, 15. I hope you remember this thing. So this is 0, 1, 2, 3. This is 4, 5, 6, 7. This is 8. This is 9. This is 10. This is 11. So 10, 11, 12, 13, 14, 15 is the don't care. So you can put the don't care. So now which group you have to form here? So you can see, sir, this one. So this one can you form this 4 group? Yes, sir, we can form this 4 group. It means you can assume this as a 1. You can, because anything you can assume, because that input is not possible. So that will reduce the circuit. Okay, now if you are targeting this one, so this will be single one. Okay. If you are targeting, sir, this one, so again this 2 group can be formed. Yes. If you are targeting this one, sir, this 2 group can be formed. So how many PI you are getting? Sir, this is 1. This is second, this is third, and this is fourth. So fourth term you are getting. So what is a function? This ABCD, and the name of the circuit is the divide by 3 circuit. Similarly, you can also design divide by 2 circuit. You can also find even number. Suppose if you want to find out even number, so even number 0, 2, 4, 6, 8, that will be 1, remaining will be 0. So anything you can design. Okay. So now what will be the answer here? First I am going to write this one. So this is nothing but so A bar, B bar, C bar, D bar. This is A bar, B bar, C bar, D bar. Now I am going to write this 4. This 4 is, here this common term is A, and here this common term is D. So this is AD. Now the second term is AD. Now the third term is, if you are considering this 2, so here common term is B, and here common term is CD bar. So B, C, D bar. This is B, C, D bar. And what is the last term? So here this common term is, for this here common term is B bar, and here this is CD. So B bar CD. So plus B bar CD. This is the answer. This is the answer. This is the answer. Or divide by 3 circuit. If you will not consider here, don't care. Then here number of literals will be more. So here this is 4 plus 2 6, 7 8 9 10 11 12. 3 plus 3 6, 4 plus 2 6. This is 12 literals. So how many literals you are getting? So when it is not necessary, if a 4 variable function, so all the 16 input is possible in the circuit. Sometimes some input we don't provide in the circuit. Sometimes some input I don't provide in the circuit. So for that input, output will be treated as a don't care. So I hope the meaning of don't care is clear to you and how you can handle this don't care. So in this question, this don't care, this don't care, this don't care, this don't care, you have considered 1. This don't care and this don't care, you have considered 0. Clear this point? So just confirm me. Just confirm me. So, okay, just confirm me. This thing is clear to you or not? Okay, so just confirm me. This thing is clear to you or not? The previous year question. What is the minimized function of divide by 3 circuit? Practically this question from the combinational circuit. But combinational circuit is nothing but just you to write a truth table. You can put over the K-map and you can write the Boolean function. So this is the best example for don't care, and I hope I have explained the meaning of don't care. Okay, so if you are writing at output don't care, it means for that input you cannot apply in the circuit. That is a meaning of don't care. Clear this thing? So just confirm me. Now the time is 12:17. Okay, so tomorrow we will continue. So I hope today I have discussed in number system, just I have one method I have provided you. Then we have discussed many things in the logic gates and many things in the this Boolean algebra and K-map. Okay, so I hope each and everything we have discussed here. Okay, now tomorrow onwards I will start combinational circuit. That is the easier topic. Many number of things we have to discuss in combinational circuit. Then we will start sequential circuit. So tomorrow and after sequential circuit, we can also finish ADC DAC. So maybe tomorrow we can finish till ADC DAC. If it will not be finishes, so at least combinational circuit and sequential circuit we will finish. And one more class I will conduct, and in that class I will discuss ADC DAC setup time, whole time. Okay, so everyone. Okay sir, good night, take care sir. Tomorrow we will start. No, tomorrow we will start from 5 p.m. If any another classes will be happening global, if any another classes will not happen in global, then I will start from 4 p.m. Okay, but don't worry, combinational circuit will not take much time. Sequential circuit I will give you much time. Okay, so that you will more comfortable. Okay, so if anybody have any doubt, ask me. Otherwise, I am going to end the today session, and tomorrow we will again meet. Okay, so if anybody have doubt, no doubt. Okay, tomorrow we'll meet. Thank you. Take care. Bye bye. Good night. Jai Hind.